Ladies and gentlemen, thank you for coming. We'll be starting in 5 minutes. If you can take your seats. If you can take your seats, we're starting in 5 minutes. Thank you for being here. Two minutes, folks. 2 minutes. Please take your seat. We're just about ready to begin. 2 minutes. Thank you again for being here.
Hello, everyone. Welcome to Chrome Dev Summit. And hello to everyone who is joining us on the live stream. There's the camera there. You survived the Techno Fitness Center hold music, so congratulations for that. We've been listening to that on loop for an hour here, so I kind of got more energy than I know what to do if I kind of want to go for a run. Right, before we get properly started, let's get the admin stuff out of the way. In the event of a fire, it's pretty simple, right? The fire exits are behind you there. Pick the one that isn't on fire. It's the best thing to do. And one of the things that we have in this conference, we've got a code of conduct, which I believe is an important part of any conference, so that's worth checking out, especially because the rules on there also apply to the fire, should there be one. So, do not harass the fire, do not shout abuse at it, and definitely don't give it any unwelcome sexual attention. That will not work out well for you at all. If there isn't a fire, don't worry about it. That's actually normal. Try and leave things like that, and things will progress much better. If you're watching on the live stream and there's a fire where you are, you're on your own. Just try and survive, please. So yeah, this is Chrome Dev Summit 2, the sequel. They let us do another one, and like all sequels, it's going to be better than the original. I think in terms of sequels, we're kind of in a real Terminator 2 situation right now, like where there's this kind of dystopian vision of the future where native apps have fully taken over and they're sort of walking on the skulls of dead websites. But the rest of the story, which you're going to hear over the next couple of days, is what we're doing to ensure that future doesn't happen, where Chrome is John Connor, and we've teamed up with a friendly android, see it works, to save the web. So coming up now to give us a proper intro to Chrome Dev Summit Judgment Day, one of the many people speaking at this event who can fire me at any point, or give me a promotion. We could give that a go. We could go either way. It's the VP of Engineering for Chrome. It's Darren Fisher.
Thank you so much, Jake. I'm really happy to be here with you guys today. It's really exciting. We have a lot of fantastic material for you, all focused on what we're doing with Chrome and what we can do to try to make the web much better, especially on mobile. Let me see. Tried the clicker. Slides are not advancing up there. I see the slides here. I don't see the slides up there. And we try again. Wow. One moment. Trust me, it's a really awesome presentation. I'm looking at something here. There we go. All right, it's working. It's early. Thank you all for coming out. Let's get right to it. So at I/O earlier this year, we got to announce that we have 300 million Chrome on mobile users. This is fantastic. It actually represents a 10x growth over a year earlier. I mean, Chrome is actually relatively new on mobile. Today, I'm really pleased to announce that we have 400 million users of Chrome on mobile. This is fantastic. Just in the last 4 months, we've seen this kind of spectacular growth. I think this is really fantastic, not just because I'm working on Chrome and want to see it be successful, but also what it means for the mobile web. I think a lot of times developers struggle with trying to reach users through browsers that are old, not updating, and there's just a lot of disparity across the mobile web and across the mobile ecosystem of the types of browsers that are out there. So as we get Chrome out there more, developers can start to count on a more consistent web platform, a more modern web platform, one that's auto-updating, one that's fast and it's getting improved. And I think this is fantastic for what it means to web developers trying to reach users through browsers. Anyway, so in addition to just trying to reach users through browsers, a lot of web developers are looking at trying to reach users through native apps, obviously, and using web tech in native apps. And for a long time, they've struggled with the fact that the web views are old. And as a Lollipop, I'm really pleased to announce that we have support for auto-updating WebView. This is fantastic. It means that for the first time, this was a long time coming, to be honest. I think it was 2 IOs ago where we were talking about how badly we wanted to get this done. Getting it to the place where when we update Chrome, we can also update WebView is fantastic. I think you all understand this, but just having a consistent modern platform that you can take advantage of, both when deploying over the web as well as through your native apps, it's huge. I think that you know, a lot of times people take for granted that they have a modern web platform. That's the sort of the mindset people are in when they're focused on desktop, but it hasn't been the case on mobile. And so getting to a place where it is, it's a huge accomplishment. Now, we have been very busy over the past year. This is a set of features that we've been working on that have all landed in the last year, and just a whole lot of different work that's gone in to make Chrome and the web platform better. We've been working with other browser vendors to bring a lot of new features, things that improve the capabilities that you get access to, things that allow you to take advantage of mobile, stuff like simple things like screen orientation and the ability to lock the orientation of the screen to portrait or landscape. These things go a long way to helping you deliver a great experience through the web. But also features that allow you to have a much better time creating a good user experience, a good performant user experience. Simple things like the will change attribute that lets you inform the engine that, hey, this is the kind of animation I will be making, allows the engine to make a lot of optimizations for you. But that's not it. There's a lot of other things here. Features like web animations that give developers a lot more control over the animation system rather than forcing you to cobble together CSS strings to generate the kind of animations you want. We've also put a lot of work over many years to build up a set of features that powers web components. Things like custom elements, HTML imports, and Shadow DOM. And all of these things are now shipping natively in Chrome, which is just fantastic because it means that as you're using toolkits like Polymer or just other toolkits that leverage web components, you're getting a native implementation of those features. There's too many things to mention here. I'll just say in addition to features, we've been very focused on performance, optimizing the engine, improving performance, reducing CPU load, et cetera. These are things that are just very important for developers who are trying to create a great experience. One feature I really want to call attention to is something that we actually removed from the platform a little under a year ago. It used to be that when a user would tap on the browser, there would be a 300 millisecond delay while the browser was trying to figure out, did the user mean to click on a link or are they trying to zoom, et cetera. Removing this allowed developers to have much more control over animations and be able to provide much smoother experiences. So I think, yes, this one deserves a round of applause. It was actually a heroic effort to get there, but it's fantastic that we can now take for granted that you don't have it. So with all this great work that's happening, it seems like the mobile web is awesome, right? Well, you commonly hear this meme. The stories are rolling out all the time about native apps killing the mobile web. The demise of the mobile web seems imminent. Shouldn't we all just be writing native apps? Well, I think the story is actually a bit more nuanced than that, a bit more interesting if you dig down. We think there's actually a lot of value to the mobile web if you start to explore it further. There were some studies earlier in the year by Flurry that showed that time spent on mobile is actually heavily biased towards native apps, and very little time spent on sites. But you have to sort of explore this a little bit further to see what's really going on. In fact, the time spent in native apps is dominated by activities like gaming, entertainment, and social. And time spent with other activities, well, it's much smaller. So it's only part of the picture. And indeed, if you look further at the time spent on mobile, actually, of that vast majority of time that was spent in native apps, it's really dominated by just a few native apps. And as a developer trying to reach users, writing a native app doesn't mean that suddenly you're getting a lot more attention. In fact, I'd argue that in many ways it's easier to get attention if you're deploying through the web. In fact, if you're specifically going after commercial activity and you talk to users and you say, how do they use their mobile devices when they're interested in shopping or e-commerce type activities, users resoundingly talk about how they use the web. And this kind of makes sense. You think about it, how many store apps do you actually install? Well, you might. You might have installed, say, the Amazon app, but actually when you're going shopping, you're doing a lot, you want to do a lot of comparison shopping, you're going to do searches and so on, and be looking for best prices or doing comparison shopping across different sites. And actually, the web is really good at this. And indeed, it's actually really good at helping users find interesting things. And as a developer trying to reach users, and there's just a lot of power here. So what makes the web ideal for success? There's a lot of things, and I want to get into that a little bit further. I think one of the biggest things, this is very obvious really, it's just that the web, when you put things on the web, there's a lot of tools that help you make your content, your apps, discoverable. There's a lot of great tools. Obviously, search, I work at Google. Search engine is a very powerful tool that can drive traffic to websites. Ads can drive traffic to websites. Social media can drive traffic to websites. A lot of this is powered by URLs and the indexability of content and all of the great tools that are available for SEO and so on. These things enable users to easily find things, but they can also easily share things. And it's not just your application or the entry point to your website, but it's deep linking into your websites, particular pieces of content or particular states of applications. Developers have an easy time presenting these things as URLs, and users have an easy time sharing them and discovering them. This is actually a very powerful feature of the web platform. It's a fantastic way to deploy stuff and get it in front of users. And the web platform, in addition to having that discoverability and that reach, it's actually very, very comforting to a user if they're given a URL. Clicking on a URL feels like a very safe action. It's not scary to someone. Whereas installing a native app, it's a bit scary. It can be. You're not sure, what are you giving up? You're accepting a battery of permissions and so you can imagine a lot of users feel a little bit unsure about that. But with the URL to a site, it's actually very safe. It feels safe. There's a history of browsers doing a good job protecting users. But all of this really leads up to the big benefit of the web, which I think is that it's a fantastically low-friction way for users to connect with developers, for developers to get user experiences in front of customers. The web is this ephemeral platform. There's no install prompts. It's very easy for folks to find things through search, through ads, through tweets and social media and such, and end up right there on a site, on a page where they can buy something, or where they can complete some transaction, or they can do something that they were interested in doing. So there's a lot of upside if we can get to a place where you can create great experiences on the web, because there's all this fantastic environment that can maximize what you can get out of it. So that's all very exciting. Like I said, there's a lot more that we need to do, because in this day and age, people are very excited about native apps. The web itself has been this platform that hasn't worked great on mobile. Everybody's pretty aware of these problems. There's a variety of problems from, performance problems to, it's hard to take advantage of mobile devices and create great experiences, to frustrated with, buggy browsers and such. So there's a lot of work that has to be done to make the environment better, but we're getting there, and there's a lot that we're doing. So I want to talk about some of those things. But first off, this summit's mostly about Chrome and what Chrome team's doing. Google Search just yesterday rolled out a really exciting feature, which is they are starting to badge websites in the search results that are mobile friendly. This is all something that you can explore further through Webmaster Tools. You can see the validation tool that helps you understand if your site is mobile friendly and so on. But this is all about helping users understand that if they're going to follow a search result, they're going to end up on a site that actually works or should work on their mobile device. That's not going to have Flash. That's not going to be a desktop-oriented site. It's not going to have very small text, et cetera. I think this is a very useful tool for both developers and users, and so I'm really excited about it. On Chrome side, our goal is really about helping developers be more productive, and to do that, we have a long history of, for example, making better developer tools. The DevTools has been a fantastic project. You're going to get to hear a lot more about that later today. We have done a lot of work to help you use DevTools on desktop to explore how your site works on mobile. on mobile devices, which is very useful. And a lot of work's gone into helping you understand animation performance and so on. And you can learn a lot more about that later today. We've also been doing a lot of work on toolkits and things like web fundamentals to help folks get started and orient themselves and understand how to optimize for mobile. I'm very excited about Polymer as a great reference toolkit for how to build fantastic websites that run well on mobile. You'll hear more about Polymer if you don't already know about it, but it's our expression of what we think a great framework can be. In addition to productivity, we're working a lot to make the engines faster and to help developers create more performant websites. We know that this is the thing that folks struggle with. The engines haven't always been tuned for mobile. They weren't designed for mobile originally. And so we've spent a lot of time just working on core rendering performance. A lot of this is about optimizing existing code paths, but moving workloads to GPUs. So we're rolling out GPU rasterization, which is really fantastic. Allows for web developers to take full advantage of the more capable GPUs that you find on mobile devices and relieve the CPUs of all the burden. And in doing so, reduce power consumption and so on. So there's a lot that can be done there. Ryan's going to talk more about performance, a lot of work going into V8, et cetera. But in addition to just optimizing the engine, we also want to do feature work that allows developers to have a lot more control over the platform. And in doing so, be able to have more control over where the expensive things happen and when they happen. And for example, when it comes to network resource loading, developers often struggle with the fact that the browser sort of feels like it's out of your control. If there's a network error, suddenly the user sees a browser error page. It's not a great experience. With the Service Worker API that we're going to talk a lot more about, you actually, among other things, you actually do get control over the network fetching and network resource loading and caching. It allows for developers to cope better with poor network conditions and so on, but also allows them to guarantee that when your application starts up, it actually loads quickly and reliably fast, assuming you've had a chance to populate your caches, which is great. I'm very excited about that because it really is one of these things that often developers suffer with when they're thinking about deploying over the web and over potentially poor network connections that people often have to deal with mobile. So anyways, in addition to all of that, we're trying to help developers provide a much more engaging experience on mobile. And here's where we're doing some really, I think, really exciting things, exploring how to, for example, allow you to integrate the web experience deeper into Android and allow it to feel like a more first-class part of the system. A while back, we rolled out support for Add to Home Screen, but we're working on exploring how to elevate Add to Home Screen so that users discover it more readily under the right conditions. I think this is a very important thing. I think a lot of developers are interested in the re-engagement that happens when you have a home screen placement, and this is something that's been difficult to achieve on the web unless users really knew what they were doing and went looking for it. In Lollipop, we rolled out support for exploding and moving the tabs of the browser out into the recents view so that web content rendered through Chrome would actually appear as a peer to native applications. This is huge because it allows a web developer to feel like their experience is not trapped within a browser, but rather it's a first-class experience on Android. And though these screenshots don't really show it, the one on the right emphasizes that you actually get a lot more control over the theming. And in addition to theming, you actually get a lot more control over the iconography. One of our goals with this whole user experience here was to try to put Chrome in the background and let the content take the stage. It's really important that we feel that developers, we feel that users, they think deeply about interacting with sites, not Chrome. It's important for them to understand that they're working with foo.com, not Chrome. And so we've done a lot with the system UI and Chrome's UI to try to help put the content first, help put the web applications first. And so a lot of this work that you see here is an effort towards that. Okay, in addition, there's also a lot of work going on with capabilities. And I already mentioned Service Worker and how it can help solve for offline and solve for poor network connections. That's just a fundamental thing that's been missing from the platform. We've had App Cache, but it's so limited and hard to use. Service Worker is much easier to use. On the back of Service Worker, we can do a lot of fantastic things, though. We can solve, finally, for background processing. We can enable developers to update their caches of content and code in the background so that when the user interacts with the site again, they're getting not just cached content, but they're getting fresh cached content. And you as a developer can have control over that. This is something that's under development. It's not done yet, but we're very excited about enabling background processing on mobile for web content delivered through the browser. Push notifications is something that we can also start to build on top of the service worker. And it's something that we are close to launching. And it's very exciting to enable developers to have access to push notifications because it allows for, again, another form of re-engagement. One of the things we're doing is being very thoughtful, though, about how we keep users in control of the experience. I think that's, as I mentioned earlier, around safety and so on. Users want to feel like they're in control of the experience. We also want to figure out how to allow developers to have a lot more power in terms of the experience they can present. And as a browser, as a user agent, we're actually in a very good position to do something innovative there. So today is all about you all connecting with us. We have a bunch of Chrome developers here to talk about the work they're doing. As you saw, this talk was very focused on mobile web, and a lot of the sessions are all jam-packed focused on mobile web. There's so much to talk about, not enough time. There's plenty of other material outside of this context and people here who can help answer those questions. We will have booths and sessions and panels tomorrow. And throughout the day, there's lots of opportunities for you to connect with developers. Really want to hear from you, hear what you care about, because ultimately we want to help make you all successful. So with that, I'm really excited to see and learn what you guys can create on top of the platform that we're building. So thank you so much for joining us today. It's an exciting day. I think there's so much to learn and explore. Thank you.
Cool, thank you very much. So we're going to be mixing things up a little bit this year, changes from last year. So tomorrow we're going to have a series of panels with a lot of the speakers that you're going to see today. So if you have any questions for Darren, he's on the leadership panel tomorrow, and that's at 3 p.m. So if you want to pose a question, then take a look on the moderator board, which is linked to from on the Chrome Dev Summit website, or just tweet your questions to Chromium Dev on Twitter, and we'll add the questions. But do shout at us if you're not happy about something or if you think we're going in the wrong direction, because we don't want this event to just simply be Chrome people having a show and tell of things that we've been doing recently. It's really your opportunity to hold us accountable for things that you think we're doing wrong, or tell us what we're doing right as well. One of the things that we've been spending a lot of time on, which Darren mentioned, is performance. And our next speaker is so obsessed with performance, he's optimized his talk down to 20 minutes, which is brilliant. So please welcome to the stage, it's Ryan Schoen.
Thanks. Thank you. I thought I was safe going second. Now it's going to be 22 minutes, and I apologize. Good morning, everyone. My name is Ryan Schoen, and I'm the product manager working on Chrome Performance. As Darren told you, the Chrome team is dedicated to making a first-class user and developer experience on the web. And we think that a very large part of that is performance, enabling you to make those really efficient, really performant, really smooth mobile web applications. So I should probably put that up. What I'm going to do over the next 20 minutes is tell you a little bit about how we're so committed to this goal. We have teams dedicated to making that goal a reality for all developers in a very natural way. And I want to tell you a little bit about what they've been working on. So I'm going to start out and talk about traditional performance in the sense of JavaScript operations and DOM manipulations. And then I want to spend a lot of time talking about rendering performance and that 60 frames per second goal that you're going to hear a lot about today. I want to touch on energy efficiency and what we're doing to improve your battery life. and then finally talk a little bit about perceived speed, because that's really the experience that your users are going to end up getting. So I said I wanted to talk about traditional performance, and usually when you have somebody from the Chrome team on a stage talking about performance, we talk about JavaScript operations, DOM manipulation, and synthetic benchmarks, things like Octane and Kraken. And we do want to be really, really good at that. We want to do it really fast. But any synthetic benchmark always has pieces of it that aren't really realistic. It's not the experience that the user gets. And earlier this year, you may have heard about a new benchmark that was released called Speedometer. And what Speedometer does is it takes a real-world app, like a to-do list, writes it up in a bunch of frameworks, so Angular and jQuery and React and a couple others, and then runs through it. It adds items to the to-do list, checks them off, removes them, and it tries to do that as fast as possible. And like I said, all benchmarks are synthetic, but there were parts of this benchmark that we really liked. It was a real app that was going to be in front of users, and so we wanted it to be fast. And when we took a look at it, it was a little embarrassing because Chrome really wasn't good, and you may have seen some numbers in the press that hinted that. And so we put a team on it, and we dedicated it, worked to that over the past 6 months. And obviously, they're allowing me to be up here talking about it, so there's some good news. I'm going to put up a graph of Speedometer. And on the y-axis here, you have the time that it takes to complete the benchmark. And then on the x-axis is Chromium revision, essentially, as it progresses through time. You can see that about 6 months ago, we were up at, 14,000 milliseconds, 14 seconds to complete the benchmark. And through a couple pretty large drops, we're now at around 6,000 milliseconds, 6 seconds to complete that benchmark, an improvement of over 2x. I think this is on Mac, but you have the same performance improvement across every platform. And so we're really excited about this, because if your JavaScript is anything like the type of JavaScript that you see in those frameworks, or better yet, you take advantage of one of those frameworks, you're going to get that performance boost for free. Your users are going to get that performance boost for free. And so we think that's really great. But as I hinted at earlier, this is only really one part of the performance game. And from talking to a lot of you, we know that what you really care about is that 60 frames per second. I think Darren mentioned it. I'm going to mention it a bunch. You're going to keep hearing it throughout today and tomorrow. And I want to be really precise about that. Because while 60 frames per second is a number, it's not always clear what web content we're talking about when we say 60 frames per second, and doing what operations, and on what mobile devices, or what devices at all. Reading Wikipedia on a Nexus 6 is going to be a very different experience from playing a 3D game on something like a Galaxy Nexus or a lower-end device. And so to be explicit, our goal is to make 60 frames per second a reality on all content and on all devices. And that's a pretty large goal for Chrome. We're on a lot of devices with a lot of different GPUs and a lot of different processors. And so we know that that's an ambitious goal. And I hope that you'll excuse me when I say that we're not there yet. But we are making pretty incredible progress. So to help frame this problem a little bit easier for Chrome developers, the engineers who work on Chrome, we flip it around. And we don't say 60 frames per second, but we talk about frame time. How much time does it take the CPU to generate everything that it has to do for a frame and get it out onto the screen? And so 60 frames per second, you do the math, that works out to 16.6 milliseconds. That's the budget that we have to do whatever we have to do to get that next frame on screen. So using this way of thinking about it, we collected 27 different websites, different effects that we wanted to make sure were really good on the mobile web, but that traditionally have been very, very hard to do in a performant way. These are things like a slide drawer that sticks to your thumb, or pull to refresh. These effects that we know that you as developers like to do and want to put in your apps, and we want to see that happen. And so with the goal that in order to be at 60 frames per second, we have to be under 16.6 milliseconds, we ran through all 27 of these effects on a Nexus 5, a relatively powerful device, and came to 129 milliseconds on average to generate a frame. Luckily, I'm not fired yet. This is January. So we ran this again after all the improvements that we've been making, and I'm happy to report that as of this week, we are finally at 16 milliseconds. For these really, really tough effects that we wanted to make sure were enabled. And so this is a pretty big jump. This is 10x. And so you're probably wondering, like, how is that even a thing that's possible? So I told you at the beginning of the talk that we had several teams that were dedicated to making this a reasonable thing that could be done. And one of those teams is a task force called Project Silk. It was a cross-cutting team between Chrome and Blink and was really enabled by the tight integration between those two. They worked on an immense amount of things, and I'm going to throw a bunch of words up here on the slide. I think Darren had a slide like this too. And I don't expect you to understand all these things. I'm certainly not going to talk about them all. But I just wanted to demonstrate some of the real breadth of what they were working on. To highlight a few, Darren this morning mentioned the will change attribute, and we think that this is really, really powerful. It enables you, as the developer, who probably knows more about your app than Chrome does, to label certain content and say, this will change, this will animate in some way. That lets us do a lot of the prep work ahead of time so that as soon as you start to animate, we don't have to do anything. It's going to be responsive and it's going to be smooth right away. All the prep work has been done. Another project is garbage collection during idle time. In JavaScript or in several programming languages, garbage collection is the process of reclaiming memory that's not used anymore so that it can be useful again. And historically, this has been totally unlinked from the Chrome rendering engine. So if you're trying to get that 16 milliseconds, 60 frames per second, and then Chrome is going to say, nah, it's time to do a garbage collection, you're kind of screwed. And your animation will just screech to a halt. So we've hooked it up with the rendering system. So now if you take a look at that frame budget, that's 16 milliseconds, maybe there's 6 seconds left at the end that you have time to do things with. And so we can fit in garbage collection there. And so you can keep running at that 60 frames per second, but still get the useful memory reclaimed. And then another project that I want to talk about that Darren also touched on this morning is a project called Hardware Accelerated Rasterization. And that's a lot of words that I don't have to say over and over again, so I'm going to call it by our code word, Ganesh. And before I go into what Ganesh is, I want to explain a little bit more about the Chrome rendering pipeline. If you've ever profiled your website in Chrome DevTools, you've probably seen little chunks of time called painting. And part of painting is a process called rasterization. And all that means is that we're taking the draw commands, like put text 12 point here, draw a rectangle that's 200 pixels by 300 pixels and put it here, and take that into actual pixels that are going to appear on your screen. And so historically, that process has looked something like this. This is a vast simplification, but the draw commands go into the CPU, where that rasterization takes place, into actual pixels. The pixels in the form of a texture are uploaded to the GPU, which then puts those pixels onto the screen. It's pretty simple, but there are a couple issues with it as well. As Darren said this morning, the CPU is not really optimized for that type of work. The GPU, after all, is for graphics, and so it would be much more efficient to do it on the GPU, which is tuned for those sort of operations. There's also that really expensive upload of the texture from the CPU to the GPU, and if you're doing that every single frame, that's really, really going to slow things down. In addition, we're not just doing this process for what's on screen on your mobile device. We're doing it for everything that's around. We're rasterizing everything around there so that when the user scrolls, they're going to get those pixels right away. We're not confident in our own rasterization ability to say, yeah, we can get it up there on time, so we do it ahead of time. And so that's really an extra burden on the CPU, and it costs a lot of memory. Even if you didn't know how this works, you've probably felt the effects if you've ever tried to do a JavaScript-based animation with something like request animation frame. There are these weird rules like, oh, well, yeah, opacity, you can change that, but left and top, like, no, you can't touch those. Like, that'll just ruin your animation. And that's ridiculous, right? Like, we don't believe that you as developers should have to have in your head these rules that don't make sense, but it's just the way it is because that's how the rendering engine works. And so that's where Ganesh comes in. We can largely throw away this pipeline that I was talking about, and again, vast simplification, but the draw commands can come in, for the most part, skip the CPU, and all the hard work can be done on the GPU. We're working hard to enable this kind of pipeline for all content and for all devices. Right now, it's just a handful of modern devices and about 15% of web content, because it's actually really hard with the many GPUs that we have and the many platforms that we're working on to get this going. But it's really, really a huge improvement. And to motivate that, I want to show a quick video. So this is The Verge's website. On the left, you have Chrome 32. And on the right, you have the latest canary, Chrome 41. And that has Ganesh enabled. And in a minute, I'm going to start the video. And simultaneously, I'll fling the two sites to scroll through The Verge's website. A very, very fast scroll. So fast that I slowed down the video by 4 times so that you can see what's going on. And you'll notice 2 things. Even though I scroll both of them at the same time, Chrome 32 takes a very long time to start because it's thinking really hard at the beginning of that animation. And the second thing you'll see is that without Ganesh, the rasterization just cannot keep up. And it'll be very apparent once I start the video. So let's take a look. there's the fling, 41's off and running, and there's the scroll on 32. Can't even keep up. But 41 rasters all the content and gets it on screen in that super fast scroll, which on here is 4 times slower. So we think this is incredible progress. Thank you. And just because I want to end this section on a low note, we do recognize that even 16 milliseconds is not the golden standard. We still have a lot of work to do. Because if there's anything else happening on your phone, or heaven forbid you as a developer want to do something besides just rendering frames, that's going to blow that frame budget right away. And so we're going to continue working on Project Silk, and I expect we'll have some more good results for you soon. OK, so far I've talked about speed, and that's great. But there's another part of performance that we're starting to realize is equally important, and that's efficiency, and specifically energy efficiency and battery life. When I started thinking about energy efficiency, I had sort of this very naive approach to it, was like, well, we're already optimizing CPU and GPU, so let's just do less work on those, and then we'll use less energy, and we'll just get the energy efficiency for free. Why do we even need to think about energy efficiency? And that's partially true. That does improve energy efficiency, but there's a lot more that we can be doing there, and it's not always intuitive. And to motivate this with a concrete example, this was what I thought energy usage looked like. When you're doing work on the CPU, you're using energy. When you're not doing work, you're not doing energy. So again, just do what you have to do it as fast as possible, and get back to idle. This is not quite how it is. And still, this is still an oversimplification, but you have a little bit of a warm-up and a cool-down period anytime that you use the CPU where you're using energy, but you're not getting efficient work done, or you're not getting useful work done. You're just burning energy. And so in this contrived example, you're going to use about 2 times as much energy as you would in sort of my naive approach. And so what you want to do instead is take this work and nudge it by just microseconds and coalesce it all together so that you have a single warm-up and a single cool-down period. And you get an energy savings of about 2x here, in this example. And so I don't want to imply that we're always going to wait as long as we can to do this work, but it becomes an engineering trade-off of how much energy savings can you squeeze out of your work just by those little nudges that aren't going to, in reality, affect the user-perceived performance of your app. So we're taking learnings like this and going back and taking a look at Chrome's energy usage. And we started with the worst offender of this, which was Chrome for Windows. And I'm happy to report that at idle, so when you're reading a Wikipedia page or when you're just reading a news article or something, Chrome for Windows is now using only 1/4 of the energy that it was 6 months ago. And so we think that that's a fantastic improvement, and we're really looking forward to taking those same learnings and applying it to other platforms. OK, the last thing I want to talk about today is perception of speed. Because at the end of the day, that's really what you guys probably care about, is the experience that you can deliver to your users. And so I'm not going to talk about graphs and tech specs and percentage improvements anymore. If you've been following the release of Android Lollipop, you may have heard about an API that they're working on called activity transitions. And it enables what you're going to see behind me here. When you transition between 2 activities in Android, which is essentially a page navigation in Android, it lets you transition smoothly and keep some elements on the screen. So you can see in this example, you click on the album art, smoothly transitions over to the next activity. And there was no break in the user experience. Not only is this a smooth and beautiful user experience, but it also hides any latency that's involved in creating that new activity. If you were to do sort of an A/B test with users, and on one hand, you take just the activity that as soon as it's ready, you throw it up on screen, no transition. And in the other, you do this smooth animation to the new activity. Even if the clock time is exactly the same between the two, the user will always say that the one with the smooth transition was objectively faster, even though the time was exactly the same. And so this is the kind of thing that we want to do on the web. But today, if you do absolutely nothing, your navigation is going to have that horrid white flash that is sort of like the signature of the web today that reminds the user that they're on the web. If you have something like a single-page web app, you can make this work, right? You can do AJAX calls. You can manage your URL state so that this is still the thing that's even possible, certainly not easy. And if you want to transition between origins, then we need to start talking about like iframes, and things just get really complex. And that's not how it should be. Like, right, you're just transitioning an element. You shouldn't have to jump through all these hoops to avoid this legacy piece of a browser. And so we've been working on this experiment. It's a new API, new prototype API that we've been calling navigation transitions that enables this sort of thing on the web. And so I want to show you how that would work if we can switch to the podium camera. Please. All right, cool. So I have here a prototype that is Google Web Search, obviously not live. And what you're going to see in a second is I'm going to click on the search button. And we're going to navigate to the search results page, but we're going to keep the Google logo. We're going to keep the search bar because those elements are also present on the search results page. So am I here? Yep. I can click. Smooth navigation, and the results just fly in. There was no break in the user experience. Thanks. So if we can switch back to the slides for a second. Like I said, this is still an experimental API, so everything is likely to change, and I don't want to go into the specifics of how it works, but I do want to call your attention to two things. The first one is that this is pretty simple. We have a meta tag that identifies the elements you want to transition, a link header that tells the browser where the transition, the CSS animations are, and then whatever CSS animations you want for those elements. Really dead simple to implement. The second thing I want to call your attention to is that a browser that chooses to implement this in whatever final form it ends up looking like, you'll get those great transitions. And if you have a legacy browser that doesn't understand this stuff, you're going to have the same transitions that you would have anyway. So it's fully backward compatible, and it'll work, continue to have those navigations everywhere else. So I started out motivating this with the Android Activity Transitions API, which I said let you do these smooth transitions between native Android apps. Chrome on Android is just a native app on Android. So what happens if we hook up Activity Transitions API with the Navigation Transitions API? And so let me show you another demo if we can go back to the podium camera. So I have here, it's a little washed out, but it's all right, you'll still get it. This is just a web page, and it has some thumbnails on it. And then I also have this toy native app that we just have, for example. And it has some pictures, and you'll see that some of the pictures are the same, and then there's some text there. If I open up my web app, and I want to now smoothly transition into that native app, all I do, click on one of the images, and you're inside the native app. So as you can see, this really starts to blur the line. If we can go back to the slides, really starts to blur the line between native apps and web apps, and we think that that's great. We want you as developers to use whatever development experience you think is right for you and your users and your app, and really deliver that great experience to the user. The user doesn't need to be concerned with what toolchain you use to get that experience in front of them. They can just enjoy and be immersed in your experience. And so we think that that's really great. So that's all I had prepared to talk about today. Just to quickly recap, I touched on traditional performance and the work that we've been doing there. I spent a lot more time going into rendering performance and all the projects that we've been working on there to get a great, nearly 10x improvement on some of those tough cases. Talked a bit about battery life and energy efficiency and how we're thinking about optimization there. And then finally, talked about perceived speed and this new prototype API that we've been working on that we think can really make a large difference for navigations on the web. But if nothing else, what I want you to take away from this talk was what I said at the beginning, which is like, we care, we get it. We know that performance on the web is painful, and we're doing everything that we can to make that a better situation. We've come a long way with some of the improvements that I've talked about today, but there's still a lot more to do. And so if I have my way, I'll be back up here on stage 1 year from today with as much good news, if not more. Thank you very much.
OK, so there is one of the panels we have tomorrow is a performance panel. That's at noon, so get your questions in for that. Once again, the link to the moderator is on the Chrome Dev Summit site. But you can just tweet your questions to Chromium Dev. It's Ryan Schoen, right? I got it right. I've been really panicking about talking to all the speakers so I can write like phonetic versions of their names, because I'm always paranoid about getting it wrong. Because you know sometimes how you'll read something for the first time and you'll read it slightly wrong, but that's the one that sticks in your head for a long time. I went out with some cool young people to a bar, and there was a song playing, and I was like, and I want it to be cool. I want it to be cool like the young people. So I was like, I recognize this song. So I said to them, oh yeah, this I know this song. This is Skills Rex, isn't it? And when I close my eyes, I still see their laughing faces. They were, oh, Skills Rex. Oh, like a competent dinosaur. Is that the band's name? They were literally crying with laughter. Okay, anyway, our next speaker, he's been a huge force in pushing the web forward. He spends a lot of his times wrangling standards group, which is kind of like living in a war zone, really. So he's got a bit of a 1,000-yard stare as the mental impacts of that. So here to talk about something called Service Worker, I've never heard of it. It's standards soldier Alex Russell.
Thanks, Jake. Jake knows all about service workers because he helped design them. So everything that goes wrong today with the live demos will be at least half his fault, yeah? OK, agreed. So I want to talk to you today not just about the problems that we've got necessarily with regards to how web apps have in the past been sort of boxed into one location or another. Because, do we have slides for, apologies. Do we have slides? Or the other slides? We'll come back to my, my debugging section in just a moment. I've done this all wrong, you see. All right. Oh, I see. I was on the wrong screen. Also, it's nice to see my coworkers actually watching and editing my presentation in real time. That's gonna make for some good times here. Can you hit the present button? Bingo. All right. So, wow, that's not focused in the right window. Yes. Hey, there we go. So I'm going to talk to you today about making web apps, appy or appy web apps, or something along those lines. It's a really difficult kind of set of words to pack together because our expectations about what an application are kind of different to our expectations of the web. We expect that the web is going to get us the most reach possible. This is you'll see the new Device Lab out here today, which I know that Chris Wilson and other folks here have been putting together furiously. But the best thing about the Device Lab is that it shows you in one concrete place the enormous reach of the web. Not only have we been able to create a platform that gets you all the users from one producer's device, or one set of manufacturers' devices, or one operating system. We've created a platform that gives you access to pretty much every device that's been shipped in the world in the last decade. We have more users on Chrome. I was looking at the numbers. We have more users on Chrome than all iOS device shipments to date. That's not to say people using iOS devices. That's all iOS devices ever made. Think about that for a moment, and then think about how you invest in those two platforms differently and your expectations of them. And they're very different because the web, despite having enormous reach, is a little bit awkward. And that awkwardness is a big issue, not so much on the desktop, when getting to the stuff that's just there is really easy. It's up hanging in a tree. But in the mobile web, we've had a bit of a disconnect because the power that you get between being able to deploy your application to pretty much every user everywhere, and the ability for them to frictionally share it with everybody else, and the ability for those experiences to show up in indexes and crawls and make it possible for third parties to also help share the experience that you've built with other people for whom it might be relevant. That power doesn't really work well with the UI surface areas that we're all carrying around in our pockets. Access to the home screen, being able to be in the notification tray, all of those things are critical when typing something on a little tiny screen with even with a better keyboard that we've got now. Let's admit that's not sort of where we want to be. Someday we'll be able to talk to our phones and it'll always just work, but for now, we're only just there. And so saying a URL at a phone is usually a hilarious thing to do in public and a frustrating thing to do in private. I recommend you try both sometime. So we don't have access to a lot of these UI surface areas today. And it all gets back toward whether or not we're first class. Are we part of the ecosystem's top-level affordances or not? And if we are, being first class has real advantages. And so it's worth asking, what do we need to get there? What do we need to do to actually get ourselves to become first-class citizens in the most important operating systems that we're all using? So we've looked at this problem quite hard over the last couple of years. And we started by understanding that we all need to be building things that work offline. We all need to be building things that just work offline. And the definition here of work is a little different than you might imagine. I'm not asking you to build things that work offline in the sense that all the data is always cached up front and it was done by magic. No, I'm asking us to get to a place where we've got basic equivalence with the frustrating native apps on your phone that launch and then fail, right? It would be great if it was the application that's delivering the bad news about what just happened to the network, but maybe presenting you with the previous state, as opposed to a situation where you're looking at a blank white loading screen. The white loading screen is perhaps the worst part of the web experience today because we can't think about web applications as being trustworthy yet. So we need to give ourselves the ability to build offline that just works. And we need access to system UI. We've heard over and over and over again from you that access to placement in the home screen and the ability to build applications that you can alt-tab to is a critical differentiator. It's part of what it means to build an application versus build a website. And we've built up a whole series of stories and expectations around applications versus websites, premised, I think, on the inability to be part of that top-level affordance. Being in the tab switcher the natural way actually has real power. And I'm very excited about what's happened in Lollipop as a result. And I think we need faster and better access to powerful capabilities. There's a whole series of applications today that make a ton of sense on the web, and really not anywhere else, for lots of reasons. But there's a whole series of applications that you can't build. The application performance work that you're seeing out of the Silk team, and the work that's happening with Asm.js, and the ability to accelerate regular plain old websites and make them work very quickly is massive, but it doesn't necessarily open up access to new hardware and sensors and capabilities in a way that I think we all kind of want to see. We'd like to be able to keep the pace. We want portability, but we want to keep the pace. And that's a place where I'm hopeful that some of the things that we're going to show you today are a good down payment. So what would it be like to actually have a web app, an application that feels like an application, but comes from the web and can still be on the web? It's a little bit like a black swan. If you haven't seen it before, you might have not theorized that it could exist. And I'd like to submit that most of us haven't seen it before. Most of us have dealt with PhoneGap or Windows 8 or Chrome apps that have tried to give us applications in our native application ecosystem that are built with web technology. And I think I can speak for everyone who's a web developer here today and say that HTML, JavaScript, and CSS are not the best part of your day. And so someone coming to you and saying, hey, I've built a new system that will let you build applications with HTML and JavaScript and CSS is not perhaps the most exciting proposition that everyone's given you. If, however, they said to you, hey, I've made it possible for this indexable, linkable, searchable, easily shareable, friction-free application platform that we've delivered to you to work really well and as a first-class citizen when you want it to, I think that's compelling. I think that's a better story. And yes, HTML, JavaScript, and CSS are key enablers of that story, but they aren't the story. So we need to get back to a place where we can build something once, build it, and deploy it to the web without awkward packaging steps, without intermediate gatekeepers that add friction to the process of sharing something, and get to a place where an app, a real app, is also just a real website. We need to see these things in the wild before I think we'll collectively come to understand what they're going to be. So what would a good experience for this be like today? Like, let's just say that you took the set of things that the web is currently good at and the set of things that apps aren't particularly great at, and you looked hard at them and said, well, what part of my life could be made better? I was thinking about this question, and it occurred to me that it just happened to me. I was in New York for the Velocity conference a couple months ago, and it's a great conference. I got to talk about performance and service workers and all some sorts of my favorite things. But after the conference, the next day, I had a little bit of time before my flight, so I stopped into the Google New York office to hang out with some people who I don't get to see very frequently and whose projects I'm interested in. And so we got lunch, and we got to talking, and then I looked down, and I was late for my flight. Okay. I did that. Nobody else did that to me. I did that to me. But I needed to get to JFK, and public transit was going to be like an hour and change. And if I took a cab and there wasn't any traffic, it might have been 45 minutes, and I could just make it. And then this happened. And this happened not just once inside of downtown and midtown. This happened basically all the way out to the airport. But luckily, I was stuck in one of New York's new taxis, which, despite having looked like an elongated Prius in the back, and maintaining the wonderful yellow color of New York taxis, which makes it easy to spot, has kept the quaint feature of New York taxis wherein your knees are introduced to your face significantly before you even get on the airplane. I just think of like a warm-up for getting on the flight. It's nice to see that some things don't change. So I wasn't going to make this flight, basically. And I had I known that I was in real trouble, I could have downloaded an airline application that might have notified me that my flight, as I found out later, was delayed. That would have been great information. And in fact, I did find that out at some point in my hour-and-a-half trip to the airport in the back of a cab where I was studying the pattern of the jeans that I was looking at. And not having had this happen, not having it notify me, made me really stressed out. So I was calling my wife, and we were trying to figure out, like, oh, can we get another flight? It wasn't good. So when I found out that my flight was delayed, it was a breath of fresh air. It was like one of the best things that had happened to me in a long time because I got to go home. Now, I had used the airline's website, and the airline's website is actually incredibly full-featured. The airline's website, I already have a login to. Chrome has synchronized my passwords to that, so that's pretty good. So anywhere that I log into their website, I've got access to sort of all of my history, all of the stuff that I've done with them. But I use this website relatively infrequently. I use it whenever I want to travel, and hopefully that's not that often, or when I'm looking for flights. But it already knows all the state. So it's a little bit punitive to need to go to an application when the website could just do it. Now, I could have used their mobile website. And as you know, mobile airline websites are mostly just practical jokes. They're designed to give you the feature set that looks tantalizingly close to being what you want, but at a different URL, so none of the other stuff actually works. So it got me thinking, what would it be like to actually have an airline website that did just sort of work? So if we can show.
You're on my own?
Yeah, I think we're good. Great. Do we have video from the? Bingo, great. So what would it be like to actually have sort of a modern web site for a modern airline? So this is Polymer Air, and Polymer Air is built with beautiful polymer components. There aren't that many of them. This was relatively straightforward to put together. And I can do all the stuff that you'd expect to do on an airline. And this is the exact same website as the desktop website. It scales up and down. It uses responsive design, using the Polymer responsive design components that's just sort of baked in. And this is a great system. So I can come in here and imagine that I want to, when I check in, let's see, 1, 2, 3, 4. Okay, I was going to check in, and my last name is Russell Still. Yes, I can spell my name. Mostly. Okay, so let's say I'm going from San Francisco to London, and I'd like to know when I check in about updates to my flight. No, I really would like to know when I check in if there are updates to my flight. By the way, you're looking at a very, very fresh build. This is the inadvisable live demo. Oh, sad panda. We'll come back to this in just a moment. So the mobile website for really this wasn't meant to be nail biting. Yes, the inadvisable live demo. So let me show you some other stuff that does work. Can we go back to the? Great. So in today's Chrome dev channel, we can build web apps like Jake, our beautiful and wonderful moderators, trained to Thrill demo, that work offline. So this is a web app that Jake has built, and I'll show you more about it later. But let's say that we're somewhere in San Francisco where Wi-Fi and network connections are at the home of Silicon Valley, where getting Wi-Fi is a pain in the butt, or just like that. This site still works, right? In fact, I can go and I'm going to swipe it away, kill that, and we'll come back to Chrome Dev. And this site is still working. I'm in airline mode. The site absolutely works. And so I can get back to the status that I had. So let's say I go back online. And like any good application, it's telling me what the status of the network is. It doesn't actually know. That's the thing about being offline. You don't really know if you're offline or not. It would be nice to know in a definitive way, but the only way you can really know is by checking in your application to know if you are. So when I refresh stuff now, I'll see the updated content. But notice that this thing didn't stop showing me anything, and it didn't give me a blank white loading page. It showed me exactly what it knew about the state of the world, and that caused us to be able to show the user, say, for instance, their boarding pass if we were an airline, if we had an airline website that worked. Just going to go with that. So in the poly-air system, what we really want is the website to be able to come back to us and tell us that our flight was delayed. It would be wonderful if when we register for a push message, and then at some point later, and our flight happens to be delayed, it was the website that told us, because I'm not going to be sitting here with this website open. It would be best if, in fact, the website decided to tell us, while we were doing something else. I think that would be pretty swell. And in fact, what we're looking at here today is a build of Chrome that has push and notifications and works offline. And it's told me, and I probably was actually going to notice that happened because it showed up on my watch. And in fact, if I come back to that, come on, Android, no, really? Yeah. If I come back to that and I swipe that away, we'll see that the status is swiped away here too. This is a real native notification. All right, back to the safe waters of Chrome Dev. That's a real thing. That's a real thing that I think most of us want. We want the ability to re-engage users where they are. And in fact, we also want the ability to take applications like this and sort of save them all the way to the home screen. Darren alluded to earlier what we're going to be doing to make it easier for you to add stuff to the home screen. But when you do, it sure would be great if these things showed up at the top level, and when you tapped on them, if they came back as full-screen applications that didn't require a URL bar when you didn't necessarily need one. And when they show up in your taskbar, they should show up as themselves. They shouldn't show up as just another web tab. This is all stuff that we're delivering today, and I'm going to show you how this works. But this works, and you can do it too. So hooray. Can we go back to the Chromebook? Do I need to do that?
I got it.
All right. by the way, I've done the live demo thing exactly the way that everybody who knows what they're doing would tell you not to do it, which is not just to have a dependency on the network and not just to have one device that you're demoing, but to have multiple devices and then have those devices not be the ones that are plugged into the video screen. So if you find yourself doing a live demo, I suggest that you take tips from me and not do it the way I'm doing it. Do you know where?
Yeah, it got lost.
Got lost. I see.
Do you want to talk about anything?
Yeah. So I think the most important part of that demo isn't that we built a website that works offline. That's something that we've been able to do for a little bit. The most important part of that demo is that we built a website that works offline occasionally. We built a website that I didn't have to interact with a lot, or I didn't have to repackage. I built it in the natural way, and then I was able to add the offline capability to it at some point later. As I'll show you in just a moment, service workers enable you to build web applications that, service workers enable you to build web applications that you can upgrade with offline capability if you build them the right way. So the most important part of building your application the right way is, do we have the Chromebook back? Or the slides? Yeah, great, here we go. So the most important part of building your application the right way, and I apologize for the jank here, is that you build a real web application. So let's see, I want to build a new tab, and I'm going to go to polyair.appspot.com, which is where this demo was hosted, and you can try it out today. And if you're using Chrome Dev today, all of the offline capabilities should work for you, and they will work for you in beta soon. So this is a regular website, right? This is not something that I built just for mobile. This is not a separate code base. It deployed like a website, and in fact, I didn't have to package up my resources in a new and unique and potentially very special and not the best ways kind of way. This is something that I use infrequently, but I want to get back to it easily. And on the desktop, that's easy to do because I've got a URL bar and I've got a search system there, and it's really easy to use. But typing queries into a phone is not the best way to do it. But I want to be top level here too. So I'm just going to close that up, and I'm going to come back to this application, which I've saved to my desktop. We're going to start asking users to whether or not they want you to be able to save this to the desktop. But today, you're able to do this manually. But in the very near future, users, if you build your applications the right way, will get asked by us whether or not sites that they interact with frequently, that are built using service workers, and that have the right metadata, want to be treated like applications. And this thing is a real application. We want it to be a real application. And what you'll notice here is that the top-level UI is different. There's no URL bar here, but I can see what the URL is. And in fact, the Chrome Dev Summit site is built the same way. This is also a site that has a service worker, will work offline for you, and is built to be a standalone application, which means that I can alt-tab between them the way I've always wanted to between my web apps. It's not lost in the sea of tabs. It's its own standalone thing. This is the sort of power that I think you really want when you're trying to become that black swan, a website that actually finally is an app. What does it mean to be top level? Well, not only are you in the bar there, you're over here. You're in the app launcher. You're where users are looking to get back to their stuff. You're part of the easy recall mechanisms that are built into operating systems. You're part of the tab switcher. Your icons are the right thing in the right place all the time. Great. So let's talk about how we did that. Can we go back to the other slides? Yeah.
Are you coming back to this?
Yes. Great, thank you. Meticulously rehearsed and flawlessly performed. So that was just the web. I think the key thing to take away from what we have just seen is that what you were looking at was a website, right? You deployed it the same way. It has URLs. All of the states inside of that site are URLs. You didn't have to package it. You didn't have to build a separate application container. You didn't put it in a store, not even the Chrome Web Store. You built a website, and then it turned into an application because the user chose to turn it into an application. It's a thing that they thought was valuable to them and wanted to keep, not a thing that you thought might be valuable to them and wanted to push, right? This is the key to doing engagement well, I think. But let's figure out how we actually pulled that off. There's 3 components to this. The first is a service worker. You're going to need a service worker for everything I show you, and pretty much all the new capabilities that we're going to add to the platform in the future. So you're going to need that. Manifests, which eventually will point at service workers, and the push notification API was a part of this. The push notification API isn't shipping when service workers initially launch later this year in Chrome 40, but it will be coming soon. And some of the details of the code I'm going to show you work today and work in the Poly Air repository, but those will be changing, and so stay tuned for those updates. But let's talk about offline. Offline happens, and when offline happens, and you know that it's offline, you're kind of bummed out, but it's nice to know. The worst part is when you don't know. Because the very worst kind of offline isn't offline, it's sort of kind of online. And so I lived in London during the 2012 Olympics. And so as a wired modern city, London decided that it was going to put Wi-Fi in all of the tube stations. You heard that right? The stations. So what that means, of course, for those of you who are laughing, that you already got this, is that you can be in the station waiting for your train, start loading a web page or something else, step into the train, and be moving 2 minutes later to the next station. Meanwhile, TCP has dropped out. It just doesn't know it yet. It's got a 2-minute window. So you're sitting there watching maybe a white spinner or a blank page trying to load, and then you get to the next station where your phone is furiously trying to reconnect to the same network, which was made available in that station too. And maybe it's busy, or maybe you don't get on it, or maybe you get on it, and then you try to tap things. But you know, London's a modern city. Those doors close quickly, and you're on your way again. You can play this dance most of the way to Heathrow, by the way, from central London. You can maybe try to load the same news article, which with 700 kilobytes of JavaScript at the top, which are loaded off the network and not out of the cache, is not my favorite dance. So enter the service worker. The service worker is a programmable in-browser proxy that lets you decide what to do. Not the first time you visit a web page, but maybe the second, third, and fourth times that a user visits a web page after you've decided to install yourself. The service worker has control over the cache, and it has the ability to mediate pretty much all conversations with the network. In the past, we've attempted to solve the offline problem. By solve the offline problem, I mean we've been trying for a very long time. Who remembers Google Gears? Wow, your scars are as big as mine. All right, so Google Gears gave you a programmable gave you an in-browser ability to cache files. It was called local server, but it wasn't a server and it wasn't programmable. It gave you a list of files that you could put in, and it would dutifully hold on to them for you. We also implemented app cache, which allowed you to give us a list of files, which we would download and then dutifully give them back to you. But we also didn't let you program it. And so having not solved the offline problem twice for you now, we've decided to do something cheeky and not solve it. Instead, we're going to let you solve it. We're giving you actually control over how this whole process works. So how do you get started? How do you get out of the gates? So this is the registration code for a service worker. A couple of things to note about it. First, the script that you're registering here has to be on the same origin. And that origin has to be an SSL origin. Service workers don't work over insecure connections for lots of boring reasons, but the exciting reasons are that it's 2014. Holy cow, get some SSL. What you'll see here is that it returns a promise. And that promise means that the installation process is asynchronous. This code is going to run in the background. The service worker process actually goes through a series of phases once the browser encounters your request to register and install the service worker. So the browser downloads sw.js, and when it succeeds, it'll hand you back a registration object, and you can find out some things about it. The scope object there tells you basically which path in the origin that your service worker is now registered for. And at the root, that's going to be the root. But that's more of an advanced feature that you probably don't need to worry about. Once you're inside the service worker, your code is going to be run from top to bottom. So the first phase is the install phase. The install phase is an event like any other DOM event that you might be familiar with, and you can control the lifetime of this event and say, I'm not actually ready and I'm not actually installed. Don't count me as being installed until this promise resolves. So you pass a promise into wait until, and then it goes. If you don't do anything here, if you don't have an event handler for it, you'll be considered to be installed straight out of the gates. Note that you can also add items to a cache. Now, I said that we had tried to solve this problem for you multiple times before by giving you the ability to generate a very long list of things and then put them in a cache. It turns out you probably want to do that. It also turns out that you probably don't want to have just one cache. We learned this the hard way multiple times, and we apologize profusely for it. But we're giving you the ability to add lots and lots of caches and control them and version them independently, but you have to do that. And this is the sort of code that you're going to be writing to get that done. So you can add a list of resources to a particular cache, but also notice that this API is incredibly promise heavy. If you aren't familiar with promises, Jake, once again, has written a great article about how to use them and what to expect. But we partially designed the Promise API in JavaScript and in the web platform to support service workers. So it should be no surprise that you're going to see it used all over the place. It's also possible to import third-party libraries, your own libraries, obviously. And there is going to be, in the initial release of service workers in Chrome 40, you're going to want the service worker cache polyfill. It'll add a couple of extra methods to the caches. But caches are available natively in the first release of service workers later this year. But these scripts are going to be cached along with the service worker script. When you download sw.js, the browser is going to go fetch these resources and cache them together. They come down as a package, basically. And in fact, this is how you can do collaboration with third-party scripts. You can use import scripts, which is an existing API inside of web workers. And you can call out to third-party CDNs or third-party resources and use those inside of your service worker. This is a great way to collaborate. And you have programmatic control over requests. You can handle fetches. And in fact, you can handle fetches multiple times. So let's say you pull in maybe a third-party plus service worker snippet using import scripts, and it wants to handle only requests for plus.google.com. It can do that, but you can also handle the main requests for your resources using multiple event listeners. So this is pretty good. And you'll note the return of respond with. It's often the case that you don't know exactly what you're going to want to do in response to a request that comes to your service worker. That's OK. You have some time to do it, but you have to tell us that you're going to need or have to take time to go get that work done. The reason for this is that service workers can be killed at any time, basically. Whenever the service worker script is quiescent, whenever it's not doing any work, we reserve the right uniformly and unilaterally to shut it down. And in fact, we're going to do that aggressively. We're doing this to preserve users' batteries and ensure that the memory usage of service workers is low in the common case. But the side effect here is that you need to not be keeping global state inside of your service worker. If you are, it's going to get killed and you're going to be surprised. The good news is that the dev tools simulate this quite accurately today. You can be happily going along debugging a service worker and it'll die out from underneath you. Not the best debugging experience, but at least it gives you a sense for the lifetime. So this is a simple pass-through proxy. There's a new fetch API inside of service workers. It's the XHR that you've always wanted. You're welcome. It returns promises, and it takes a request as the key. You send in a request, and it hands you back a response object. Also, response and request objects. Hey, wouldn't it be great if we had those as opposed to manually packing those in on a per library basis? We've added that too. There are some batteries included, but just enough to let you do your own thing. So this is the simplest read-through proxy you can imagine. You could do something like this to, say, get real user metrics in terms of runtime performance. Obviously, the navigation timing and resource timing APIs give you a lot of that today. But if you want to do something specific and custom, here's a great place to do it. It's also the case that you can construct your own responses, as you see at the bottom here. We're looking at an event handler at the bottom that creates a new response object, passes in the content of that resource, and sets status and headers, and then responds with it programmatically. You can imagine doing client-side templating. You can imagine doing your own parsing and processing of responses that come back from the network. All this stuff is possible with service workers, and it's relatively straightforward. I am incredibly excited to see what you do with it. I'm also a little bit fearful, but incredibly excited. All right. So remember that cache that we populated earlier? It's possible to get an individual cache object out of the cache's collection, but you can also match globally against a single request. And matching globally against a single request allows you to take the first thing that comes back. This is a nice, easy-to-use way of saying, if you have something in any of the caches that matches this request, hand it back to me. But again, it's asynchronous. The match operation returns a promise, and when you get it back, if it's in the cache, you'll get an object, and if it's not in the cache, you'll get null or undefined. And that is to say that in promise speak, something not being in storage isn't the same thing as an actual exception. You will need to handle exceptions separately here. So let's talk about what happens if I populated a cache, but my application comes through and it needs something that it doesn't already have. This is read-through caching. It's a little bit simplified from what you're actually going to want to do. But basically, you can fetch it if you don't already have it, and then you can put it back in the cache and then respond with it. This is really straightforward inside of the Service Worker API once you sort of wrap your head around promises. But aside from that, you have all of the power to do all of the things that you wanted to do at runtime. You didn't have to be omniscient. You didn't have to be omnipresent with all the developers in your team. You can actually sort of clean up some of their errors in this sort of situation and do things for them to make sure that caches are actually populated. So let's talk about performance for just a minute. This is a slide from Ilya Grigoryk's talk at Velocity last year. And it talks about the lifetime of the 1 second budget that we'd like to give ourselves if we're actually going to do the right thing by users. 1 second is a long time. You know, it's a very, very, very long time when you think about how fast CPUs are and how many operations we can actually get done. But from a user, 1 second is really where you start to get annoyed. 1 second is a bad place to be if you're not giving something back. And on the web today, and specifically the mobile web, you can blow out that 1 second budget very easily. And in fact, if the radio's dead and you're in a cold sleep state on a phone, you can blow out that 1 second budget just starting the radio. You'll never have a chance. You'll never be able to get out the gates. You won't even be able to look up DNS in that 1 second if you're on a 3G connection and you're in a deep sleep state at the network level. So remember that you may already be behind your 1 second goal, and then you have to add an RTT for DNS if you don't already have it in the cache or it has expired, an RTT for TCP setup, an RTT for HTTPS setup, or an RTT or 5, and then HTTP request and response setup. This is pretty bad. This is to get any bytes on screen if you're going to the network for those bytes. This is a very bad place to be. And this is the place that we're all trying to live in. By the way, you have done a heroic job in trying to get your mobile websites to load fast. But the deck has been stacked against you. This is a bad place to be, and we need to do better. So this is, again, Jake's Train to Thrill. And this is a side-by-side comparison of it loading the very first time, and then it loading with a service worker. The first time is on the left, and the service worker is on the right. What you're looking at is those bytes were on screen immediately in the service worker case. And that experience on the left-hand side isn't great, but the right-hand side experience is what happens every single time you come back to the application after the first time. Isn't that better? Isn't that what we all want out of the web that we're interacting with and the applications that we interact with? I think so. All right, so let's talk about how, as you're starting to build your site with a service worker, you're going to make sense of what's actually happening. All right, can we go back to not the phone, but the Pixel? Great. Bingo, thank you. So one of the things that we have added in, oh, right. Let's say I'm going to add USB debugging here. One of the things that we've added to Chrome in recent years, are we displaying the? Great. One of the things we've added to Chrome in recent years, which is huge for debugging on mobile, is Chrome Inspect, Chrome://inspect. And that will show you things like all the pages that you're currently looking at, and will let you inspect them immediately. But today, it also is going to allow you to inspect service workers. So these are the local service workers that I'm looking at. The Chrome Dev Summit site is going to work offline, and it's got a service worker. And we can inspect it in the normal way. It's just DevTools. That's pretty great. And we can do the same thing for the Polyair service worker. And you can see that this is a service worker. It's got a global scope. It's got a bunch of stuff we've added. But it's actually a very small object compared to what you get in a document. So this is a much smaller API than what you see in the DOM. So, but IndexedDB is available as storage, not local storage. And you have the ability to work with it in the normal way. But the interesting part comes when you start to work with devices. So let's go back here, and let's look at my Nexus. Because the DevTools team has done such an outstanding job, it's possible, when this works, to both see what I'm looking at on the phone and to start debugging it. So I can drive this here, right? Cool. And I can go to the service worker internals page of the device itself. So Chrome. Service worker internals is going to work both. What? Oh, I missed a colon. Maybe I missed a colon. Maybe I need to load it from the device. Bug to be filed. All right. I can see the registration status. I can see that there's a service worker that's been activated but stopped, which means that it was loaded and it's now active for a particular bit of the origin space, but it's been killed by the browser because it isn't doing any useful work. If I go back, for instance, to train to thrill, we'll see that the service worker state here goes to something else. Just one moment. New tab, train to thrill. Now if I come back here, we'll see that all the logs are being sent to the activated and running service worker at the middle there. So you can see the logging status that's coming off of it. And this story is going to get better for debugging service workers. But you have the ability both to inspect them here, but also to connect to them over the USB debugging bridge. So that's pretty great. All right, can we go back to slides? Sorry. Thanks. OK, so that's inspecting and debugging. It's worth noting that an application that feels like an application, that does the sort of stuff that we've just seen, has to be composed of two parts. The first is a shell. It's the thing that boots up when you initially tap on the icon or go to the URL. And the second part is content, which you probably want to send down in the initial payload when you're first loading your application. But subsequently, you really want to be composing content into the shell. If I navigate from place to place, I don't want a full page transition necessarily, and so I want to be pulling content and loading it in with Ajax. Building an application in the modern style using something like Polymer makes this trivial. The Polyair application is really just that. It's data binding plus a bit of content shell, and when things change in my data, things change in my UI. This is a really natural way to do it, and I can start to do synchronization on top of a data model. And this is how we need to start thinking about constructing applications. Jake's Train to Thrill is perhaps the most elegant and futuristic version of this because it has server-side logic for smooshing down the initial payload the first time you go to it, then installing a service worker, and then subsequently launching the shell, and then feeding it data. And that's sort of where we really want to be, where we're launching something almost instantly. So today, to get ourselves onto the home screen, you sort of have to do this dance, where you click on Add to Home Screen, you add something there, and then it shows up like this. Again, if you build your site with a service worker and a manifest, and it's high quality and users like it and they come back to it frequently, you're going to start to see us asking users whether or not they want to continue to engage with your site in this way without necessarily having to determine in some inscrutable menu and without any actual context whether or not this is something that they want to do. We're going to make this better for you, and we know that this is our job. So what is that metadata? Today, this is that metadata. This is from the Chrome Dev Summit site, and I had to snip a little bit. You have to do this on every page, every single page. At the top of the page, and by the way, those are very valuable bytes. Let's say a user is coming to your site for the very first time. This sucks. This is bad. This is in your first couple of packets. This is stuff that you wanted to use to put pixels on screen to tell the user that something else was going to happen, or give them the answer in the best case scenario. This regurgitation over and over and over again, which is subtle and breaks easily, is a bad thing. And so we're replacing that with a new web manifest format that's being specified at the W3C in conjunction with Mozilla and others. But what you do instead of that long-winded thing at the top is instead to put your theme color if you want one, but a link to a manifest. And that link to a manifest is something that you can point to from any document in your origin. And it's going to include all the stuff that you really want, but it can be extended with other stuff later. So for instance, you'll see at the bottom there is GCM sender ID. That's what we need in our demo application to make it possible for the notification API to understand, or the push notification API to understand where you're actually coming from with regards to the back end of the push system. We hope not to need this in the future, but for now it's extensible, and we expect to start to use this for more and more features that don't fit anywhere else in the platform. High-resolution icons, a long description, a location to load when you initially tap on the document in your launcher. Those are all part of the manifest, and you can even control the screen orientation. This is good stuff, and we expect that this is going to be a key enabler for making it possible to build things that feel appy. All right, let's get to the push notification bit, because I think that was the bit that you actually clapped for. OK, I don't know if that was tension because I did it wrong, or so. So what you're seeing here again is promises being used nearly everywhere. This is a little method that we've put together to request permission to do notifications. This is an existing API that we're extending for this new world. And so because it doesn't already come with promises, we're wrapping it in a promise. And again, you can create your own promises. And this is sort of how you can control inside the service worker things like delaying activation or waiting on some network or IndexedDB response for data. But we're going to request permission, and then if it's granted, we're going to vend a promise that resolves successfully with it. And I'm not going to deal at all with how to do those permission prompts correctly. My colleague Adrian is going to talk to you all about how to do that and how not to do that. And I can only say that if you do it right, it's going to work out well for you, and if you do it badly, you're going to have a bad time. So let's say that we get to the point where we've got that request. So we can request it, and then, as you see here, request, and then we can say navigator.push.register. This registration method is going to move to a different location in the API, and I'll update the appropriate things as that happens. But basically, you get a registration, and then you can send the registration ID that you get back as a part of that registration object to your server, so that your server can send things to the backhaul push messaging system and then notify you on your device. That's what allowed us to deliver a message to Chrome, even though Chrome was dead. Chrome was listening for the message that you sent, even though Chrome hadn't been started when I received that push message. So that's how we enable end-to-end push message registration. All right, on the service worker side, so by the way, there are some push notification systems that you may have used in the past which don't let you start your application when you receive a notification or a push message. That's a pretty bad user experience when, let's say, I am in the tube and it's going from hop to hop, and I've gotten just enough to know that something happened, and then I tap on it, and then it doesn't know anything about it. Instead, what we're doing here is we're allowing you to handle the push message and then create a notification yourself. knowing that what you're probably going to want to do is take that data and put it in a database and make it available for your application when it starts back up again offline. There's nothing more frustrating than seeing a notification that has everything that you wanted to see and then going to an application and then telling you that it doesn't have it. We should do better than this, and our model allows that. So the way you do it is that you get data back from the event for the push message, and you can create a notification. The service worker true thing may change in the future, but basically, you can create a notification from the background context if you have previously requested it from the foreground context. You're not able to make that request for permission from inside the service worker, so make sure you do that in your application from the pages that you're looking at. That makes sense, though, right? The user's looking at your app. You should be requesting permission to do things from inside your app. All right. And in fact, you get events back to handle the stuff that just comes down the wire, or when the notification is interacted with. This is a natural outcome of the fact that the service worker could be killed between when you sent the notification and when it came back to you. So it's a good thing to use the notification object that comes back from the notification click to go handle things. Yeah. And I wanted to just let you know that while all of this, I think, is compelling and I think is going to enable you to deliver amazing applications in the very near future, we're just getting warmed up. Darren mentioned background synchronization, and it's a high priority for us in the near future. We know that you want to be able to go update your application when you're connected to power and a network and maybe the user's asleep. We know that you want alarms. We know that you should be able to make an alarm clock application on the web. We understand that. And we're working hard to make sure that those sorts of things are available in the future. And this is just a down payment. So we're listening. The slide deck will be made available, as they all will. Jake's Is Service Worker Ready Yet website is the authoritative place to look for information about the status of the various APIs that are being added, and to understand how it's progressing in different browsers. So we're not the only ones who are implementing. We've designed this system in collaboration with our friends at Mozilla and others, and Samsung, and we're excited that they're implementing too. So thank you so much for your time and attention, and I'm excited to talk with you about how we're going to make real web apps.
So did that involve at one point screencasting from your phone to a Chromebook to a MacBook all in a chain?
I'm actually confused about what happened. I know that we got it working.
You go and have yourself a lie down to recover from that. So I've had a few people sort of excitedly ask me, like, oh, are you into trains? Because you've got the train demo. And I'm sorry to say no. I was somewhere and I thought I need to create a demo, and I was on a train. And that is the level of inspiration I have to deal with day to day. So I actually hate trains. I have to get on them every day. So Alex is on the Future of Web Apps panel tomorrow, and that's at 10:30, and I'm moderating that one as well. So get your questions in on the moderator, on Google Moderator, which is linked to from the website, or just tweet them to Chromium Dev. Right, it's time for another session before the break. We're going to talk about permissions. So TweetDeck, I don't know if you guys use TweetDeck, but it's available as a website, but also in the Chrome store. And I was looking at the reviews for this, and there's a lot of one-star reviews, and people saying, I don't trust this app because when I install it, it goes to Twitter and it asks for permission to tweet on my behalf, and I don't want that. That sounds like a bad thing for it to do. And it's a total misunderstanding of the permission, because in TweetDeck, when you type a tweet and you hit send, that is TweetDeck tweeting on your behalf. It's doing it via Twitter. And this is why I think that upfront permissioning model that Android uses, I don't think that's the right model. I think the web has the right pattern. Because if that permission was asked for when you click the send button, it would make so much more sense. You would think, oh yeah, okay, I pressed that. I want that tweet to go via Twitter. But we're opening up whole loads of extra stuff onto the platform. So here to talk about how we can give the web more power without breaking it, it's Adrian Porterfeld.
Thanks for that introduction. So as I said, I'm Adrienne, and I'm from the Chrome security team. And today I'm going to be talking to you about how to ask for superpowers, meaning all these cool new APIs that we've been talking about throughout the day. So I travel a lot too, just like Alex. Last week, I was in the Sydney office talking to the Chrome apps team. A few weeks before that, I was in London. And because I travel so much, I like to try to stay in touch with my family back at home. And I usually do that with Hangouts in Chrome. So when I want to video chat with my husband or maybe my dog who doesn't really know what's going on, I use Hangouts. And Hangouts relies on Get User Media in Chrome in order to get access to camera and microphone. And as Alex was talking about, it'd be great to be able to get things like flight updates and gate change notifications from a website using things like service workers and push messaging. And so all of these cool new user experiences are being enabled by all the new APIs that are coming to the web. So we've talked about a few of these today, and even more will be coming out. We've got notifications, and Bluetooth is in the works, things about persistent storage and background sync, et cetera. And all of these are really awesome, and I hope to see them used in all of your websites. But we've also got to deal with the fact that there are possible negative user experiences that could come along with these APIs as well. So for example, I'm one of those people who doesn't always plug in my phone, and sometimes on day 3, I'm like going around my office mates' computers looking for USB cables for power. So I don't really want websites to be draining my battery more than they really need to. So something like push messaging, while really awesome, could also end up draining battery faster than you like. Or notifications are great when you want to find out about an email or a tweet or something like that, but not so great when you're getting 15 of them in a minute to tell you all about some new product you should buy. And of course, no one really wants their camera turning on at an unsurprising time. So as a community, we face a challenge here. So on one hand, we have these new superpowers, these new APIs, that we want to be able to use to build great experiences. But on the other hand, we have responsibility to users to make sure that we're respecting their privacy, their security, and in general, their desire to have control over their devices. And also, one of the things that I really love about the web is that I can go to just about any website and feel pretty confident that at the end of the session, I'm not going to have any problems with privacy and security. I can go to little-known websites, I can try new things out, and I don't really have to be worrying about privacy and security because Chrome is doing it for me. And I feel that's our job as developers to take users' concerns into account so that users don't have to become security experts to use the internet. So our answer to this is by putting more effort into Chrome's permission model. So when I say a permission, what I'm talking about is you go to use the notification API, and a thing pops up to ask the user, hey, do you want to let a website, of course, to respect user choices and user control over their devices. And on the other hand, we also want to make it easy for developers to be able to use this permission system so that it flows well and works well with your websites. And so I'm going to be talking today about some of the things that are coming now or coming soon in Chrome with respect to the permission model. And then after that, I'm also going to be discussing a set of different tips that you can use to make your websites work better with this permission model. I'd also like to clarify that everything that I'm talking about today, pretty much, is stuff that Chrome is doing. It's not standards track or specifications type work. Those are the APIs. I'm talking about the UI and the user experience that surrounds the APIs as part of the browser. So as Alex briefly alluded to earlier, the foundation of this model is that HTTPS is going to be required for most new APIs if they touch on things that are security-related, privacy-related, or if they could be abused. And not only will this apply to new APIs as they come into existence, but we're also trying to figure out how to backport this to older APIs. So for example, Get User Media is shipping today. As I mentioned earlier, Hangouts uses it. And right now, you can use it over both HTTP and HTTPS. We're working on figuring out a transition plan to make it HTTPS only in the future. Now, let me explain why we think this is important. Let's say that I'm using Twitter, and I give Twitter the ability to take photos with my computer, to post a picture of myself or my dog or something. I want Twitter to be able to use that ability. I don't want my ISP and the people around me at the coffee shop to also gain that ability at the same time. And HTTPS gives you the guarantee that Twitter will be the only one getting access to this privilege. And the flip side of that is integrity. Like, say you have something like notifications. Some Wi-Fi provider might get it into their head that a great way to monetize is to send lots of notifications, advertising things to people. That's going to hurt your website too, because people are going to associate these low quality notifications with your website, which isn't what you want. So I want to acknowledge that some people have found the path to adopting HTTPS a little rocky, so don't panic. It's probably easier and faster and cheaper than you think. And later this afternoon, my colleague Chris Palmer is going to talk all about all the great things that have happened over the recent year and coming with TLS. All right, so now you've got your HTTPS website. So the first thing you're going to need to do is to request permission to get access to the API. So in the past, and in fact currently unstable, what this looks like is an info bar at the top of the screen that is asking the user whether to grant or deny a certain privilege for that website. As you can see, it pushes the content area down. So we got feedback from developers that info bar was being missed by users. They weren't really seeing it. So we're working on a new thing called a permission bubble. And this hopefully will get more user attention, and users will notice it more easily. So you can play with it if you turn on that flag. Or we're also going to be starting to roll it out experimentally soon in the coming months. We're still playing around with things like how to get focus right. Another problem that we had with the info bar model was that if people asked for multiple permissions, they would end up getting stacked on top of each other like this, which is pretty ugly. And if you get a few of them, it starts taking up a lot of space. So the permission bubbles will coalesce permissions that are asked for very close together in time. Users can still say yes or no to each of these individually. Another thing we're doing is looking at completely new ways to ask for permission instead of just a binary yes or no answer. So this is an example from Chrome 40 for the Chrome Apps USB API. So instead of just asking the user yes or no, like can this access USB devices, it lets the user choose which USB devices should be available to the app. Now, my colleagues are also working on prototypes of similar types of things for things like the web Bluetooth API. So you should expect to be seeing this for web permissions too. All right, so let's say that the user has made their decision. They've either granted or denied the ability to use a permission. People might want to change their minds later. We were actually asking, we ran through some scenarios with a group of users a few weeks ago, asking people whether they would say yes or no to permissions in certain circumstances. And some people expressed hesitation because they didn't know how to control these privileges. For example, this person said, and that's why I wanted to decline. I don't know how to undo. If I knew how to undo, I would say yes. So to address this, we're working on better in-page controls. I'm going to show a demo here. By the way, I'm using the same extremely, if I could switch to the projector, that'd be great. The same extremely fresh version of Chrome that Alex was using. So please cross your fingers for me. All right. So here I've got a website that's asking for access to geolocation. Thanks, it's reminding me that I'm at my own talk. Useful, right? OK, so I'm going to go ahead and allow this. Now, if you click on the lock, it opens this up the in-page controls. So this lets the user check on the security and the privacy of the connection. So you can see at the top, it's using HTTPS. So it says your connection to the site is private. And it also gives you the ability to see any of the non-default permission settings. So this one has location, because I just granted that. And from right here, you can toggle between allow and block if you want. So now I've blocked that. Back to the slides, please. Now, another thing that comes up is usage. I mentioned earlier that I'm really paranoid about battery life. Other people are concerned about things like how much disk space a website or app is taking up. Or some people are worried. They don't want to use any websites that are going to be constantly tracking their location. So our answer to that is building some of this information into site settings. I'm going to show you some mocks of our vision in this space. But just so you know, you can see some of what I'm about to talk about in Chrome 40, although it's not feature complete yet, which is why I'm showing mocks today. So if you go into site settings, you can search for a page or pick a specific permission. Here, I'll do notifications as an example. And it'll show you all the websites that have been granted access to this or been blocked. And for the ones that have access, it'll show you when it was last used. So you can see, for example, who's recently been sending notifications on your device. And if you search for or click on a specific website, you can see the history of how it's been using its privileges. You can see here in this example, it's been using geolocation. You'll also be able to see information about battery usage and data storage. And you can do things like stop or delete the data if you think that's important and you're trying to reclaim some space. So I recognize that those features that I was just talking about in site settings are not things that people are going to use every day. On an everyday basis, people want things to just work. So let me give you 2 examples. The first is Virgin America. You're traveling, you've got 10 gate changes in 10 minutes. You probably want all 10 notifications in 10 minutes telling you all about this, because this is important to you. On the other hand, let's say someone wants to send you 15 advertisements in 15 minutes. You probably don't want that. So how do you distinguish between these 2 cases? Well, in the positive user engagement case, the user really likes that website. Examples of a user indicating that they like a website might include something like it shows up in their history a lot because they visit it often. Maybe they've bookmarked it. Maybe they've added it to their home screen. Or maybe they have a login for it. So what we're thinking about doing is tying these signs of positive user engagement to thresholds for permissions that aren't privacy sensitive, but are more just annoying. So you might be able to send more notifications, have a higher quota for storage, or if they're a vibration API, vibrate more times in a short period of time. So we want to be able to sort of reward this good user experience. This is still experimental, by the way. This isn't something that we've nailed down precisely and something that we haven't launched yet. I'm mentioning it really early now because I would love to get feedback from you on what you think about these ideas. And if you could come talk to me at the booth or come to the panel with questions about it, I would love to hear your thoughts on it. We also will be recognizing user discontent. By this, I mean, I mentioned that there are 2 cases, the Virgin America case, which I like a lot, and the case of the sort of spammy website. And we want to be able to recognize these negative cases as well. So for example, users might consistently say 99% of users say no when a website asks for a permission. Or people are saying yes, but then they're going and turning it off later. These are signs that users aren't very happy with that experience. And so in these cases, we're thinking about things like lowering thresholds, or maybe not even prompting users. So again, this is an idea that we haven't exactly fully decided on the mechanics of it, but I'm again giving you an early heads up. All right, so now I'm going to talk about what you can do to build a good user experience around our permission system. First, I want to motivate that users don't just click yes, yes, yes when you ask them for things. People do think about and make real decisions when asked permission questions. So here are some quotes from users about things that they've considered when they're trying to decide whether to grant a permission. So what type of information is it going to show? Are you interested in it? Do you trust the trust source? So some researchers at UC Berkeley asked a group of iOS users to share the settings in their phones so they could see what apps they had granted or not granted geolocation information to. And we found that it differed a lot depending on, or they found that it differed a lot depending on the specific app. So you can see that for some apps, like Maps, almost 100% of users were willing to grant it geolocation. But on the other end of the spectrum, fewer than half of users were willing to grant it to some apps like SoundHound and Shazam. So the point I'm trying to make here is that the benefit that users feel they're going to get from a specific permission depends on what you tell them the value proposition is. So the first tip that we have is to provide clear value by timing the permission request in such a way that the user can connect the permission request with the feature. All right, so I'm going to do another demo here. Can I get on the camera again, please? So yes, you may recognize it. This is the same demo that Alex was using earlier. So let's see how this goes. OK, so let's say that I'm traveling and my flight's canceled, and now I'm trying to book another flight. So OK, I click on the button to bring up the page to book a flight. It now immediately pops up the question of whether I'd like Polyair to be able to send notifications. This isn't really a great time to ask about that. I don't really know what's going to happen if I say yes. So I'm going to swat it away. So let's say I'm trying to go from SFO to LAX. All right, we're going to take the Millennium Falcon. All right, here again, it pops up another permission request. And this one's a little bit better. You can see that it's at least tied to some feature on the page, but in my opinion, it's still not the best version yet. So let's say no to that. Now here, I'm going to click on the Notify About Flight Delays button. Now here, it's very clear that you've just turned on notifications for flight delays. So the user is going to be persuaded to click on Allow here to say yes, because they understand what they're going to get. Back to the slides, please. So for some permissions, like notifications, it's pretty easy to do this well today, in my opinion. For other types of permissions, it's maybe a little bit harder. So for example, for geolocation, you can't tell whether your website already has the permission before you try to use it. So some people on my team are working on something called the Permissions API. Don't copy this code because it's currently a spec. It hasn't been implemented yet. But it's coming, and you'll start seeing an implementation probably in 41. But the idea here is that it'll let you query to find out whether your website has a given permission or a set of permissions, so that you know whether trying to use it is going to pop up a permission request or not, to allow you to time your permission requests better. So for example, if you knew this about geolocation, you could do different behavior. You could show very localized stores. You could show all stores in California if you don't have the permission. Just use IPGeo instead. So it'll give you more options. All right, so the next thing you need to note is that you need to ask with a document. And this pertains specifically to service workers. If you try to request a permission when there's no documents open, there's nowhere to show the permission request. So don't do this. So I'm going to show you with a good and a bad example. A good example is, in the main document, in response to some event like toggling, request the permission there. A bad example would be when a background sync event fires from within your service worker trying to request permission. But the page might be closed. There's nowhere to show a permission request. So you will not have a good time. Do not do it this way. All right. The third thing I want to talk about is handling user rejection. So what I mean is when a user says no to your permission request, please don't break your whole website. The user might see that it breaks the feature, and then at a later time, go back and enable the permission. So I'm going to show an example of what that looks like. So here, this imaginary store is going to give you 3 options of ways to give you information about store openings. So if you click on the toggle for the first one, that opens up a notifications prompt asking about desktop notifications. So let's say I have, for whatever reason, changed my mind in this intervening second and click block. The thing you can do as a website developer here is gray out, disable the feature. So here, the rest of the website still works. You can still do email alerts or Facebook alerts or however you want. But the notification part specifically has been disabled. Now here's how you can check the states, particularly for notifications. There are 2 ways to check the states, the permission state. The first is on load. You can check the value of notification.permission. And then update the state of the toggle based on whether it's, for example, already disabled for your domain. The other is, let's say you want to trigger the request. you do notification.requestPermission, and the callback will take as an argument a permission parameter. And either way, you're able to then check the value of the permission, either the value on load or the value after you request it, and update your UI accordingly. And last but not least, you also have to remember that you need to handle revocation. So let's say a user grants a permission, but then for whatever reason disables it later. This might mean, or it even could just be that their device breaks. You don't know. So make sure that when available, take advantage of both your success callbacks and your error callbacks. So here's another example of that. This is currently in the middle of recording audio using getUserMedia. So I've previously granted the permission. But now I'm going to take it back. And the next time the user goes to click the record button, the error callback is going to fire. And you can see in the console at the bottom, say that it's a permission denied error. So this is an example of showing how you can pass in both a success callback followed by an error callback. And in the error callback, you can say disable the feature and update the UI state. So hopefully, we're able to help you as developers build good permissions user experiences. Because I want you all to be able to use these really awesome APIs that are coming out. And as part of that, you need to make sure that you're justifying to users both why you should be able to get the permission and also why you should keep it. And as I said before, we want to help you do this. So we'd love feedback, and also as these will be posted later, all of the demos and the code examples are on my GitHub. Thank you.
So Adrian is also going to be on the Future of Web Apps panel at 10:30 tomorrow. So tweet your questions, and we'll add them, and we'll ask them to the group. So our next speaker is Kofi Briak. Coffee break? Coffee break. Excellent. Brilliant. So there is something else that we're doing differently this year. Is we've got free demo stations out there by the coffee, so you can talk to Chrome engineers about a particular subject. So Ryan's at one, so you can talk to him about performance stuff. Alex and Adrian are going to be at another to talk about web apps and service worker permissions. And Rob Dodson and Mike McNulty are at another to talk about Polymer. So give them a piece of your mind, ask some questions, and we'll see you back here in 25 minutes, 11:30. Thank you.
Ladies and gentlemen, we are 4 minutes to starting. If you can take your seats, that'd be greatly appreciated. Again, 4 minutes. 4 minutes. Please take your seats. The program will begin shortly. Thank you for coming. Two minutes, ladies and gentlemen. 2 minutes. Please take your seats. 2 minutes. We're just about to start. Thank you.
Hey, come in everyone. Grab your seats. We're going to get started with the next section. So we're going to be talking a little bit about UX. I think as an industry, like, our kind of attitude towards user experiences has massively improved. Because you think about how it was in the dark old days. Does everyone remember ICQ? Do we use that as a chat thing? Yeah, yeah. Do you remember the noise it made when you got a message? Right, okay. So whoever designed that must have led a pretty rough life when they sat down and thought, oh, it should make a noise when one of my friends sends me a message. Uh-oh. I kind of want to give them a hug. You know, that's a terrible way to live. Well, here to give us hopefully a much happier story about UX. A big welcome, everyone, for Roma Shah.
Thanks, Jake. So I'm Roma, and I'm a UX lead on Chrome. So you've already heard today about all the different ways that we're tackling the web app experience from so many different fronts. And you've heard about the performance improvements, how we're bringing capabilities to web apps that native apps already have, and balancing the friction of permissions with still keeping users safe. So I'm here to talk today a little bit about the user experience front in general. We've made some pretty significant steps this year that make it easier to design intuitive and beautiful user experiences across native and web platforms. And my hope is that you guys leave this talk with a general understanding of the philosophy behind material design, some practical tips on how to get started even if you don't have a designer on your team. And I'm also going to talk a little bit about some of the Chrome UX changes that we've made in Android L that we hope moves the mobile web experience forward. So before I dig into the philosophy of material design, let's take a look at the material design reel so you can get a visual design sense of what it's about. The reason I want to get into the philosophy of material design instead of just jumping straight into the spec and giving you practical tips is that I think it's really important to understand what this design framework is trying to achieve. The spec is online. You guys could just go there right now and look at it. And it makes it easy for people to build well-designed apps. And that's really important. But what I'm hoping is that by understanding the philosophy behind this design framework, you guys can help us evolve it further. A spec is never going to be able to cover all the complexities of any app out there. And we need you guys to really kind of push on it and use it in novel ways to help us evolve it. It's a community effort. So getting into the philosophy, material design is based in real-life tactile experiences. The name material suggests this, but it was really heavily inspired by studies of paper and ink, but it's more open and imaginative with behavior because there's code behind it. So paper lends itself really well to squares, simple shapes like squares and circles, but unlike real paper, this material can split, heal, rearrange itself, and move itself about when it needs to. And while we want users to feel like they can interact with it in a realistic way, like real paper, things should always feel intuitive. So let's take an example of what it means to be material. Material design has attributes that we're innately familiar with in real life. So there's surfaces, edges, light, dimensionality, and movement. All of these things give us visual cues about how these objects relate to each other and what the affordances are in a design. Material design is bold, graphic, and intentional. It's based on the foundational elements of print design and graphic design. Typography and imagery, colors, grids, scale, and space all guide the visual design. And when used appropriately, these elements combined will really make up an aesthetically pleasing UI and a more immersive experience. But beyond the surface look and feel, when these elements are used best, they should really also have function. They should help convey the meaning of elements, the hierarchy of the UI, and where users should be focusing their attention. So let's take a look at Gmail before and after having applied these elements of design, how it affects it. There's a lot more white space, it's more readable, and with the use of color, and this floating action button, you see where the user is supposed to focus their attention to. So these elements should also provide consistency and a sense of familiarity across platforms and devices. In material design, you've probably noticed that there's a lot more motion and animation. And it's not just there for the sake of it. Motion is meant to provide meaning. So motion and animation are really meant to reinforce the idea that the user is initiating change. The user is initiating action, and they're in control. So motion cascades from touch points. Changes in the interface are meant to provide visual feedback and feel really directly connected to what the user has just done. Motion also allows us to make the experience more immersive and natural. It's no longer this, jump from screen A to screen B, but a really fluid and deliberate transition between states. Material design also aims to create a unified experience across native and web platforms and all the different device sizes that are out there. Across devices, the user is meant to be seeing the same view of the same design. And obviously, based on the screen size, the interaction and the input method that is appropriate for whatever that device is, things should change, but the colors, iconography, and hierarchy should all remain somewhat constant. All right, so those are kind of the basics of the philosophy behind material design. Now I kind of want to shift gears into how you can actually apply these principles. So the entire material design spec is up on google.com/design/spec. If you have the luxury of a dedicated designer on your team, this is the spec that they should be going off of. But if you don't, that's why we're here right now. So first of all, you probably want to use Polymer since it's, you can get it nearly for free, and it's specifically for building material design for web apps across desktop and mobile. And their website has everything you need to get started, including some really great demo apps that show you the interactive elements of material design. So Polymer is a tool, and you're actually going to be hearing more about it later. But I'd like to dive into a practical, basic checklist of how to apply material design to your apps. And the particular things that I'm going to talk about will help you make kind of critical design decisions, even if you don't have a designer on your team, and hopefully give you the biggest bang for your buck. So material design has recommended spacing and sizing guidelines, all of which are detailed in the online spec. Following these can really just help the readability and usability of your app. So components are on an 8 device-independent pixel square grid. Type is on a 4 dp square grid. And the size of structural elements are based on these things called increments. And increments are based on the standard app art height, which is 56 dips on mobile and 64 dips on larger screens. So for example, we have 3 different apps here, and they all have different needs for different app bar heights or different view heights for whatever reason. And all of these things are in increments of 2, 3, or nx the size of the standard app bar height, which is shown in the orange one on the right. There are a number of layout templates available to you on the online spec for mobile, tablet, and desktop. And they give you an idea of how keylines and spacing can work across screen sizes, window sizes, different structures, and different elements. And if you're building an app designed for touch input, you should really make your touch targets 48 by 48 in DP, whether the icons or elements within that 48 by 48 take up that full space or not. So Polymer has a lot of components that you get for free. You should take advantage of those. This includes icon sets, widgets, elements, and transitions, all based on material design. I'm going to take a second to call out one of the specific components that's pretty recognizable in material design, and that is the floating action button, or FAB, or paper FAB. This thing is supposed to be the main and iconic action of your app. It's not supposed to be any arbitrary action, but something that a user can really look at in one glance and understand what is your app about. So for example, we have this media app here, and a play pause button really gets the essence of what this app is about. In the Maps app, you have a driving directions button with a car. You really get a sense of, like, this is what this app is about. You should only ever have one of these components on the screen at one time, and you probably don't need these floating action buttons on all of your screens within your app. Colors. So material design has a lot of color palettes that you should take advantage of. I do want to stress, since it's come up before, that the material design color palette does not equal the Google design color palette. This thing has plenty of range to fit any app's branding and style needs. So it's easy to start with the primary color of your app. This is usually going to be the brand color of your app. So if the brand of your app is red, let's say, this should probably be red instead of indigo. And then we have this notion of accent colors. So accent colors really should be bright, not dull or dark, and they're really used for buttons, UI elements, and components that you want the users to focus and guide their attention to. The material design spec recommends a stack of Roboto, then Noto, then sans serif, that's the font stack, at least for body size text. But we do acknowledge that fonts are often inseparable from branding. So if you have a specific font for your brand that really you want to use everywhere, we recommend using it for display size text, not for body size text per se. But regardless of the fonts that you use, you really should use the sizing and spacing and weight and style guidelines that they have in the spec. They've made it really easy for you guys to just take that, and there's tons of typography nerds that have worked on this stuff. All right, depth. Dimensionality and shadows and depth are very important in material design. So it helps to think of your UI as existing in Z space, not just X and Y. So depth shouldn't just be ornamental. Depth should be giving users hints of how sections relate to each other and move in ways that seem plausible. Once you understand the relationship of how sections in your UI relate to each other, then you can start adding shadows and dimensionality to things. So for example, on the left, you see if there is a shadow there that makes those two sections look somewhat separate from each other or somewhat of a gap, it's natural for the user to assume that if I swipe one of those things away, that the other one may remain and moves independently of the other. But the one on the right, the seam between them is like a very light line. They still feel like they're coplanar on the same section, and you would imagine that if I swiped one of them in one direction, both of those things are going to go in the same. The Z position is also meant to be a reflection of your content hierarchy, and you're probably going to use it with content that you typically want the user to be focusing on, such as dialog boxes or floating action buttons that we were talking about earlier. And this Z depth hierarchy isn't necessarily a constant or fixed thing. For example, when a user selects a date from calendar and it expands and moves forward from the grid. So really make sure to thoughtfully consider what Z level each section of your UI is in, and make sure that the shadows it casts are appropriate, the movement is plausible, and in Polymer, in fact, you can use the paper shadow element to create Z depth and animate between Z of 1 to 5. So motion, as we talked about earlier, is also very important in material design, but it's also one of those things where it's really easy to go overboard with. So transitions and animations should be very deliberate and meaningful, but not necessarily gratuitous. A lot of the motion that you've seen in this presentation today required a non-trivial amount of work from motion designers specific to that role. So if you don't have dedicated motion designers, or you just don't have the time to finesse these things on your own, I would recommend just not worrying about it. It's better to stay simple than to spend a lot of time and effort making all these motions and animations that end up being more distracting than helpful. And also, you're going to get a lot of transition and animations for free from Polymer with the various UI widgets and elements. So if you do implement custom animations, we recommend that they be smooth, mimic true physical motion, give hints to your users about how this app works, and then also reflect users' choices and actions. All right, so now that we've covered the basics of material design, I really want to talk about some of the big changes that we've made in Chrome. So first, let me start by saying that applying material design to Chrome has been a very interesting design exercise for us. We really like to think of Chrome's core UI as a container for your guys' app and your guys' content, and we usually strive to be as invisible as possible. An approach that we've landed on is to begin to apply material design, starting first on mobile, using these core foundational elements that we talked about earlier. But on the core parts like tabs, the toolbar, and the Omnibox, we're still going to remain much more visually subtle than what an individual app might be doing. So we basically want our UI to be there for users when they need it, but most of the time they should be looking at your content, not Chrome. So beyond material design, some of the stuff that we've been doing is looking at how to make your apps fit more naturally and intuitively and beautifully into other platforms. So that brings me to some of the big changes that we've made in Chrome UX for Android L. First, the most visible change that you'll see here is that we've taken tabs outside of the Chrome app and put them at the same level as your recent apps in the overview. And so this is a pretty big change to the user experience of the browser, where we separately have a separate browser app that you go to. But we're really excited about this because it brings visibility of web content, brings visibility to web content, and it actually unsilos the web from a browser app. And for users, we think that users shouldn't have to think about the technologies that apps are built on. If I'm planning a dinner with my friends and I'm looking at restaurant reviews on the web, I'm talking to my friends on my native messaging or email app, I'm going to be switching back and forth between those and planning this thing. I'm thinking about my task. I'm not thinking about like, oh, okay, that thing is on the web, so I need to go to the browser for that. That thing is native, so I need to go to this other switcher for that. So we want to have one single place to switch between tasks. And in addition to this new home for tabs, we want to continue to make steps to level the visuals between native apps and web apps. So you've noticed in material design in Android L that apps have really boldly colored toolbars. And starting in version 39 in Chrome for Android, you'll now be able to use a theme color meta tag to set Chrome's toolbar color, giving you more control over the look and feel of your content. The theme toolbars will be visible not only in the browser view, but in the recent overview section as well, to help users with recognizability. Of course, what you do here will really depend on the design of your content. You may not want to have like multiple bars of really boldly colored things. So if you choose not to use a theme color, we're still going to be the same default gray that we are right now. So the syntax is pretty simple. You add a meta tag to your page's head with the name theme-color and set the content to any valid opaque CSS color. Chrome will also show high-res favicons in the overview, just like native apps have. And we pick the highest res icon that you provide, and we recommend providing a 192 by 192 PNG. All right, so all the details for that are on HTML5 Rocks and the Web Fundamentals site. So I hope I've helped you guys get a bit of a grasp on the efforts that we've been doing from a user experience front to move the mobile web forward. Material design is basically a framework that helps anyone really make thoughtful and well-designed apps, whether they're built natively or on the web, with a really small amount of effort using the tools and specs that we provide. And the changes in Chrome for Android Lollipop are our first steps to give you guys more control over the look and feel of your stuff and really simplify the workflow for our users who don't really care whether something is native or web. They just want to use the stuff that they care about. And even more importantly, what we need from you guys is to test out these changes in Chrome, the material design framework, and really, really stress test them with the complexity of your apps, give us guidance and feedback, and that's the only way we're going to be able to move the mobile web user experience forward. Thanks.
Excellent stuff. So Roma's on the material design panel at 2:15 tomorrow afternoon. So if you have any questions, yeah, put them on the moderator or tweet them to Chromium Dev. And thank you so much for all the questions so far. Yeah, make sure you don't give the panelists an easy time of it tomorrow. Well, we're getting set up for another performance talk. Well, while you're setting up, I'm going to share with you a lifestyle tip. Because I've been optimizing my life recently. I bought an exercise bike. But it's kind of boring, right? Because it's like a bike that doesn't go anywhere. It's terrible. So I thought, what can I do at the same time? And I've tried like TV shows and other things, but I've kind of settled on playing PlayStation at the same time. I really recommend it. So it's a great thing to do because it turns every game you play into 2 games. Like the first game is like defeating the Spanish Navy using a combination of stealth and swordplay, and the other game is don't sweat into the controller because then it stops working. And it doesn't just stop working as well. Like you'll kind of be stealth creeping through some shrubs, and all of a sudden your character just stands up, looks down, and then runs into a wall. So I have actually killed a PlayStation controller this way. Okay, so on Chrome Developer Relations, we have an excess of polls. I think it's fair to say. We've got the Kinlan, the Irish, Backhouse, and the Lewis. So we figured we better let one of them on stage. So, everyone's favorite Paul, unfortunately couldn't be here, so instead, here's Paul Lewis.
Can I just say up front, it is actually part of standardizing the platform to make everybody a Paul. All right, so it gives developers a reliable and convenient way to access developer relations if we just say everybody's a Paul. So welcome to this session on the applied science of runtime performance. And by runtime, I kind of mean rendering. I basically mean anything that isn't page load. As Jake said, I am one of the Pauls, and I work on the developer relations team. And normally I focus on both performance and design. And when I normally do my talks, I do these fairly theoretical, kind of architecture-based talks where I talk about pixel pipelines and architectures and how you get stuff on screen. And no. This time, I'm going to do something completely different. I'm going to do an applied sciences talk. I'm going to step you through the process of building something from my point of view, my own personal journey, which is something of an experiment for me, because I don't normally sort of put this out there. And like all good experiments, sometimes they go a little bit wrong. But hopefully it won't. So we're stuck with it now, so let's find out. Hopefully, by now, most of you have seen this. It's the Chrome Dev Summit site. I designed and built the thing, and I set myself the... Oh. I can see this talk is going to go well. I won't be covering like the nitty-gritty details of every aspect of it, but I wanted to step through the thing that gave me the most challenges and the most interesting thing that I could share with you on that journey. And it's this. It has this hero takeover effect with the cards. Okay, there we go. That's it on mobile. And because we're responsive, of course, this is it on desktop. Same kind of deal. Now, what I want to do, first of all, is I want to kind of step through what we call the natural way. So I think this is the way that most of us would think to solve this problem. We have a box that's moving on screen. It's getting bigger. So probably we think, right, let's do this with CSS, because we've heard that this is good for performance. So we'll transition on width, on height, on left, and on top. That seems like it'll do the job. Unfortunately, it gives us 2 problems. And we'll step through those very briefly. Firstly, let me show you this. This is a site I built a while ago called CSS Triggers. You can find it at csstriggers.com. And what you can do is you can find any given CSS property, and it will tell you what workload it triggers in the browser. So things like layout, paint, and composite, for example. And when we're building fast-performing sites, we want to trigger the least amount of work possible. Now, unfortunately for us, when we use left, top, width, or height, we trigger layout, which is the geometric calculations of where everything is on screen. We have to paint, filling in the pixels, and then we have to composite the page together. And basically, when you've got a reasonable sized DOM, this is what the frames per second looks like. Now, if you can't see, let me zoom in for you. This here is the 60 frames a second line, which we're obviously aiming for. And you can see that when I transition on width, height, left, and top, that essentially we're pretty close to that 60 frames a second line. And that's not good, because if we have garbage collection or we have a freakishly long paint for some reason, then we're not going to hit frame target and we're going to stutter. So we're putting the browser under strain every frame. So if you don't normally do the DevTools thing, I highly recommend this. Go into the DevTools, go to Timeline, hit record, do whatever it is that you do, like scrolling or whatever, and look at the bars and just see how close you are. Are you going over the 60 frames a second line? Are you under? How far under? It's the first line of defense to building a really nice, smooth experience. So that's one thing. We're pretty close to that frame budget. Here's the other problem. Changing width and height puts you into pixel rounded kind of mode, which means that even if you're getting 60 frames a second, because things are moving per pixel, they actually look like they jitter a little bit. That's what it actually looks like to me. And I don't like that. Personally, I think it's jarring. It actually looks like it's jank, even though it's actually doing pretty well. By comparison, you get sub-pixel rendering when you change a transform. And this turns out to be quite useful for animations. So that's a thing about the platform. I don't know. So I want to talk about the unnatural way, or I'm going to call it the other way so I don't feel so weird about it, the way that I actually end up building that effect. So I'll step through the outline of how I went about this. So it starts with this function here, which is collecting the properties. So we're going to expand the card, which means we need to figure out what we know about the card. So collect properties, it takes an object on which we're going to store all the things that we collect about the card. So what are we collecting? Well, first of all, we need to know what we're collecting on, and we collect on things like the title, the icon, the content. Anything that's going to animate in the card, we need to track. And the collect properties looks like this. You see here I have the bit where I ask for the individual elements that I'm interested in tracking. And then I ask for things like the left and top and the width and the height of all those things, which I get through this, get bounding client rect, which if you've never used is brilliant because it gives you an object that looks like this with all the correct numbers in. And I have a disconcertingly large amount of love for this function because it is so unbelievably useful. So big thanks to the IE team, because I believe that was IE4 that landed. Well, I never. Yeah, next week on esoteric functions. OK, so once we've collected all the information about the card in its collapsed position, we now just expand it out completely to its final resting place, like so, like this. And we collect all the positions again. So now we know where you started, and we know where you finished. And of course, we've let the browser do all the work in the middle. Like, I don't say how wide or high. I asked the question, how wide and high? And I collect it. So it's in this final position. And now I calculate where everything moved. Okay? And then I apply a transform to reverse it. So it looks like this. Now, this all happens very quickly. You might not have seen this effect on the site because it doesn't happen like this. And you might look at this and you go, OK, it looks roughly in the right place, Paul, but there appears to be quite a lot of pink. That's right. But if we clip it, shazam, there we go. It's like it never happened, right? The good thing about this particular approach is now we're ready to rumble, because all we've got are transform and opacity changes that we've applied. And that means we're nice and compositor friendly. If you look at csstriggers.com and you type in transform, it'll go compositor. That's it. And compositor stuff typically is very fast today. So we switch on animations, and we just clear out all those transforms like this. Like here, this is the function that does it. Translate to nothing, scale to 1, and go to your final opacity. And it gives us, oh yeah, we also animate the clip around the whole thing, by the way. Should mention that. And it gives us the effect that we've come to know and love. And I think a good question at this point is, why are you doing it this way? It's like way more work, right? It's way more work. And you're right, and it is more work. And my hope is that the natural animations way will become faster. And as you heard this morning, we're investing a lot of time and effort into making that a reality. But this is my journey through building this, and this is just the state of things as they are. Anyway, it is more work, and to kind of summarize my feeling, actually, there is a quote from John Gruber recently that I thought was excellent in this regard. He said, the point of making apps shouldn't be about making life easier for developers, in this case me, it's about making the best possible apps for users, in this case you. So yes, it is definitely harder, but you can encapsulate this into a web component and then never worry about it again and give it to other people, and they never need to worry about it again, which is like kind of what Polymer does, and it's pretty cool. And I generally think that performance matters, right? It matters to users, as we heard this morning with the takeover, the hero effect. Users really feel it. They may not be able to say what it is, but they feel it, and it matters to them. They want something that feels great to use. So I think it's worth the investment. Anyway, this way is actually faster than the other way. Let's look at the timeline again. And you see now we're way lower in the middle. I say in the middle because the eagle-eyed amongst us will be saying, surely, Paul, this is bad. And that's a fair question, I think. And so to answer that, I want to introduce you to what I call the Picasso principle, which is this. Learn the rules like a pro so that you can break them like an artist. It works for anything. Write it down. You can go back to your office. I'm like an artist. I'm an artist. It works very well. You can be like, you can say, Archimedes said, use will change sparingly. He didn't. But Picasso did say this, and yes, learn the rules like a pro so you can break them like an artist, which is not to say I'm an artist, although I'm pretty handy with crayons. It's true, it's true. I actually drew this, and my son looked at it and went, Daddy, what is it? It's a picture. It's better than yours. Anyway, didn't say that. All right, so these rules, right, that we're going to break. They're not my rules. I don't really go in for rules, but they are things that you hear when you're learning web development. And they come from a good place. They come from noble intentions, but I think we can break some. Let me show you what I mean. Rule number 1, no frame should ever exceed 16 milliseconds. Right? It's actually pretty good, because we want 60 frames a second. 1 second divided by 60 gives us 16 milliseconds. But it's actually not the whole picture. What I mean by that is this. When the user taps or clicks on something, we actually have 100 milliseconds in which to respond before the user goes, that didn't respond, did it? So we've got 100 milliseconds that we bought, time-wise. The animation starts, the animation runs and ends. And then we have a little period at the end where we pick up the pieces and go, OK, before the user actually notices that the animation's ended, we've got this little window here. It's only this bit in the middle that needs to be 60 frames a second. So if we bring back that timeline snapshot, you'll see that it follows that pattern very closely. The beginning where we do all the measurement stuff, all the toggling of classes and so on, that's that bar on the left, and it's roughly about 71 milliseconds on a Nexus 5. I've memorized the number. It's not like I'm looking at the bar and I've got some freakish talent where I can tell you how long a frame was just by looking at the bar. And then at the end, it's about 43-ish milliseconds. So we're inside that window, that model of where you can say, actually, before I kick off an animation, if I have expensive work to do, I should do it now so I can run cheaply through the middle of the animation, rather than going on every frame, I should do expensive things, because then you're much more likely to hit problems. So then, rule number 1, no frame should exceed 16 milliseconds. No chance. Of course, there are times, you want to be 60 frames a second all the time. Of course you do. Why wouldn't you? But there are times where it matters more than others, and during an animation is where it really matters to the user's experience, and that's the thing to concentrate on. You do have these little windows of opportunity during kind of idle time and so forth, where you might be able to do expensive work and save yourself some hassle. By the way, when I say animations here as well, scrolling should be considered an animation. Things are moving on screen. So don't, in that sense, treat scrolling as a separate thing. It should scroll at 60 frames a second. OK? So you might be wondering then, were there any other rules that you decided to break during this build, Paul? Yes, indeed, there are. Because I named that one rule number 1, so it follows there may be other rules. Rule number 2 never trigger a forced synchronous layout or layout thrashing. You may have heard it called that. Who would do such a thing? Let me show you the card expansion code again. So to recap, collected in its collapsed position, expanded in collect again, calculate where we move to and reset it, switch on animations, and go out again. The problem is in this section here, and particularly these two functions, because they set the transforms and opacities. Now, because of the way the browser is optimized, it defers those to the end of the frame. And unfortunately, the second one now stomps over the top of the first one, and it's kind of like the first one never happened. So we set our card to its expanded state. We then applied a transform that did nothing, and the net effect is no animations whatsoever. Boo-hoo, boo-hoo. What we need to do is we need to force the browser to realize that we set some styles before we start changing them again. And this is where the forced sync layout would help us. And to do that, we can add something like this, which asks for something like a width, a height, a padding, a margin, the bounding client rectangle. Anything from CSS triggers that tell you it triggers layout would probably be enough to get this. So never, ever, ever force a sync layout? Never trigger one of those? You can call me Pablo. It works because I'm Paul, not because I'm an artist, although clearly I am. There are subtleties here that I do need to call out. Firstly, I'm only doing this in that long-running first frame. That 100 milliseconds that I have as a window, that's my opportunity to do this kind of work. As dangerous and expensive as it might be, that's the time to do it. The other thing is I'm not doing it repeatedly, which would be very bad, because if I went read, write, read, write, read, write, that's causing the Chrome to do an awful lot. It's causing every browser to do an awful lot of things that you don't want it to do. OK, so caveats out of the way. So it's all plain sailing, right? No. Let's hit pause a second. There is a slight problem, and I want to show you. Again, this is all about my own kind of, it's quite cathartic, this. It's like therapy. Not everything is jank-free. Things are miles better than they were, but there are times where it janks. On every browser, at some point, it does jank. Let me show you what I mean. This is occasionally in Chrome. Now, you may have seen it stutter there. I'll do it in slow-mo, and just bear in mind that jank looks even worse in slow motion. OK? Oh, every time. Come on. I feel like it is my fault. I should say that. Right. It's also bad in other browsers. Let me show you in mobile Safari. Like that. Does that as well occasionally. So, same kind of deal. Let me show you why that is. It's because of this line here, when I said I animated the clip that was around the box. Clip triggers paint. Again, if we look back at CSS triggers, and we look at that, that's its profile there. It doesn't trigger layout, but it does trigger paint, and it does trigger compositing. So on non-Chrome browsers, it always causes jank. It always causes problems. And on Chrome desktop, it's typically fast enough to not be a problem. On Chrome and Android, it's only occasional. And it's better when there's GPU rasterization switched on, in which case it is significantly better. So that's really nice. But to be completely honest, I was on the fence about the whole effect, because maybe I should just kill it. Maybe I should just scale it back. And that's where it brings me to sort of rule number 3, which is never sniff the user agent string. Don't judge me. Don't judge me, all right? We're all friends, right? OK. The card JavaScript file, I have this flag in it, and it says, run lo-fi animations when you can't cope with fast clip animations, OK? Which is effectively a wraparound way of saying, today, is it Chrome? I've named the function like this because my intention is to keep this up to date. My hope is that every browser will get better at dealing with clip animations. But right now, this is the state of things. And I don't just want to, I just don't think clipping is something that people have really tried to do a lot of, whether it's overflow, hidden, like animating these things. But as these effects start to open up to us, which they are doing, then we're going to try more and more of these things. And that's a really interesting place for us to be. So this is what it looks like on desktop Safari. It's the same on mobile Safari as well. You see that? There we go. And it's no bad thing, actually. It runs well. It does the effect nicely. And I think this, for me, was the important distinction, when I was sort of reasoning this out to myself, is that I don't use it to redirect you to an MDOT site or to say, no, you can't have the thing. What I'm trying to do is trying to just give you something, but because I'm confident that you can't have the fast clip animations, I just don't want to ruin your experience. So for me, that's kind of how I've thought about this. So I think in very specific circumstances, you might feel OK about UA sniffing, but then I would say that, given that's what I did, right? So you may disagree, and I'm 100% cool with that. I think the question, though, for me, or maybe, why even leave it in if it's not perfect everywhere, Paul? What were you thinking? And I want to explain why I did. Firstly, I think it's important to push boundaries. It's partly my job, but it's also partly what I think we need to do as an industry. We need to find out where the boundaries are. We need to say, this is the kind of thing I want to make, and push. I think that's a good idea. I think the web deserves those great user experiences. And I think it can act as something of a signpost as well. Like, these are the kind of things you can do on the web. Secondly, it does hit 60 frames a second. I'm quite tough on myself. I'm a bit of a perfectionist. On desktop, it runs very well. On mobile, it typically runs well as well. It's just occasionally. I believe it will get significantly better, not only through GPU rasterization in Chrome, but I think every browser vendor has got very smart people working on these kinds of problems. And lastly, but not leastly, I like giving Chrome engineers headaches. Why is this slow? I'm kidding, of course. Or am I? One thing I want to say about all those rules, or any received wisdom, is if you decide to go against it for whatever reason, you're responsible for it. In the same way, I'm now responsible for the Chrome Dev Summit site. And if browsers fix their performance issues in this area, I will have to keep that function up to date. That's my responsibility, and I believe that's the responsibility we have. It's important that we make sure that our stuff does the most that it can, and we don't just sort of launch and forget. So I think that's something that I really wanted to kind of call out. So yeah, I will be keeping that code up to date, because it's not future-facing, so I have to drag it into the future with me. OK, cool. So a guided tour through building this. Just that. Just that. There we go. It's great. So I wanted to cover off a few other bits and pieces, sort of related to the site, but also sort of related to the whole sort of runtime rendering stuff that I think is helpful. Let's talk about debugging animations for a second. It's hard, isn't it? Good news. Right, this is pretty fast, right? Ta-da. If it runs, gonna run? Yeah, OK. Pretty fast. There's a good experimental feature that we're on the process of making here in DevTools. Yeah. And I can go in and I can switch down the global playback speed here of the animations. And hit that. Wait, gonna pause it now, because I want to do that. I just want to pause it. Just wait there. Hold off. And then, yeah, come on. And then I can inspect the element itself, which I think is this one. And it tells me all the animations that are currently on that and its children. And as I roll over each one of those, it's going to show me which element it's referring to. I can dive into one. I can scrub it back and forth. And I can also inspect the actual properties at that point and say, what values do you have? Now, this is not ready just yet. It's experimental. We wanted to give you a bit of a sneak peek, show you what's coming down the wire. We know that debugging animations is hard, and we're doing a lot of work to make it far easier. So that's going to be a lot of fun. Next thing, Alex actually mentioned this earlier, but I did wanted to call it out. The site will run when you're offline. Now, at this conference, the Wi-Fi is really good. At not every conference have I been to that I could say the same thing. And so for me, a conference site that works offline is actually really quite useful. And of course, it is because of Service Worker. Now, Alex did a great job of kind of talking you through all that stuff earlier, but I did want to kind of add my own little bit that I am using it. It's a kind of let's call it an app cache replacement. I don't know. It's about resilience for bad Wi-Fi. and fast bootstrapping of the site rather than anything more adventurous. And it's really quite simple on the inside. On a fetch, I basically say, do you have something in the cache? If yes, return it. If no, go and fetch it. And then when you've got your answer back, assuming we can cache it, and then return it. It's pretty simple, and I kind of like it. Another reason I really like Service Worker, personally speaking, is this. I think historically we've been in a situation where we've been very network bound. It's like having to install an app every time you want to use the app, right? And I don't know about you, but when I have a native app open that does pretty similar things, and I'm trying to decide which app I want, I don't go, you know what? This was 3.2 megabytes from the Play Store. This was 4. I can't deal with it. No, no, no. I basically say, look, this has a better user experience. It's got a better design. It's got a better feel to it. I like this one more than I like this one, okay? I think that's an important distinction. Service Worker has the potential to give us these fast bootstrapping, fast launching experiences. Now, I should say that it doesn't do away with the network concerns we've had so far because you still got that first load where you need to get your Service Worker in place. But the future, the sort of second time onwards, then it starts to get a lot better. And I think for me, that shift of saying, you know what, like when two sites or two apps, web apps, do similar things, the differentiator becomes the runtime. How well does this thing perform? How well is it designed, and what's its user experience like? I think that's really cool. Other thing that people have mentioned to me in the past is that it's very difficult to kind of figure out in the wild how you're doing from a frames per second point of view. So it's OK, you've got DevTools timeline, and that's great for your machine, and maybe you get a little bit of stuff going on in your device lab if you've got one. Great. But what can I do when I've got thousands, tens of thousands, hundreds of thousands of users out in the wild? Well, this is where the frame timing API could help us. Now, just to warn you, it's in sort of spec state at the moment. It's being discussed by the W3C, so bear that in mind. This is the W3C repo, which has this address. It's on the W3C, frame-timing. There's an explainer doc there. There is the latest draft of the spec. So you can go and dive into that and figure out a little bit more. But I want to give you the kind of elevator pitch for what you get with it as it stands. So there are these renderer or main thread events. So main thread is where your JavaScript runs, where style calculations are done, where layout is done. And you can ask for these records. And each one that comes back looks a little bit like this. There's a unique number for each frame. It has a start time, and it has a CPU time. Now, you could use this to kind of step up. Say if you've got an array of these, does the start time go up in 16 or so millisecond intervals? If so, I have something that runs on the main thread at about 60 frames a second. But more than that, with the CPU time, I can figure out how comfortably or not I was doing this. If I have a CPU time of near 16 milliseconds, I'm really close to that boundary, aren't I? And there's not a lot that might push me over. Okay? Whereas if I've got low CPU time, then I'm making it with ease. And with lower CPU time, of course, hopefully becomes lower battery drain as well as a bonus. So you get a lot of information just from these three things. But you can also ask for compositor events from this as well. So with the compositor thread on Chrome on Android, that's where the painting and rasterization, well, it depends where the GPU raster's on. That's where painting happens, and it's where compositing happens. And the events for that look like these. Again, they've got the same frame number system, and given the way compositing works, sometimes there are multiple composites per main or renderer thread event. And so you can tie them back with this number. How many, I've got a bunch of these for 120, tie them back. And they also have the start time as well. There is some discussion, I believe, as to whether there should be CPU time here as well. So if you feel strongly either way, that's what the GitHub repo is for. That's what the issues are for. Go and make your voice be heard. So it would take a while for me to explain exactly what you could do with all this. But here's some ideas. You could track the frames per second of your JavaScript and your CSS animations. You could figure out, hey, when a video is playing, the side navbar doesn't run very well. You could track your scrolling performance. OK, it scrolls fine on our machines here, but for whatever reason, on these devices over here, it doesn't scroll well. You could beacon that data back to analytics. So on aggregate, you could start figuring out that people in a particular part of the world are using a device that you don't have in your lab, now would be a good time to go and buy that and fix the issues that they have, and you can start doing this much more broadly. And then lastly, you can automate and you could alert on regressions. The new person joins the team, they're well-meaning, they add will change to everything, everything collapses, and you go, what happened? Hopefully, you can catch that early before you deploy, get in. So, frame timing API. I think that's really exciting. I'm really looking forward. I hope this ships. I'm just wanting to give you the heads up that it's something that's being discussed. Right, coming back to the site, there is one other thing I wanted to mention. It's open source. You can learn from my mistakes, my successes, and I would love for you to do that. The code is as neat and tidy as I can muster, but it's not bad. You know. Please do take a look. It is on GitHub, Google Chrome, Dev Summit. There was another commit I did this morning, which fixed a bit of an issue. You know, I'm keeping an eye on it. You know, they're interesting things. Main things I would look at personally, the card.js file and the service worker. Two really interesting bits, but there are interesting things in there about how I manage URLs. So I'll leave that one as a bit of a tempter. Go and have a look, it's really cool. So to finish up, I guess my journey, the conclusions I drew from it were that you should push boundaries. Like I said, the web, I believe, deserves these fantastic user experiences. It deserves us pushing really hard on this. Good performance, though, isn't always easy, and we are doing a lot to try and make it easier, to try and make that natural animations way just the way that you do things so that you don't have to keep in your head all these different ways of doing things. It isn't easy, but it is absolutely always worth it. I take from the clap that you gave me earlier, which I really appreciate, that you like the site. And so for me, I can now tell you for definite it was worth it. Because as I would always say, performance matters, as you've shown me. Thank you.
Yeah, I think the best thing about the Dev Summit site is you got to use the CSS clip property, right? Yeah. It's kind of like a special treat when you get to use that, because it's mostly useless.
Can I be like an engineer, and one of the Chrome graphics engineers went, what? I've never heard of this property. I was like, I know, I discovered it myself. There's a new one, clip path. It's deprecated, it's clip, but everybody supports it, so
Only Firefox supports clip path, yeah.
It's going to keep showing up in the stats so they can't kill it. Anyway, I'll shut up.
Well, so you're using that user agent sniffing at the moment.
Yes.
Is the frame timing API something that could replace that? Could you detect that this animation is running slowly, therefore drop it?
Dude, I never thought of that. Yes.
Yes. We've solved the web again.
Go, if it's not running well, maybe switch to lo-fi.
Okay, you're done now. Go away. So yeah, Paul's on the performance panel at 12 tomorrow, along with engineers working on network and graphical performance. Go and go and get yourself set up over there. So any questions about the stuff that you saw there, like the animation DevTools stuff, or how to get to 60 frames a second? Yeah, do put your questions on either Twitter or on the moderator board. Oh, okay, so are we set up and good to go? I'm going to assume no. How's everyone doing? Is everyone okay? Yeah? Applause is good, I assume? Excellent. Well, so if applause is good, then about 10 people are doing fine. The rest of you are having a horrible time. Okay, well, fair enough. Well, hopefully our next speaker can change that. I think one of the huge problems we've got with the web at the moment is unencrypted traffic. And it's not just stuff that we send to the server that we want to keep safe. It's also stuff that the server sends us. Because if you go to something like most news sites, BBC, The Guardian, they're served over HTTP, and you have no way of knowing that information that came to you is what they sent. And then we've seen stuff with not just routers or ISPs messing around with stuff, but also governments as well. And I think it's really important that we can get to a situation where we can rely that the stuff that is on the screen is definitely what the author sent us. So to tell us how to do all that, big warm welcome for Chris Palmer.
Hi, everybody. Thanks for coming out. Hopefully you're having fun. And hopefully you won't scream and cry. I noticed that when Alex said you have to have HTTPS for service workers, and when Adrienne said all the cool new APIs need HTTPS too, I'd like to thank you all for not screaming. Maybe you screamed inwardly, but I really appreciate it, because A lot of times they're screaming. So I want to help you find out how to reduce the screaming. And the good news is we can. So first, I'd like to pitch why you need TLS. So I'm going to be focusing mostly on the performance aspects, but first I should motivate it. So as you may know, Chrome has the 3 goals of speed, simplicity, and security. And I'm on the Chrome security team, specifically the secure usability team. But all those things have to go together. We can't have an easy, fast path to crash into the wall. We can't have terribly slow safety. The safety can't be too complicated. So unless all those 3 things are working in harmony, we and our users are going to be really sad. So I'm going to try to combine them in a way that works well for everyone. So why do you need TLS? I'm speaking today to you as website developers, and I want you to think about the needs of your users as well. So your users care about the data that they're storing in your application. If your application matters at all, then it matters to people who care about the privacy, the correctness, whether or not it's been mangled in transit. Even if it's just a news site, it matters that they're seeing the true news. And sometimes the news gets falsified, and it really does happen. For example, the AP's Twitter account was hijacked a while back and caused a 2 seconds long huge dip in the value of some stocks because of a false tweet that was sent out. And someone made a lot of money in those 2 seconds. And so we want the news to be true so that that kind of thing has less chance of happening. So any app, even the simplest just publishing facts app, should be safe. And if you went to all this trouble to animate your UI nicely and to have cool graphics that fit a material design specification or whatever it might be, you went to a lot of work. And you want your users to see the true work that you've done. Unfortunately, when we don't use a data channel that provides authentication and data integrity, people between you and your users can mangle that experience. And in fact, mangling the user experience is other people's business model. Messing with your business model is someone else's business model. Here's an Ars Technica story about how Comcast is doing that for their own gain. So if that little thing appears over your nice animations, your users aren't going to have a good experience. So you want what you built to get to people. You also want your privacy policy to have any meaning at all, which requires the basic bare minimum of security that TLS provides. If you're monetizing your site, and I hope you are, so that you can all continue to have food and rent, either people are paying for it directly, and obviously you need to secure people's payment instruments, whether it's credit cards or PayPal or whatever, or if you're monetizing by ads, you want to monetize your ads and not the ads that random people are inserting, which incidentally is a business model. So here's a person on Stack Overflow asking, I'd like to monetize, I'm giving away Wi-Fi, and I want to make some money on it. How bad would it be if I took people's AdSense IDs and put in my own? Would I get in a lot of trouble for that? And obviously the answer is, what the hell, man? So, but people are doing that. People want to do that. When I've given forms of this talk before, I used to show, I was at a free Wi-Fi cafe in Austin, and they were inserting all sorts of goodness on the front page of Google, including enticing me to download software, which was possible back then. This is many years ago when Google search wasn't on HTTPS. And so people have been doing this for a long time. It's a stable strategy, so we should all get together and make it not a stable strategy. So TLS is good. It's good for you. It's good for users. It's good for your business. But let's get to the performance part, because it's a big concern that people have. Is this going to kill my speed? You know, we've talked about we want rendering to be fast. It has got to be paper smooth. And if TLS messes it up, then I'm in trouble. So let's figure out why not. So HTTP 2 is the new fancy HTTP version. It's coming up. We've built previous demo versions of it before. You may have heard of Speedy. Google is using it for lots of its sites. Chrome supports it. I think at least one other browser does. And HTTP2 is being standardized. And we've experienced great results, speed improvements when we turned on TLS. And there's important reasons for that. So the first web was for documents, HTTP1. HTTP2 is about applications, and it's tailored to the needs of dynamic applications like real appy apps on the web. So that requires that it perform very differently on the network than old-timey document-based HTTP. So HTTP2 brings a couple super important features to make apps responsive on the internet. One is multiplexing. So if you think about HTTP1, you have this nice feature where you can establish a TCP connection, and then you say get / and then they give you the answer. And if you want to save the cost of having set up that TCP connection, you can send another get or another post or whatever. And that's very cool, and it helps. But we need more than that for these super responsive, modern 2014 apps. So for that, we have multiplexing in HTTP2, where you can, it's kind of like, in a sense, it's kind of like streams within a stream. If you ever heard of SCTP, it had a similar idea. So you can, once you set up your HTTP connection to a server, your HTTP2 connection, you can interleave requests and responses at all different times over the same connection, and it can live really long, and it can be sending tons of stuff. Not even simple documents, but constant streams of video streaming interleaved with your get the icon, get the avatar, post a comment, all happening on the same HTTP connection. So that's a huge, sort of like a huge improvement over mere pipelining and mere persistence. It also solved this problem where over one connection, you really need to get that CSS file to style the page, but you're waiting for the JPEG to come, which you asked for first. And so until that JPEG comes, you're not going to get any CSS, and there's going to be that like style jank where it suddenly the style appears too late. So the head of line blocking problem is a big problem on networks, and HTTP2 does its job to deal with that at the application layer, and it's super important. Another important thing is that you can, the server or the client, whoever initiates a stream within the long-lived persistent connection, can tell the other side how important that stream is in among all the other streams that are currently running. So a server can say, hey there, client, here's the main web page, and now you're going to want to focus on this JavaScript file. It's super important. It's jQuery, and we can't do anything without that. And you'll need the CSS next. And all those avatars for all the users, those are important, but they're third. So don't get those before you get the JavaScript, because it's really important to have the JavaScript. And then the client can prioritize how it handles the incoming packets, and you can get a much lower latency page load, a much better user experience. And either client or server can initiate a stream. You can say like, hey server, I'm sending you up some updates. Say it's a mail application. It's really important that you process these emails that I'm posting before you process the IMs. Maybe the emails are more important, or vice versa, whatever it might be. So that's super, super cool features. And then as a minor sort of bonus, HTTP2 compresses the headers of HTTP requests and responses. In the old days, you could compress the bodies, but sometimes the headers would get big. If you have like millions of cookies or just huge lists of options and you keep repeating them, sometimes it could be nice to compress those, so now we can. It can be useful. But all of that goodness only works on TLS. There's two reasons for that. One is we really want the future web to be safe so that it can be appy. If you think about your mobile apps, and even Windows and OS X, but certainly iOS and Android, all of those apps pretty much have to be, these days, signed. Like you can't get into the Android store without your developer key. You can't get into the iOS store without your developer certificate, so that people can believe that they've got the real app. Well, if we want to have that same goodness, HTTPS is that. TLS is that for the web. But the second reason that relates to performance is that we need to have end-to-end reliability to deliver all that goodness, all those multiplex streams and the header compression. We need for our communications between client and server to be opaque to all these meddling middle boxes, all those people who want to insert their own ads into your stream. They're also doing things like, oh, I'm going to optimize your site for you by stripping out some of your headers. It looks kind of big. I'm just going to get rid of those for you. Well, maybe you needed those. Maybe your app depended on that. Or maybe they're going to say, oh, I'm just going to downscale all your images. It's better. Trust us. And the users are like, why does everything look so fuzzy? Or whatever. Or there's passive eavesdroppers. Mean time to Snowden is 11 minutes. Passive eavesdroppers, active tamperers who are not messing with your traffic for the purpose of inserting ads, but maybe inserting spamware, adware, or fraudware or spyware. All those sorts of things can happen, whether they're for nominally good reasons or for nominally bad reasons. We don't even need to worry about that. The fact is, HTTP2 looks so different on the wire that all of those middle boxes that are expecting to see HTTP1 will do the wrong thing when they try to help by mangling your traffic. So we know from experience that it's really, really hard to get a successful HTTP2 deployment over not TLS. Over plain TCP, all sorts of breakage happens. So we need the reliability. If you think about it, inside a computer, you've got your USB wires and your PCIe. Well, we're building a planet-sized computer, and the message bus is all the air, all the copper, and basically anyone could be messing with it, and they are. So we need the basic safety that TLS provides. In fact, this argument has been going around and around since the very beginning of the internet. If you haven't read it yet, you should read this great paper by Jerry Saltzer from 1980. I think there was drafts of it in 1979. And he's trying to define what he calls a careful file transfer application, which is basically what we're doing here, HTTP. And he says, so if you were going to try to build such a thing, you'd want the server to tell the client, here's your file, and you want the client to have some reason to believe they got the full file with no damage. How would you do that? You could build reliability stuff at the ends, or you could try to build reliability stuff in the middle. You could have the telephone network try to make some kind of promise of reliability, or something like that. But instead, he argued that the place to put the reliability guarantee is at the endpoints. And any reliability guarantees that happen in the middle, or if you will, at lower layers in the network stack, those are nice optimizations if they work, which is not always. So if you really care, do it at the endpoints. And that's, again, that's what TLS gives us cryptographically. It cryptographically gives us server authentication, data integrity, and data confidentiality. What we mean by that, when I say cryptographically, what I mean is that it would be computationally infeasible for one of those middle layers to get away with messing with your stuff. They could, but it might take more energy than there is in the sun, so we'll call that good, hopefully, if the cryptographers have done their job right, and they usually have. They're much smarter than me. So really, security and reliability are kind of the same thing. Security is reliability even when people are purposefully messing with you. Reliability is like, oh, there's noise, and there's bad weather, and lightning strikes cause that server to go down, bummer. Security is when it was not a lightning strike, it was a bomb, or some crazy person inserting their own ads. So, and since the message bus is the planet, we must and should assume that we're always under attack. So, but this all sounds good. I want to have all those nice benefits of HTTP2. I want to provide safety to my users. I want my privacy policy to be true. I want people to feel good and happy and safe when they're using my app. But I've heard that TLS is really slow. Isn't it really slow? How can we fix that? So there's several shades of answer to that question. If you think of it not as a Boolean, but as like an 8-bit wide answer, the high order 6 bits are all no. It's not slow. And the low order 2 bits are, well, we could probably tune up a couple things. So my colleague, Ilya Grigorik, has a cool website, which if you haven't seen it, you should visit. that expands on why all those high order 6 bits are 0. It's called istlsfastyet.com. And the answer is yes, except we need to get more people using it. So, and he's also got a really good book about optimizing those last 2 bits. But let's think about making sure that TLS always fits into our performance budget. If we want to say we have 1,000 milliseconds before people will get bored and look away, we've got to make sure we meet that deadline. So let's do what we can to make sure that TLS is not the thing that breaks it, right? So the first thing to do is optimize the higher layers first, the content layer, the HTTP layer. And HTTP 2 is all about building in a lot of those HTTP layer optimizations into the protocol so that you don't have to, and it gives you more knobs to tune, like prioritizing different file types and stuff. But the content layer is a huge cost, and a lot of websites, maybe even most websites, are paying way too much there, in my experience. So here are some, oh, I've got my examples coming later. Yes, they're coming. So think about, when you're thinking about how to optimize at the higher levels or at the lower levels, you want to go through a workflow like this. Start by setting a quantified target. If you don't have a quantity, like 1,000 milliseconds, or each page load must be less than 50 kilobytes, or whatever, if you don't have a quantity, then by definition you don't have a problem. And that might seem obvious, but in my previous life, I did a lot of consulting where I would beg people to turn on HTTPS, and they would say it's so slow. And I would say, well, how fast is it now? And they would say, I don't know, but it's got to be as fast as possible. And it's like, well, that's true. It should be as fast as possible. But if you don't know how fast or slow it is now, then you don't know if TLS would hurt. And they never liked that answer. So then I had to draw pictures for them and give them examples. So assuming you've got a quantified target, and 1,000 milliseconds is a pretty good target, measure the status quo. And we'll talk about measuring in a moment. Where are you at now? Are you already, even without TLS, not meeting your guarantee? Well, got work to do. Or maybe you already are, and we're good. Let's stay there. And assuming you're not, you can play this circle game of checking all the red squares. How many connections are you making? How many resources are you downloading? How many bytes is each of those resources? Reduce all those things. How many TCP handshakes? How many DNS lookups? I've seen sites where because they wanted to parallelize all the 50 resources they load per page load, they would parallelize it over 25 CDNs. And looking up 25 host names blew their budget before making any TCP or HTTP connections. So, well, maybe too much parallelism could be a bad thing. And again, HTTP 2 does a lot of this stuff for you, but it still matters at the content layer. So do all that, measure the status quo again. How are we doing? Have we met our guarantee or not? Maybe go back. Maybe you've met a new guarantee and you'd like to tighten your quantified goal. So that's great. Obviously now you can do even better, 500 milliseconds instead of 1,000. That would be sweet. When you feel that you're happy, you can go to the green circle and be done. And then when you add TLS, you can do this exercise again, make sure you're still meeting your budget, whatever it is. And if not, fix some stuff. So as to recap, TLS underlies all those performance guarantees, so we have to have it. And I admit, TLS is not free. Let's do I like to do this. Let's have a poll. So there's all those things of TLS, the server authentication, the data integrity, and the data confidentiality. There's a lot of crypto going on. And there's additional network traffic to do the handshake. So who thinks that the symmetric cryptography, the encryption of the data, is the slow thing of TLS? Anyone think that? Nobody thinks that? That's interesting, because everyone else on the internet does think that. They're wrong. You're all right. So good on you. Another thing that could be slow is the asymmetric cryptography, the public-private key pairs, where you say, hi, I'm really twitter.com, and no one could, in the lifetime of the universe, falsify this guarantee that I'm about to make to you. And then the client says, well, let me just check that math. Is that slow? Any hands? Some hands. Not zero. Those of you who raise your hands are about right. That's slower stuff. It's fixable, but yeah, you're going to pay some price there. It's going to be like in the milliseconds. You'll notice it, and that's a bummer. And then the third thing that might cost us time is the network, the additional part of the handshake. Who thinks that's expensive? Many more people. And again, you are right. That's the thing. So when you're worrying about TLS, worry first about that network overhead. Worry second about that asymmetric crypto. Don't worry about the symmetric crypto. Think about it like this. We can watch DRM video, right? So it's being symmetrically decrypted and then blasted to your GPU. And nobody ever even knows that the video is encrypted because it just does not matter. So don't worry about it. So worry about the network stuff. So we can amortize those costs after, of course, working on our content layer. So what you want to do is at every stage in that playing the red square game, keep measuring, and Chrome provides you some nice measurement tools. I'm a huge fan of the dev tools. They're super nice, as hopefully you already know. There's this network tab that tells you what Chrome is doing on the network to load your app. And I'll say app instead of site. So here's a page load. I visit the New York Times every day, and I'm always interested to see what is going on content-wise. It's very heavyweight. And before you laugh, make sure that your site isn't like this. I don't use them to pick on them. I use them because it's just a super common site that everybody visits. So we can see a couple things in this network tab. It tells us the status and type of each request, how many seconds it takes to load the page, and where in time the request happened. Here we are, 57 requests. I just visited just the front page. We've already transferred 0.5 megabyte. And whichever request we're on here, maybe it's 15, or we're toward the bottom, I guess. We're 1, 2, 3 seconds in. And we can also see how big each resource is. 4 kilobytes, 500, whatever it might be. So there's a couple good things about how the New York Times site loads, some bad stuff, and make sure that we want to move things into the good category. So first thing, they sprited their many little icons. So obviously, if you figure there's like 50 icons there, you definitely would not want to make 50 requests to get them all. So you sprite them, and that helps a lot. So make sure you're doing that if you're not already, because the overhead of starting a new network connection for each of those would really kill you. And then TLS would look really bad if you made 50 just to get little bitty icons. So there's some bad stuff about their site that they could easily fix. First, we have here some JavaScript. It's gzipped, which is super good. Always make sure you're doing that. But even gzipped, it's still 62 kilobytes. So think about what a browser has to do to parse and execute all that code. 62 kilobytes compressed. So multiply it by 5 or 8. So pretty soon you're talking about a lot of code. And that's just one of many. Here's another JavaScript, not compressed for some reason. And it's set to never cache. It says specifically, don't cache this. Well, turns out it's often exactly the same text. So they could have cached it. And certainly they could have compressed it. So make sure you're always caching and compressing as much as you can. And here's a trouble spot that would be the kind of thing that would make TLS seem too expensive, but really the cost is elsewhere. So here's a CSS file that contains within it a base64 encoded font, and the base64 encoding multiplies it by what ratio? Anyone? 4/3. Someone said 4/3, which is true. So it's bigger than it needs to be because of how they've encoded it. And then they set it to cache for only 300 seconds. And it's 0.5 megabyte. So every 5 minutes, you're going to get another 0.5 megabyte font file. That's probably the same as it was 5 minutes ago. So don't live in this world. That would be sad. That would be slow. That will blow your budget. So in addition to Chrome DevTools, it's also good to look a layer below. Look at the TCP and DNS and IP layers. So who's used Wireshark? Hopefully some people. Good, many of you, great. So you can see lots of good stuff, including what's going on at the TLS layer in Wireshark. And I find that it's always an eye-opener. When I was in consulting world, trying to convince people that they could indeed afford HTTPS, I'd bring up a screen like this, and many eyes would open. So there's a couple things going on in this page. This one, it's a very small page load. It only took a quarter of a second to get all the packets. There's only about 18 total. We can see at the bottom, there's no visible text. It doesn't look like a web page. It's all ciphertext. And that's what you want all those ad inserting people to see, is nothing. All those people, all those passive surveillors, all those tamperers, you don't want them to be able to do it. So that's good. We can see that that's working. And then we see that the size of the packets is mostly small. There is one thing that stands out, though. The server hello, which contains the certificate, is like 2,700, 2,800 bytes, which is also about the same size as the whole web page. So that's a bummer. I would really like to amortize that cost and reduce it. So one thing you want to do is make sure that your TLS sessions live as long as possible so that you don't need to re-handshake TLS. You can, I don't know if you knew this, you can restart a existing TLS session that the client and server have already negotiated over a totally different TCP connection 5 minutes or 5 days later if either side is keeping a cache that long. So make sure that your server is configured to keep TLS sessions alive as long as possible so that you don't pay that expensive network thing very often. And so that you can get, and also things like HTTP persistence and pipelining or HTTP2 streams get the most benefit from the handshake that you do pay for. Also, you want to make sure that that initial stuff, all the setup, the TCP setup and the TLS setup, falls within the initial congestion window in TCP. If they don't, you'll have to wait just for the ACKs for your handshake. And that will slow you down badly. The good news there is that it's becoming a standard internet-wide to make that congestion window much larger. In the old bad days, that 2,700, 2,800 bytes might have blown the budget. But these days, usually, often, and you can check with Wireshark and libpcap and other tools, that you are, in fact, not blowing the initial congestion window just with your handshake, because that can be a bummer. So these days, you have a lot more headroom, maybe as much as 5,000 bytes, maybe even 8,000, and that helps a lot. But if your server certificate is really big, or the chain is unnecessarily long, or if your CA gave you a certificate that includes their logo, some of them have JPEGs of the logo. It's like, well, those bytes are wasted, and those are the most important bytes, those starting bytes. So don't get caught there. So just by looking, almost everybody, and I'd be surprised if any of you were already at a point where your app was already maximally optimized at each of the layers. So just by looking, you can discover lots of headroom where you can introduce safety. And overall, I should note that in this move to SPDY and HTTP2, in certain cases, by going to HTTPS, Google has experienced an overall latency reduction, not an increase. Even an affordable increase would be cool, but oftentimes we're actually able to do better by introducing end-to-end security and reliability. And it's good for users. So thanks for hanging out. And I'll be at the panel, I think, immediately next. There's a booth. So come yell at me if I'm wrong. Thanks.
Cool. Yes. Well, I'm starving. So let's do some lunch. We've kicked the previous people off the demo stations and tossed them out onto the street. We're done with them now, and we have some cool new people there. So Roman's going to be there to field questions on material design, and Paul will be a different one talking about performance. And Chris, and Paul Backhouse will be there to talk about security and dev tools. There are free demo stations. One of them's a little bit hidden around the corner, so make sure you find the one that you want to go to. So let's do lunch, and I'll see you back here at 2:30.
Thank you, everyone, for coming. We're starting again in 4 minutes. 4 minutes. If you can kindly take your seats, we'll be very grateful. Again, starting in 4 minutes.
Hey everyone, come in, get a seat. We're about to start the afternoon. Did everyone enjoy lunch? Yeah. Okay, most people enjoyed lunch. That's pretty good. In Google in London, they gave all of us a health check. Like just they sort of did the blood test for cholesterol and blood pressure and weight and stuff. And after the end, you got a bit of paper sort of telling you your results and if you were doing well or not. And the idea was to sort of improve the health of Googlers. And I got the all clear, which I was quite surprised about, but quite happy about. And it's totally ruined my life because it was like I now have a golden ticket, like a note from the doctor that opts me out of lifestyle common sense. So it's like, oh yeah, I will have another beer and a chocolate cake because I've got the doctor's note. I can probably have a few more of these before I get into the danger zones. On that note, a couple of people have asked if there's an after party to this event, and yes, there is. We have an open bar with beers, wine, spirits, and we got soft drinks as well. It's going to be free DJs. Which is pretty cool, but there's going to be plenty of places to go for sort of quiet technical discussion as well. Okay, so let's get on to our next talk. Here to deliver episode 1 of the Web Components trilogy that we have this afternoon. It's Dmitry Glazkov.
Can you hear me now? Wow, the power of technology. Is the episode 1 is the worst one? Is that what it is? Or I can't remember. All right, I guess. So everybody had lunch, a little bit tired, right? So we need to get up. No, I'm just kidding. Somebody suggested we do calisthenics and stretch and all this stuff. But I'll try to be energetic for you guys. You don't have to. So this talk is a little bit different from every typical web components talk, and believe me, there's a few of them out there now. Just go search web components talk, and you will see a bunch of them. Because I'm going to ask deep questions like, why are we here, right? Why are you guys here? We have no clue. But why are we doing what we're doing, right? Why do we do things that we do? Well, I'm doing because I want to make a bunch of money and retire in the Swiss Alps, right? Is that what we're doing? That sounds good, reasonable? Maybe write a little science fiction, space opera type stuff. Okay, no. Well, the reason why we do these things is because we want to solve problems. We want to help users. We want to make it easier, make life better, change the world, some of us say. Some of us like, oh, I can't do the whole world, but I'll change a little bit of it. And so about 5 years ago now, I basically was a young web developer who just joined the Chrome team. And I was really getting into this whole web development and browser development thing. And I was like, oh my God, I have superpowers. I can change the browser. It was awesome. And so I started looking around, and I realized something important, that great platforms have one framework. Terrible platforms have none. And web platform has a bunch. And the reason why we have so many is because all of these frameworks are really made by pissed off people. People don't make frameworks because they're happy. Like, oh my God, I have extra time. I'm going to go and build another web framework. People build frameworks because they're sad and upset, and this thing does not work, and they're like, okay, I'm going to not do this again over and over. I'm going to codify this into something, and hey, maybe some other person will benefit from it. Changing the world type thing, right? Are you guys with me? So, so really, with this goal, I kind of said, okay, so if these frameworks are all cries for help, what kind of help do they need? And this really was the venture that began back then and ended up being the thing called web components. And web components really is about solving several problems, and I'm going to try to go through them with you. And this is just tip of the iceberg, but you know, I have 30 minutes. I can probably talk about this for days. And I won't. Instead, I have 30 minutes. And so one of the first problems that I've encountered, and something that people do all the time, is that composing things is hard. Composition is like the foundational thing of software engineering, right? You have a bunch of people working on software. Your team consists of more than one person sometimes. And you're all working on achieving success, and then things have to come together and ship. And then it's like success turns into not success because nothing fits. And so composing things is generally really hard. And in the web platform, especially in the web, we've always done this really weird thing where it's a very common pattern. I'm going to call it render and decorate, but you probably have your own name. And that is the idea is that, you know, instead of keeping everything in one large DOM tree, you separate things out, and you bring them into smaller chunks, and you make those chunks separate, and you keep them aside. And so, for example, imagine there's a very large DOM tree there. I'm not going to bore you with details. Just go into Gmail and open Inspector and look at it, and you'll see it right there. And so render and decorate goes like this. Hey, instead of my actual widget on the page, I'm going to put a little div there as a marker. And then later, when it's time for me to inflate this marker, I'm going to do a magic incantation. We call it apply instances. And then we're going to query selector all. By the way, if you guys don't know JavaScript and can't follow me along, I apologize. You probably are in the wrong conference. But you know, nevertheless, that's all I have. And then you just, you know, you do something like you create a template, you create a widget template there, you put stuff in it, and you blow it up, and everything looks wonderful, right? Except, what is the problem? When you go back into the inspector and you look at the, all right, hang on. Turns out, well, when you look at the tree, it's all back together in the one big tree, right? So now you can no longer think of these widgets as separate things. You're thinking of them as one large, big DOM tree in a document. And so to solve this problem, we came up with this neat thing called Shadow DOM. And Shadow DOM allows us to add one line to this code. Just one line right here. But what this line does, you guys can see it? You guys with me? Is it now keeps all of this tree right here in this thing as a separate little subtree. So now I can still move it around. I can still reason about it by itself. It's no longer a part of a larger whole, but at the same time it renders as the same widget right there, right? You guys with me? So what we did is effectively solved the DOM composition. So developers out in the field or working as a team no longer need to worry about a large DOM tree as the final result. They can still think of all of these pieces as separate little chunks of code and chunks of trees, and then compose them together as one, as a big, large, beautiful document or an app or whatever you guys decide to build next. Are you guys with me? Yes? Right. Well, right after this, we ran into this next problem that is a little bit more interesting, and actually we've gotten so Stockholm syndromed into it. We go like, no, it's okay, it's not a big deal, we're all right. And that problem is called CSS. All right? There was this Comet Lander thing on Google Plus or Twitter that you guys have seen probably. We can land the thing on the comet, but can't position the box on CSS. And really, the biggest beautiful problem with CSS is that CSS is a wonderful bit of machinery that allows us to separate concerns of style and presentation from the concerns of structure. But it also is all or nothing thing. So for a larger web app, this becomes a really weird, spooky action at a distance thing where you have to basically say, hey, I actually have 1,000 widgets in my doc or in my app, but all of them ultimately feed from one style sheet. And it's somewhere there. And actually, I'm going to pretend that there are multiple style sheets, but no, there's still one style sheet. So once you change a thing, it becomes this weird thing. It's like, am I going to break anything? I don't know. If I did, what am I going to do now? And so here's a simple illustration of the problem. I'm just going to take this thing and say, hey, I'm just going to add this little div down below over there. And I want it to be red. And it's very simple. It's you have top here, I have div here. And so all I need to do is put like this simple selector there, div top, div div. Dope. Because of the render and decorate that comes after the fact, that is not visible on my tree right there, the widget title is also red. And that's where the wonderful bang important comes in, right? You go like, okay, specificity. I need to remember the numbers, 0, 1, 10. Anybody can rattle off the bat what the specificity rules are? That's okay. It's all right. Because we can actually solve this for you. And we did this with the web components with the same line of code. It's the same line of code that we had before. And the beautiful part here is that CSS is scoped inside of the shadow tree. So whatever you write inside of the tree, CSS is encapsulated inside of it. So nothing leaks in, nothing leaks out. You don't have to start reasoning about global thing and how the global style sheet applies to this widget, because all these things are completely separate. As you can see, the widget is no longer red, the widget title. Awesome? Yes! Yes! And trust me, when you start building with Shadow DOM, one of the amazing things happens is your selectors get simple. You no longer write this really weird train, wacky train of wagons that is like plus div dot blah pound foo, and it's like, no, everything is just pound foo or pound blah and div dot whatever. And it's very simple because you no longer think in a global document, a global app sense. You no longer have to worry, oh, will the next state change affect what I have just done with the style sheet? You basically think about it as, hey, I'm working inside of my widget. And that's all I need to worry about. And I'm OK. And nobody's going to mess my stuff up. Right? So we solved, don't do that. We solved 2 problems. There's still a bunch of them remaining. Let's go ahead and start solving all of them. And the common thing is the house of divs that we have, or the Jacob's ladder, whatever you call this thing, is like this amazing thing where we just soup up our document with div, 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 div. And sometimes it's like, oh, I wish I could use a button here, but because IE or something, I need to use a div for my button as well. So everything is a div. Yay! Well, no, it's not really OK, right? Because like even in the solution that I said, like, oh, I made it better. This is much better. I still go, look, this is div class my widget. Why can't I just call it what it is? Why can't I just say, look, this is my widget. This is not div class my widget. This is my widget. And turns out there's a thing we invented called custom elements that allows us to do this. And custom elements is really neat. It basically says, HTML, it's been a pleasure. But it's time for me to start saying things the way I mean them, right? Saying what you mean. Alex Russell invented this. Alex Russell, everybody. Say what you mean. And the basic idea is this. You just declare a new tag. You just register a new tag with the HTML parser. You proclaim, you suddenly have this power and say, I'm going to extend HTML. I don't have to be the spec editor. I don't have to be a browser implementer. I just call this thing called document.registerElement, give it my tag, name, and provide a prototype. And suddenly, a bunch of code falls away. No longer I have to do this apply instances thing. I don't need to do this anymore. Because as the parser encounters my widget, it will invoke a thing called a created callback, which is like effectively a lifecycle callback for the HTML element, and it will run this code for me. So effectively, I'm saying, hey, HTML parser, do something useful for a change instead of just spitting out stuff and objects. Create my objects for me, instantiate them, so I don't have to come behind and decorate them with something. Create them as they are, as they were meant to be. And so this allows me to effectively remove the extra calls at the end here that were present that says apply instances thing. I don't need to do this anymore. It's all now a part of the created callback of the HTML element. So now I've invented my own tag. I gave it behavior. It's not just about new tags, right? It's about making parser do the work of instantiating things. So now HTML parser that runs as fast as it could possibly go not only just spits out objects of predefined shape, it can spit out your objects as well. And you can build entire object trees, and you will see in a few minutes how this happens and what kind of magic you can achieve with this stuff. So yes, awesome, right? Custom tags. And finally, let's just turn this knob one more time and say, well, this was really fun, but Dimitri, this still looks a little wonky. You're still doing things that look somewhat unpalatable, like you're doing things like creating document object tree using JavaScript and mashing strings together. That seems bad. Can we fix that? And the answer, I guess you kind of figured that one out, right? The answer is yes, we can. And the way we do it is with a special thing called a template. Template is a magical HTML tag. Everybody, after you leave here, if you've not played with the template, go play with it. It's awesome. because what it does is it gives you nothing. Not in the bad sense, but in the good sense. Things inside of the template do nothing. They are inert. They're like the Han Solo thing in Frozen in Time, or whatever that thing. I can't remember the compound, but it obviously was some sort of amazing stuff. And so once you put things in here inside of this template right there, styles will not apply, images won't load, videos won't play, things are inert. They're basically like, it's parsed, it's there, it's ready to be stamped out, but it doesn't do anything. And that allows us to, instead of doing this crap right here, look at that, that's a lot of code. Break it down to this, where we basically say, hey, widget template, all we're doing is just creating a template, getting it out of the tree, and then stamping it out right there. Does that make sense? Templates are wonderful. Not to say that everything else is wonderful as well, but these are pretty awesome things. Still, this looks okay, right? Now we have all of our HTML in the HTML space, all of our JavaScript in JavaScript space, but you say, Dimitri, yes, I am channeling Emerald Lagasse here. Dimitri, why are templates in my document now? How can you help me get rid of them? Because if this is a large app, won't there be like a bunch of templates hanging around in that thing? Wouldn't that be kind of bad? And then this JavaScript seems to be like just somewhat sitting by itself. That seems bad, right? Well, we can fix that. And that's why we came up with this thing called HTML imports. HTML imports. HTML imports are amazing because they allow you to create HTML files that you can do what? Import. That is pretty cool. So as you can see here, this is our template right there. And there's our JavaScript code right there. All right? And then we import it using this very simple, very familiar looking line that's called link rel import. Instead of style sheet, you're importing HTML. You're importing, instead of styles, you're importing markup. And so what happens is now your app suddenly does not have to look like a bunch of stuff. It can be now separated, and you can build dependency trees out of it. And by the way, link rel import, HTML imports provide dependency management. That's very nice. So all deduping happens. So if you include it twice in different places, you will only get one instance. So it does really well. And it also allows you to start reasoning about larger apps in a much, much simpler frame of mind. OK? So there's our import. And there's our final result. HTML imports, everybody. The neat thing is these building blocks are just the beginning of what can happen and what will happen. By giving developers the power to harness HTML parser so that they can create their own object trees, giving them ability, giving you ability to scope your styles and to compose DOM dynamically on the fly instead of, mashing it all together. And by enabling a reasonable markup reuse scenarios with HTML imports, you open all kinds of possibilities. First of all, interoperability. This one is really crucial because every framework invents this system in slightly different and completely incompatible way with another framework. They all have to deal with reuse of elements. So widgets from one framework are not compatible with widgets in another framework because they were invented in the composition model was invented in a slightly different way. When DOM is your composition model, when Shadow DOM is this kind of the web standard, and custom elements is the standard way to compose things, everybody can now compose in using the same common lingua franca, which is web components. So that allows or enables the path to where every framework can reuse each other's widgets and things, and you don't have to think about which one is compatible with which and which one is not. It's a long road because there's lots of really strong opinions about how composition should happen. A lot of this is, again, laden with Stockholm Syndrome and understanding of the world, but the path is open. It's available now. The other thing that is pretty amazing is the fact that now the browser understands your composition model. So the rendering engine can make smarter decisions about how to do things faster for you. For example, a Shadow DOM can be a performance primitive because instead of reasoning about invalidating styles across the entire document all the time when your app has multiple pages, like a single page app type of thing, you're all confined to tiny little trees. Style calculation is much faster and much more predictable. So hitting those 60 frames per second becomes a more real and achievable goal. And things like HTML imports are also really cool because parsing of HTML, turns out, many browsers do on a separate thread. So you could potentially start loading multiple imports, and they would be doing all the work of parsing and tokenizing and creating those loading those imports in parallel. And so you could gain performance benefits just from that. And the third and pretty most important thing is that all these primitives are designed in such a way that they provide the developers, especially developers of frameworks, a better framework, better way of thinking about coordinating actions. Instead of arbitrary points at which your components or your divs become components, there is now predefined checkpoints like microtasks. And there is callback queues and execution of those callback queues that is defined in a spec. So you can now reason about how much work do I need to be doing now, how much work do I need to be doing later in scalable fashion. And of course, it all results in, at least in my mind, in really green circle of awesome. I'm not sure why the circle is green, but it's definitely awesome. This is about it. If you guys want to ask me a few questions, we have 6 minutes left. Yes? OK, what's the status of browser support? They are available in Chrome. And they're available in Opera, obviously. No laughing. And then Mozilla is implementing web components as well. It's right now an experimental track. But I've been talking to Microsoft folks. They're excited about it as well. So hopefully, fingers crossed, soon. There is a thing called webcomponents.js, which is a set of polyfills that allow you to take advantage of most of this functionality across browsers. What is this, IE 10 plus? So it's pretty awesome. But it's definitely native implementation has certain performance benefits. Yes, I'm sorry, you were first. Mm-hmm. Right. So HTML imports and namespacing. I have to repeat your question, obviously, for people out in the internets. I hope you're watching. I don't even know if this is the camera, but I'm assuming it is. There is no namespacing for HTML tags because there's just one HTML parser. So custom elements will be parsed according to one registry. But the notion of registry exists, and we can improve this in the future to enable multiple registries. So an import can declare and say, I have my own set of elements that I want to do on my own, and please don't touch mine. I speak my own language. As far as how it is imported into a main document, it is not important in the main document. So it just is a separate document. An import is a separate document. And the only way you import data is if you run script inside of it and you decide to do something with it. So you have to take an extra step to do that. Am I done?
Yep.
I'm done.
So we've got a Polymer and Web Components panel at 9:30 tomorrow. So if you didn't get a chance to ask your question there, put them on the moderator board or tweet them to Chromium Dev, and you'll have a group of people there to answer them tomorrow. We also have a Polymer demo station, and in the next break there'll be people there as well. One of the things I really love about these conferences is being able to talk to developers, because there are so many smart people here, and which is great, because my first experience in San Francisco was a little bit different. When I first arrived in San Francisco, I went to a shop in the airport to buy a drink. I just arrived. It was my first time there. And the person behind the counter was being very friendly, and they asked, "Oh, where are you from?" And I said, "Well, London," which I'm not, but you pick a capital city, keep it simple. And they looked at me and went, London. Paris is in London, right? And I'm not a rude person, but it was really difficult to answer that question without sounding sarcastic. And being British, everything I say sounds sarcastic anyway. So I was kind of like, well, they're connected by a tunnel, so you can have half points for that if you want. But they're quite different places. Right, are we good to go for this next bit? 15 seconds. Ah, that's good. Is everyone having fun? That's a good way to waste 15 seconds. Everyone say yeah. Yeah, brilliant. Is that 15 seconds? I'm great at filling for time. Excellent stuff. Okay, so here for episode 2 of our epic Web Components and Polymer trilogy, here to talk about lessons learned from Polymer, it's Matt McNulty.
Hi there, so welcome to the Polymer State of the Union. Not sure how familiar you are with State of the Unions. I'll try and make this a lot more interesting. But you may half of you may have to stand up and give standing ovations like every couple of minutes. So I hope you warmed up, did some squats, that kind of thing. Should be good. So just a little bit about me. My name is Matthew McNulty. I lead the Polymer team here at Google. My Twitter handle is there. It's Matt S. McNulty. Feel free to stalk me. There's a lot of young British women who think I'm an actor over there. So they stalk me, and they are similarly bored. So feel free to join them. For the sake of this talk, I'm going to assume that most of you know something about Polymer as well as Web Components, and that you paid attention to Dimitri. Just in case, I'm going to spend just a minute or two talking about what Polymer is. Oops, wrong button. So Polymer is a library that helps you build elements and apps out of Web Components. So this sounds like a lot of JavaScript frameworks out there, but Polymer is different in that it uses Web Components, what Dimitri was talking about, this cutting-edge set of standards. This lets it do less work to achieve better results than what came before, and frees up framework authors to concentrate on making great apps. So how great can apps be? Turns out with Polymer, very great. So it's easy to say, but let's take a look. So first I'm going to show you a mail app that one engineer wrote in just 2 weeks. So granted, it was Eric Beidelman. He's pretty awesome. But still, it was one dev in just 2 weeks. And I get to do a demo on a screen that's really far away. All right, so first off, let me make this clear. This is not Gmail. This is just a sample app that we wrote in Polymer, but it does use the Gmail API and Google sign-in and authentication, which I can sort of see my mouse. No one email me at those other email addresses. Forget you saw them. So the Gmail API and the sign-in authentication API are just part of more than 250 different APIs that Google makes public. So the Google Web Components project, which is a project we started to turn those APIs into web components, is at googlewebcomponents.org, I believe. And managing some of these APIs can be a pain, but Web Components reduces the boilerplate and makes it so they're really simple to use and really simple to integrate into an app like this really quickly. So let me find my cursor again. There it is. So here we have an app that's really, really close to the native Gmail app. You can see if I scroll it, It's got a really cool material design, crossfade scroll thing. I can also select items. It's got some cool ink effects there, undo it. It's got an app drawer. This stuff is all, it's pulling like this profile data from Google+. It's profiling the tags. It's pulling the tags from the Gmail API. This is all a real app with real data. And it's even responsive. I can bring it really big, and it adjusts automatically. It still has all the really cool effects. So anyway, so you can swipe messages. You can do swipe to delete, undo it. And it all just works really well. And this just uses the web platform, uses web components, and uses Polymer. Let me get back here. All right, so now we see what we can do with Polymer, and part of what makes it different, but let's dig into it just a little bit more and see what makes it unique. So we make a big deal out of the fact that Polymer is a library and not a framework. This goes back to using web components and really using the platform. So a long time ago, web apps were written in HTML and using built-in tags like button and form. So Polymer returns to that world, but this time with custom elements. And with Polymer, developers write HTML, but the framework is DOM. We don't build our own framework on top. Polymer is just a really thin layer on top of that new and improved web platform. So that's great at a high level, but what does it actually do? So the first thing it does is it sugars the primitives that make up web components. So why does this new hotness that Dimitri just danced around and talked about need sugaring? It's because like all good primitives, web components are really low level. And that makes them really flexible and really powerful, but not quite as easy as they can be. And Polymer helps that out. So Polymer also reduces boilerplate, keeping your code limited to just what's unique in your application. And it adds a declarative syntax to web components. This is in the spec, but no one's implemented it yet, including Chrome. And this allows you to develop in markup, which makes it really simple. And most importantly, Polymer has an opinion. You know, it's how we think elements and applications built with web components should be built. So here's Dimitri again. This is an actual picture of him working on web components. I definitely didn't Photoshop this yesterday. It's definitely not my, my wallpaper. So this is just a little history lesson. The state of the art for a long time has been JavaScript developers building their own platforms on top of the web, because the web platform wasn't good enough. But now with web components, it is. And Polymer is the next step in that story that Dimitri was telling earlier. It's the experiment to prove that web components are awesome, to use his term. So experiments have results. How have we been doing? So Polymer has a lot of really great features for making building web apps easier. So developers love them. We've had 1 million unique visitors to Polymer. We're in the midst of holding a bunch of education events around the world called Polytechnics. 119 of them so far. And 85% of the participants say they're going to use Polymer in their next project. So in our little report card here, I'm completely biased, but I think we get an A for that one. So grading yourself is the best kind of grading, in case you don't know that. So how about productivity? So Polymer lets developers build applications faster and with less code. So QuickOffice is a user of Polymer, and they removed 10,000 lines of code when they moved to Polymer for their document renderer. So, and again, the mail app I showed earlier, written by Eric, came from 1 developer in 2 weeks to build a really polished, really nice web app. So let's give that one another biased A. We've also built a lot of elements that developers can use as is for their apps. You saw some of those in the Gmail app. These are built with Polymer, but they're not Polymer. They're a separate thing. We have a few different sets. We have core elements. We have paper elements for functional and UI elements. And we expect there to be a lot more of these. So, and you saw, paper elements are our material design elements. And material design was this really awesome effort inside of Google, because the Polymer team, the Android team, and the team that works on kind of the iOS framework for iOS apps at Google all worked together side by side on the same project. It was equal partners across it all. So as you can see from the demo I did earlier, developers can build awesome experiences with these. So working on a perfect GPA so far. Mom's going to be really proud. So how about performance? So Topeka, this really cool quiz app we showed earlier at I/O, the Polymer mail app I was just showing, and our sample apps work great. But to be honest, performance is inconsistent. Things take tuning, And they're especially inconsistent on browsers that don't yet support native web components, like Safari. So developers have told us that mobile Safari is super important for the mobile web. They can't just ignore it. But getting quality performance on that browser is really challenging. So there goes our perfect GPA. So I'm going to give that a needs improvement. Mom's going to be pretty mad. But we're progressive optimists here on the Polymer team, so we're going to rephrase that to maximum improvement opportunity. I was going to do an acorn because it's the furthest from a tree, but that was going to get a little too weird. So how about payload and complexity? So these things go together really often. So Polymer itself is pretty lean. It's 123K. It's a 66K gzipped. For an app and like a fully featured framework, that's pretty great. But for a single element, which is what Web Components says you can mix and match on the page, not so much. And Polymer is supposed to be able to do less, which means it should be smaller because it's built on Web Components. And in terms of complexity, Polymer is pretty complex. It can be difficult to know what's going on if you want to look under the surface and see what's happening. And again, for an app, that's OK, but for mixing and matching all these different elements from different vendors, not as much. So I think we have to admit we have another maximum opportunity for improvement here. So let's look at the whole report card. So ergonomics, productivity, and expressiveness are A's. A for awesome, as Dimitri would say. And performance and payload need some improvement. So this illustrates an issue we've had all along. Polymer has dueling goals. Be this experiment that pushes the platform forward and lives on the edge, but also be something production-worthy for developers that developers can depend on. So we've done a great job at the former, note all those A's, but the latter is clearly a work in progress. But the experiment's over now. Native features have shipped in Chrome. Polymer's fully featured enough to build apps, like I showed you. We started out with no native features at all when we started this project 2 years ago, and almost no knowledge about how all this stuff would work together, and now that's changed. So now it's time to make Polymer production ready. So in the last month, we've begun to take a hard look at every aspect of Polymer. So we've learned a ton we can put use to making Polymer better. We looked at each and every feature and tried to hammer it down into a leaner, less complex shape without sacrificing the really great features that everyone loves. So we've made a bunch of improvements, and we're ready to tell you about them today. So first, we've refactored Polymer into a series of layers. So core features are really fast and really lean. Advanced features that are more costly are opt-in. We strive for the 80-20 rule, so try and accommodate all the common use cases and let the rest opt in to the more advanced features. So that's the first change. Another change is we've greatly simplified our data binding system. So like everything else, we've optimized it for performance and simplicity. So most properties don't require two-way binding, so we've made that opt-in. So if you think of an AJAX request, there's a zillion things you can set, but really only one response that you want to actually listen to. So we've made that opt-in. Polymer's always had implicit types for properties, but we've made that explicit now. And change notification uses events for interoperability across elements from different frameworks. And another thing we're doing is specifically geared at browsers that have not implemented Shadow DOM and the rest of Web Components. So this change is specific to them and not Chrome. So we have a Shadow DOM polyfill. It's awesome. It's this feat of engineering. It's spec compliant, but it's also pretty intrusive, and because it's a pretty big feature, it's pretty big. So instead, we're going to take the tack of building a shim-style layer that just polyfills what Polymer needs. And the existing polyfill is going to live on for generic non-Polymer Web Components code, and that's the third change. So those are the high-level changes, but what are the results of this effort? So it's still pretty early. Performance testing is a really tricky art, but we have some results to share. So the first thing we tested was startup time. So how long we can go from launch until the app is ready to use. So first on Chrome. So I've always wanted an excuse to use that. So like a medium complexity app starts about 5 times faster on Chrome than it was before. So that's a huge speed up. On Safari, the story is a little bit different. So the same app starts up 8 times faster on Safari. So it's more of an improvement than Chrome, but we had more to do on Safari. So Chrome is still faster because it has the native features, but the penalty is reduced to as small as we could make it. All right, so it's way faster, but what about payload and complexity? So we've reduced payload 87%. So it's 15K now, and that's 6K gzipped. And this is with the same features and the same use cases. So we're not quite done. These numbers are going to change a little bit. My team wants me to emphasize that. But you can get an idea now about how we sped things up so much. We went really, really simple and down to the metal. So to be honest, it surprised even us that we could do this without a major disruption to the feature set. But it's fun and easy to say these things, so let's look at actual evidence. Let's go to the videotape. So this is showing Pika, which is a newsreader demo. It kind of does RSS feed reading, which we've had for a really long time. And we've got two versions of it running on a Nexus 9. On the left, you've got Polymer, the new Polymer. On the right, we've got the existing Polymer. It's the same app. So that actually went early, didn't it? So let's see the difference. Boing. So here's the same thing on an iPad Air. Gets better. So here's a synthetic test. This is like a medium complexity list, a lot of list data, and a lot of data, actually, here on a Nexus 9. And now here's the same thing on an iPad. And no, it didn't freeze. All right, so let's take a look at our report card again. So we stayed after school, we worked hard, and Mom's much happier now. We've improved precisely where we've needed it, and we haven't touched the features that developers love. Of course, nothing in life is free. So there are some breaking changes, especially when it comes to data binding in certain cases. But it's really not that scary. It will not require a rewrite. So elements might not have to change at all, individual elements you've made. Larger apps might need a few days to a week to adapt, but it kind of depends on the app. Some apps might not have to change really at all. So basically about a few minor version numbers worth of changes, but all at once. So to make sure people realize that, we're changing the version number to 0.8, both to show that we're closer to 1.0 and we're 0.3 better than before. Glad people got sort of a Spinal Tap reference there. So I've got a few other things to talk about too. I've covered what Polymer is already, and I do that every single talk, and all of us do that every single talk. People still get really confused about it, even people that work on web components. So Polymer web components are pretty big new things, and some people think Polymer is just the polyfills. Some people think Polymer is the material design elements. We kind of like to clear that up. So the polyfills that Polymer uses are agnostic. They work with any other library. Brick uses them today. These are web components polyfills, not Polymer polyfills. And they're generally useful. These polyfills are not Polymer. We wrote them, but they're not part of Polymer itself. So we're going to move them away from Polymer into webcomponents.org. So other library authors or developers can use them without any confusion at all. And the community can improve them independent of Polymer. So we wrote them, but we want everyone else to be able to use them until the day we can happily get rid of them because everyone supports web components. So elements, they're made with Polymer, but like I said before, they're not Polymer. Polymer isn't material design, but we make a set of material design elements. So we're going to take them, we're going to move them to their own part of the website, and I think we're eventually going to give them their own identity and put them somewhere else. But for right now, they're kind of separated out from Polymer. And what's left is the core of Polymer, that 15K, or that 6K gzipped. And now that core is production track. So it means no more fuzzy labels that mean nothing, an actual roadmap. That's still a little fuzzy. So 0.8 is in preview today, so it's live today as a branch of Polymer itself. It's still really, really early. It lacks docs like completely. It's still missing a couple of features, but you can take a look if you're brave. We like to do everything in public, so we've got it sitting there. 0.9 we're going to call beta, will be early next year, and then 1.0 really soon after that. So the idea is we're focused on the core of Polymer. We're going to put it out in production as quickly as we can. So even as an experiment, until now, lots of people are actually using Polymer. So we love early adopters out there on the front lines of the web platform with us, and I have a bunch of them I'd like to show you. So first up is Salesforce. Salesforce is Polymer's BFF. So they're here somewhere. They really, really get Polymer. They've gotten Polymer from the first time we put it out there. They're the people I bring to the office every time the team needs a pick-me-up. And their mobile SDK teams built this whole SDK for their developers to use Polymer to build Salesforce apps. So they built a whole SDK on Polymer and are shipping that to their customers. They've also built a reference hybrid application that runs across multiple platforms, and has secure offline storage, and it uses Polymer that you can see here. So this is actually a product that they shipped this week and blogged about, I think, yesterday. So next up is News Corp. News Corp has this awesome team using Polymer to experiment with next-gen tools for understanding and manipulating data with components and putting that data in the hands of journalists. So it's really, really cool stuff, and it's at the cutting edge of data-driven journalism. And now for some Google products. So YouTube is using Polymer. So for some users, this is going live this week. It's going to be the related videos list to one side for a percentage of users are going to get. We moved over to Polymer this week. So QuickOffice, I mentioned before, they've got a rewrite coming of their whole renderer. This uses Polymer. It's shipping very, very soon. And it radically simplified their code base. So 10,000 fewer lines of code to do the same thing. So Translate is also developing the user interface in Polymer. You may not realize this, but hundreds of millions of people use Translate every single day. Google Play Music is also using Polymer. And Santa Tracker. I'm actually happy that got the most applause. So this is a great story. So I don't know if you guys know this. 1955, a Sears store in Colorado Springs put an ad in the paper saying kids could call and talk to Santa. And they put the wrong number in, and they actually put the precursor to NORAD's number in. So this colonel in NORAD in Colorado Springs started getting phone calls on Christmas asking where Santa was. And this colonel actually happens to be the grandfather of a good friend of mine who works at Google. And he started to just actually give out where Santa is to all the kids. And a tradition was born. So it's a really cool story. You should look into it. So the Santa Tracker this is the current one. The Santa Tracker that's going to launch this upcoming season uses Polymer. And it's awesome. And it's for all your Santa stocking needs. So there's a whole lot more users of Polymer inside of Google, really too many to actually list, but there's a whole bunch more. So let's wrap up. So that was a lot of new stuff. So in summary, so the next major version of Polymer is coming shortly. It's out today. It's super, super fast, super, super light, and really, really modular. And it's going to require really minimal changes for developers to adapt to. Everything you're doing today still works. And Polymer is no longer an experiment. So hooray, it's production track. And the polyfills are moving over to webcomponents.org. That's already happened today. And lots of people are already using Polymer, including Santa. And you should join them. Rob's up next. He's going to dive in a lot deeper. And so you can do nothing. And Rob's going to be here in a minute. You don't even have to move. You do something and follow us on Polymer. And we're on GitHub. The name of the GitHub project is Polymer. And come check us out, build a project, and join the fun. Thanks.
Cool, excellent. And you're going to be on the panel tomorrow, and you're on this sort of action booth thing. I keep forgetting what we're calling them, but you're on that later as well. Excellent stuff. I really like how much developer tooling and libraries and stuff have improved. When I first joined the BBC, which is where I went when I left university, we were all editing files on a shared Samba drive. And then we were FTPing those up to the live cluster, and we had no kind of sensible version control or anything. And when I joined, I was kind of new to the web, but I did ask, like, what happens if two people try and edit the same file at the same time? Because surely, like, people are going to be overwriting each other's changes. And they went, aha, we have a solution to this problem. Follow me. And I was led to this table that had a series of paper cups on it. And each paper cup had the name of a file written on it in permanent marker. and said, when you want to edit a file, come here and take a cup. Take the cup for the file you want to edit and take it back to your desk. And that means that's yours now. It is locked. And if when you go to the table, it's not there, that means someone else is editing it. You have to go around the office and find who has that cup on their desk, and hopefully they haven't just left it over the weekend. It's surprising that that worked, but yeah, it's great that we have much better systems now. So how are you good to go? Are we getting there? We've got some resolution issues.
Yeah, it's just resetting it up.
No, that's fine. How's your day going?
It's going well. How about you?
No, I'm all right. I'm amazing at filling for time.
Yeah,
How about
Do you want to ask everyone how they're doing again? Or
that went really well last time. We'll do
like
that.
15 whole seconds.
So when I asked you how's it going, say yes, but make it a really long yes, and we'll see if we'll be ready by then. How's it going, everyone? Everyone having a good time? I'm worried about people are going to start passing out. Okay, we can stop that. I had this problem one of the first talks I gave, because I still get super nervous being up on stage, but I had one of those headset mics, and I went up on stage, and unfortunately it was kind of halfway up my nose, so as soon as I started speaking, I could hear my own breathing like a kind of, unwelcome phone call sort of going out through all the speakers. And the sensible thing to do at this point would be to move the microphone away from my nose, but because I was nervous, I thought the solution to this is to stop breathing. And there's only so long, because humans need to breathe, and I hadn't quite factored in that. I nearly passed out and died, but are we good now? You ready to go?
Yeah.
Excellent. Right, in the explosive climax to the Polymer and Web Components trilogy, this guy here is going to talk us through building something with Polymer, I assume. I didn't see your rehearsal. That's what you're doing, right?
I think so.
Something like that. Excellent. Cool. Big welcome to Rob Dodson.
Cool. All right. Thank you guys so much. This is really awesome to be on the stage today. Over the past year, we spent a lot of time talking about web components, really teaching developers just kind of like the basics of the standards and teaching folks how to focus on building elements. And we're now at this place where we have kind of like this burgeoning ecosystem of elements that are out there. There's a lot of developers out in the open source world who are creating elements. We've also got element sets that have been created by the Polymer team. It's got the core and the paper elements. And so we're at this point where we have this flourishing ecosystem, and I think it's time for us to start to think about the next challenge, which is how do we leverage that ecosystem to actually build real applications? And I'm particularly interested in figuring out how to build compelling experiences on mobile. The mobile web has like a ton of opportunity, but it's one of those areas where for web developers, it's always been a challenge to create a real compelling experience on a mobile device. And so when I was preparing for this talk, what I wanted to do was just like pop my phone out and look at the applications that I use all the time, things that I consider sort of successful experiences. And I wanted to go through them and just sort of catalog what I see as the kind of common UI and UX expectations in a successful app. So what I've got here is Twitter. I've got Pocket Casts for listening to podcasts, and I've got RDO. And one thing that struck me as I was doing this is, if I just take these applications and I put them side by side, even though each of them kind of feels unique when I'm looking at it in isolation, when they're all lined up like that, it feels like there's just like a ton of commonalities in their interfaces. And so using Twitter as an example here, I want to just catalog some of those common UI patterns that I see. So up at the top, we have a toolbar, right? Pretty familiar, and oftentimes if you've got a toolbar, you're going to fill it up with some icon buttons. And then below that, you've got some tabs for switching between content. Got like a primary content area, and oftentimes you're going to have like a, like an infinite list of content inside of there, or you might just be lazy loading more content as the user is scrolling down the page. And down at the bottom, you've got a secondary toolbar for doing additional actions of some kind. Now, if we take a step back again, and we line these apps up again, like when I was looking at Twitter a moment ago, it felt like a very unique experience. It felt kind of aligned with its brand, and it had kind of its own thing going on. But again, I line these guys up, and now I can see that they all kind of have those same UI patterns going on. They're all kind of doing the exact same thing. And the reason they all look the same is because they're all built using an SDK. So these are examples coming from Android, but the same is true if you're working in iOS. If you're building on one of those platforms, you just already have this SDK that's available to you. You grab a bunch of components out of it. Maybe you kind of tweak them a little bit, color them differently. But in general, you're using stuff that's already available to compose your application. Now, on the web, we've kind of never really had this thing. We've never had app building primitives. We've never had sort of a mobile web SDK. And I think it's time for that to change. And I really think that the way that we're going about doing this is using Polymer and web components. So my goal today is to teach you how to build mobile web applications using these new technologies. And I basically split this up into 4 parts. The very part, I'm going to show you just how you can structure the UI for your application. Then we're going to look at how you can transition from one state of your application to the next. After that, we're going to look at ways to make sure that your application is performant, because that's really crucial for a mobile application. And lastly, we're going to look at ways that you can make sure that your application runs offline, because if your mobile app doesn't run offline, then you really don't have a mobile app, right? People are oftentimes on their mobile devices when they're in low connectivity to no connectivity situations. So it's got to run offline for it to be a real compelling mobile app experience. Let's start with structure and just think about ways that we can compose the UI for our application. And really, that's the key word here, compose. What I want to do is I want to take as many pre-existing elements from the Polymer core sets and the paper sets, and I want to bolt them together to build my application. So this is the app that we're going to be working from today. It's just a really simple contacts app that I threw together. And I've tried to utilize a lot of the same patterns that I was showing in the previous successful apps that I had before. So you've got a toolbar up at the top with some icon buttons. You start scrolling around, you're going to get this sort of infinite list of content inside of there. You've got a drawer panel that you can pop out for your menu. Clicking on any one of the contacts is going to do kind of an animated transition to show you that person's contact details. I get this really nice kind of cool condensing header effect as I scroll around. And I also got a little floating action button down there in the corner. I can click that, sort of pop open another screen. These are all animating transitions that I'm using here. Now, if you've seen me talk before, you've probably seen me start off by using this element. Anytime I'm building an application, it seems like I'm always starting off with this core toolbar element, which is just a really simple container. It lays out its children using Flexbox, and it's a really good place to kind of get started with one of your screens. And because composition is really the name of the game, what I want to do first is I want to just throw some additional elements inside of here. I just want to compose the UI for my toolbar. So I've dropped a paper icon button inside of there. I've configured it with an icon attribute to give me the hamburger menu for my application. That's how I'm going to slide out my menu later. I've also dropped a div inside of here for the title of my application. Now, one of the cool things about the core toolbar is that since it uses Flexbox, I can kind of take advantage of that a little bit. There's these things called layout attributes in Polymer. And what I can do is I can actually tell the title of my toolbar that I want it to flex to take up as much space as it can inside of the toolbar. And this is a really handy trick to know because it means that I can then pin controls to the other side of my toolbar. And what I want to do here is actually add a little context menu so I can have things like settings and feedback. So to do that, I'm going to use another element called paper menu button. And the paper menu button is pretty interesting because by itself, it really doesn't do anything. Like, it's kind of useless. If you just put a paper menu button tag on the page, you get really nothing. It only really comes into its own when you start composing other elements inside of it. That's really how you unlock the potential of it. So I've got another paper icon button that I've thrown inside of here, and that's going to give the user something to click on. Then I'm going to throw in a paper dropdown. And that's going to give me this little animated rectangle thing up there, so when the menu expands, it's going to kind of like come out from the corner, span towards the center of the site. The H-align attribute that I've thrown on there is going to indicate which direction it should animate from. So here we're telling it to animate from the right edge towards the center of the screen. Lastly, I'm going to throw a core menu inside of here, and that's going to give me the actual menu items that users are going to select for my settings and feedback. Now, the cool thing here is that each of those elements that I threw inside of my paper menu button is useful on its own. I can use core menu elsewhere in my site if I need a menu. What's awesome, though, is when I start to compose these things together, I get different, interesting, complex behaviors. Now, it's also important to point out that I didn't write any CSS or JavaScript to make this happen. I just knit together these. Oh, yay! Thank you, Dimitri. These elements just know how to work together because they're app building primitives, which is awesome. Now, once I'm happy with the look of my toolbar, I can take all of this markup, and I can throw it inside of another element called core header panel. And the core header panel is just a really simple container. It's got a header section up at the top, which will hold a toolbar, content area down below. And the cool thing about the core header panel is it only really cares about managing the scroll behavior for my application. And if I put a toolbar inside of it, it's going to make sure that that toolbar stays sticky up there at the top of the document, and all my other content is just going to move underneath it. Now again, no CSS or JavaScript to make this happen. These are just smarter primitives. They know how to work together like that. Now, when someone's actually like looking at one of my contacts, I want to have this kind of like cool big shot of Adi Osmani's face, basically. And I want it to do this kind of cool animating effect. So as the person's scrolling down, it kind of collapses and sort of cross-fading with the background image. And to do that, I'm using a cousin of the core header panel called the core scroll header panel. It's basically the same component, but it adds this nice condenses attribute, and it gives me that kind of cool effect. Now, once I have sort of the different screens for my mobile site laid out in a way that I like them, I can drop all of this into another element called core drawer panel, and that's going to give me a responsive scaffold for desktop and mobile. And the way this element works is it's basically got a drawer area. Any content that I place inside of there is going to end up in my sidebar. It's got a main area. Any content that I place inside of there ends up in the primary content area. And the cool thing is this element is responsive by default. So if I'm on my desktop and I just start dragging it out, you'll see the drawer panel opens there. I can open and close it. I drag this thing out, and when I hit a certain size, this toolbar just pops out for me, which is really nice. Again, I'm not writing any breakpoints or media queries to make this happen. The element's just responsive by default, which is really nice. Now at this point, I've built the skeleton of an application. I've kind of shown you how to put the shell around everything. But what we're still missing is the lifeblood of our application. We're missing the content, right? And when I was showing these apps earlier, I mentioned that oftentimes what they're going to do is they're going to kind of do like an infinite list or sort of like a lazy load of content so the user can keep scrolling through all of their tweets or all of their albums and things like that. And we can achieve the same thing in our application using an element called core list. And core list is one of my favorite elements because I feel like it's sort of the thing that knits all the scaffolding and the content together in this way that I really love. The core list is basically a virtualized infinite list. You connect it to a data provider, and then it stamps out a template for every single instance in that data provider's array. So here I'm saying, list.data equals some array. I've got objects inside of that array. Each of those objects has a name. And inside my core list, I have a template element, and I'm just binding to each of those instances as they come in. And it gives me this really, really performant infinite list, so I can go through all of my contacts. Now, as I was building my application, I kind of came across this thing, which I'm going to share with you as a tip if you want to go out and start using core list yourself. One of the things that core list does is it recycles its children. That's actually how it's so performant. It makes a fixed set of children, and as they're moving, it's sort of like pulling them back around the other way. So if you have image tags inside of your core list, you can end up in a situation where you're basically like racing the network, and you're having stale images like fly past the screen, and then they catch up and they change, which sort of looks weird. So I found that there's an element called core image, which you can use to prevent stale images in your application. And it's pretty easy. You just drop it in here. You give it a preload attribute. And what that does is it says, hey, if I'm loading an image, I'm not going to display the stale image that perhaps was inside of here before. I'm just going to display like a little background color for you. And so what we can do now is we can actually have this cool contacts list. We can sort of race the network, and you can see the images loading in. But what you're not seeing is stale images, which is good. The other thing that I discovered as I was doing this is that it's really important to make sure to set your core list scroll target to your core header panel's scroller. I know that this is a little bit of kind of like a rough edge, but I wanted to make you guys aware of it if you're going to go out and start hacking on these things today. And basically what happens when you do this is you're telling the core list to listen to the scroll events that the core header panel is firing, and that way the two can work together in harmony. Now, there's two ways that you can go about doing this. You can either set the scroll target in JavaScript. So you could say list.scrollTarget equals headerPanel.scroller. Or you could do this with bindings if you want to be really fancy and impress your friends. You could just say scroll target equals hPanel.scroller. And this is one of those things which, again, I think it's a little bit of a rough edge. Perhaps we might be able to clean this up in the future so that you don't have to wire this up yourself. But I wanted to make you aware of it because it was like the first thing I wanted to do was put one of those lists inside of one of those fancy headers. And I needed to set up this linkage to make it all work. Now, through the beauty of composition, I've taken my list and I've thrown it inside of my scaffold, and I have this really, really cool application now. And I want to give you a quick recap of what we have inside of here. So up at the top, I've got a core toolbar. After that, paper icon button, paper menu button for my context menu. I've got a core header panel, which is controlling the scroll behavior for my whole page. I've got a core drawer panel, which gives me that sort of responsive scaffolding, so it works on desktop and mobile. And I've got a core list for my kind of like infinite content provider. Now, one thing that's really cool to do once your application has sort of like reached the state where you feel like it's kind of shaped up a little bit, is to think about ways that you could change it. And if I look at this, and I just imagine perhaps applying a little CSS to that toolbar and perhaps adding a little bit more content to the list, then I'm really not that far from something that looks a lot like Inbox, right? All the parts remain the exact same. We're just tweaking slightly the appearance of them, changing some colors, adding a little bit more content, but we've now got a very different experience. And because the core list supports variable height content, meaning that our rows don't all have to be the exact same fixed size, we can think about throwing cards inside of here. And if we do that, then we have an experience that looks kind of like G+. And again, none of my markup actually changed. I still have a core toolbar. I still have paper icon button. I still have paper menu button, header panel, drawer panel, and core list. So my markup remained the exact same. The only thing that changed was the content that I'm placing inside of it, which is pretty cool. Now, in my mind, this is the power of composition. When we have a mobile SDK that's full of these really good generic building blocks, we can build vastly different experiences just by arranging them differently and tweaking them slightly. I think that's huge. So let's go back to our contacts app for a second. We've got the basic pages kind of figured out, but I haven't really shown you how to move from one state to the next. And this is a dilemma for a lot of folks. They start building components, they get really excited, they throw them together on a page, and then they're like, how do I go from point A to point B? Basically, how do I do transitions? And this is one of those areas where we're still working on it, but I think we've got some really cool stuff in the pipeline. One of the elements that I've shown before, which I think is really awesome, I put this little experimental badge on it because it also is a little experimental, but it's so freaking cool, I like to show it, is this element called Core Animated Pages, which gives you a pluggable system for transitioning of one state of your application to the next. And basically the way this works is I put some sections inside of my Core Animated Pages. I configure its selected attribute to tell it which sections should be displaying at the time. And then I give it a transitions property, and I tell it, or sorry, transitions attribute to tell it which transitions I would like it to play as it moves from one state to the next. And with basically just that, I've wired up this really cool system for animating through different states in my application. So inside of my app, my markup kind of looks like this. I've got a whole bunch of markup that makes up every single page, and it's all kind of composed together. And so the way that I'm going to transition from one state to the next is actually take all of this markup and turn each section of my application into a custom tag. So take all that markup, make an element out of it. And then I start nesting those elements inside of Core Animated Pages. So I start with my contacts page. I drop in an info page for when you click on a contact and you actually can see their profile. So I created a little custom transition here called Fade Scale. It's on my info page as an attribute. It's also in the transitions attribute for Core Animated Pages. So now when you click on a contact, it's just going to animate up. You see Addy there. And then it goes away. And again, for the page where I add a user, right? It's basically the same thing. I nest that element inside of here. I give it a transition. I add that transition to Animated Pages transitions attribute. When I click on my floating action button now, it pops up. I can add a new user if I want, and it goes away. Now, another tip that I want to share with you is something that I came across as I was building this. Core Animated Pages does this thing where if an element is not displaying, it's going to make it display none, which can totally screw it up if it's trying to figure out its height or do anything like that. So there's a magical event here called Core Animated Pages Transition Prepare, which is the longest event name in the history of the world. But this event does magical things because it basically fires the moment that your element goes from being display none to being display block. And that means that you can then do all the work that you need to do to make sure that things are measured and have the right height and everything like that. Again, this is one of those things that I'm sure if you see this, you're like, dude, that feels like a wart. And I totally agree. I think you're right. And this is one of those things that I think I know the team is aware of, and we're going to kind of work on to see if we can actually smooth this out for people so you don't have to do all that sort of finagling yourself. But again, I wanted to make you aware of it, so if you're following along with this video or something afterwards, you want to try and implement this stuff yourself, you know how to do it. OK, so at this point, I have all the sections of my site together. They animate, they do really cool stuff, but really that's just animation, right? We're not really changing the state per se. We're missing the other half of the puzzle, which is routing. And this comes up a lot. Developers are always like, how do I do routing in Polymer? And Polymer and web components don't really have an opinion here. We're not going to tell you specifically, like, you have to do routing this way. There's really two ways that you can go about this. You can do it imperatively in JavaScript, or you can do it declaratively with an element. And so I'm going to show you both approaches, and you can kind of decide which you prefer. So if you're going the imperative route, it looks something like this. It's really as simple as just listening for a route change using some sort of routing library. Here I'm using Flatiron's director library. So when I hear a route match, I tell Core Animated Pages, hey, change whichever page is currently selected. It's pretty straightforward. Now, one of the nice things about routing in JavaScript is it gives you pretty fine-grained control if you want it. So if there's parameters in my route, I can catch those when the route matches. I can go fetch more data if I need to and give that to the page. Or I could just pass those parameters to the page itself, be like, here you go, here's the parameter that's coming in, and change, right? So some interesting stuff there. One thing that is pretty cool, which I wasn't actually using in my contacts app. I experimented with it. I think it's a really cool idea. It's something that's we're probably going to be using a lot more in the future, is this notion of lazy loading imports. So actually, let's say you've got part of your site that's 4 or 5 pages deep. Someone doesn't need all those components right away. There's this mechanism in Polymer called Polymer import, which you can use to just sort of dynamically import things. So you can add this to your router, and you can say, hey, when that route matches, that far away route, let's import some of that new stuff. Maybe throw a loading screen up during that time. And when it's ready, Polymer import gives us a callback, and we can change to that page. So that's the JavaScript way of doing it. There are also projects out there which do this in markup with elements. In particular, there's this really cool one called App Router by Eric Ringsmith. It allows you to handle URL changes and update the views in your application. It handles hash change URLs as well as HTML's history API. So you get sort of either flavor that you prefer. The other cool thing is that it actually already supports Core Animated Pages and doing lazy importing with Polymer import. But it does all that under the hood for you, so you don't have to do it yourself. So again, 2 options. It really depends on which flavor you prefer, but definitely try both out and see what you like in your application. All right, so at this point, I feel like I have my application pretty sewn up. It does all sorts of really interesting behaviors. I'm pretty stoked with the way it looks. And now it's time to focus on performance. Sorry, that's the wrong slide. Performance. There we go. I love this lady's face. Now, one of the areas that people run afoul with Polymer often is around file size, right? You'll even hear this. People will be like, Polymer's too big. It's too bloated, whatever. And there's some ways that you can mitigate this. First is this thing that I stole from Glenn Mattern, who is the creator of XGIF, which is the most important custom element ever made. Yeah, thank you. If you haven't seen XGIF, you should take some time and spend it with XGIF. So one really quick win that you can get is just conditionally loading the polyfills. You don't have to load the polyfills on every platform. There are platforms that support them. Chrome supports it, Opera supports it, Chrome for Android supports it, and hopefully very soon Firefox. So all we're doing here is we're just checking to see if the different standards are implemented on the page. If they are, we just move right along. If they're not, then we load the polyfills. So this is an easy way to save yourself quite a bit of kilobytes. Just conditionally load stuff. That's one trick. And the other thing you got to do is you got to actually pop up in the DevTools, and you got to make sure that you're inspecting your page, right? So I looked at the Contacts app after I built it and was very proud of it. I popped up in the network panel there, and I saw that I was making 109 requests, which is a lot. And I'm loading 943 kilobytes of stuff. Now, keep in mind, I have excluded the images from this network panel. So that's just my code, right? Holy crap, that's a lot. I recognize that 109 requests for some of you might be concerning. But what's going on there is, under the hood, I'm importing elements. Those elements have dependencies. They're importing their dependencies, and so on and so on. It's basically this whole sort of tree that's growing out of my application. And so to mitigate this, we created a tool called Vulcanize. And Vulcanize is a module which will actually take all of your imports, concatenate them together, smush them all together, take all your JavaScript and your CSS, mash it all into one file, and allow you to just load that one thing into your application. Now, it is available as a Node module. But if you are not so stoked about doing everything on the command line, it is also available in a grunt task and a gulp task. And for the context, the grunt task, I set it up once, and I just never thought about it again. It just runs every time I'm about to push to production, which is cool. Now, after I vulcanize, and I make sure to put my stuff on a server that supports gzip, my application is now 3 requests, which is a significant change. And I've got it down to 114 kilobytes, which is pretty nice. Now, this is all of the code for my entire application. This is all the JavaScript, all the CSS, all the HTML for my entire application, right? So I've got it down to 114K. This number gets actually even smaller, much smaller in Polymer 08, which is cool. Now, the last thing we got to do, we've got our app to the point where we're like ready to put it out there, share it with the world, but we got to make sure we're thinking about offline, right? Because again, if your app doesn't work offline, you really don't have a mobile experience. And I know that we've talked a lot about Service Worker today, so I will talk about it again here because it's so freaking awesome and I'm so excited about it. What I did was I added Service Worker to this application. Pretty straightforward. I just checked to see if Service Worker exists. If it does, I install it. Important thing to note here is that as I'm installing my Service Worker, I've got to make sure that I'm using the root scope so that I can catch any request at the sort of the top level of my application. If you nest your Service Worker inside of like a subdirectory or something like that, then it's only going to have access to the request in that scope, which sort of sucks. So you want to put it high up if you can. Inside my application, as soon as we boot up, I just try and cache as much stuff as I can. You'll notice that I'm caching the vulcanized bundle of all of my elements. So my UI is just like instantly available. I'm also caching the initial response from my data service so that there are contacts to populate my list there. And then the other thing that I did was, as the user is scrolling around, I'm dynamically caching any sort of image that has a host name from s3.amazon. So as you sort of pass through an avatar image, I call this s3 response method. And really all it's doing is it's fetching that image, it's caching it, and then it's serving it up for people. So as the user kind of uses my app, it just consumes things for them. Now, if we pop this open in Canary, and we've got Service Worker running, we start running our app. And what I'm doing here is, at first, I'm just racing to the bottom of my application. And right now, there's no Service Worker in play. And so what it's doing is loading all 300 of my contact images at once and just like hammering the crap out of the network. And you'll see it's like, oh, God, why are you doing this to me? And it finally all starts to load in. Now, let's refresh it and see what happens when Service Worker is in play. Let's turn our Wi-Fi off. Refresh the page. You'll see here over in the column that our assets are now coming from Service Worker. So I race to the bottom of my application. All those things are just coming in immediately. There's no wait on those assets. It's really cool. So, wrap up. What did we learn? For structuring your application, structuring your UI, you've got the core and the paper elements. You can compose those together to make a really awesome mobile experience. For moving from one state of your application to the next, you've got core animated pages, and you've also got imperative or declarative routing. Kind of depends on how you like to do that. For performance, conditional polyfills, and most importantly, vulcanize all the things. Use vulcanize to bundle up as much as you possibly can. It'll save you a lot. Also, consider exploring lazy loading. It's one of those things that we're still trying to figure out what's the right pattern, what's the right UX there, but it's something that I think we'll be seeing a lot more in the future, especially in the world of Polymer. Lastly, for offline, Service Worker's got your back. So as that starts to land in the various browsers, even today, experiment with it. As it starts to land in various browsers, put it in your app. It's going to be really awesome. If you want to play around with this Contacts app, it is available up on the GitHubs. It totally has a lot of bugs, so please file bug reports, but even better, submit pull requests, okay? If you want to learn more about Polymer, and you're just sort of like excited by everything that you've seen this afternoon, as Matt mentioned, we're running Polymer events all over the world. We call these Polytechnics. I see some of you wearing the shirts, which means you are cool. If you go to itshackademic.com, you can find a Polytechnic near you. If you want to participate in one, maybe you want to run your own, whatever. All the material is up there. If you set one up, please let me know. Tweet about it, whatever. It's freaking awesome, so you should all go check it out. Most importantly, polymerproject.org. As you've all been sitting here, we've actually secretly been updating the website. So there's kind of a new experience there. It's just a slight, it's just a nicer coat of paint. It's not a full-blown reboot of the site. But now it's a lot easier to find the content that you're looking for. The getting started experience is a lot easier if you just want to get up and running with Polymer. So definitely check out the site, go through some of the tutorials, and I'm looking forward to seeing all the really cool stuff that you guys build. So thanks.
Excellent, and that takes us to another coffee break. So there's a Polymer Web Components panel tomorrow morning. You'll be on that, right?
9 a.m.
So tweet your questions to Chromium Dev or add them to the moderator. Also, the previous people who were at the demo stations, they've been told their 15 minutes of fame are over and they should go away, which means we've got space for new people. So that's great. We've got one demo station for Android's WebView, another for the Web Starter Kit and Chrome DevTools, and another for mobile Chrome apps. They're the kind of stations out there with the TVs on. We've moved one of them just to make things tricky for you, but I'm told if you go out that door and keep walking, you'll eventually come to it. If you get wet, you've gone too far, you're in the swimming pool. So we'll see you back here at 4:30 for more talks, and then the after party. Cheers.
Good afternoon, folks. If you can please take your seats. We are 5 minutes to showtime. Please take your seats. Hope you're enjoying the conference, and thank you for coming.
Hey, okay, so we're ready to start the last session of the day. So come in, get a seat, get settled down. It's okay. How's everyone's brains? Are we still alive? Yeah, that's good. Wow. I got up at 4:30 this morning. I'm about to drop dead. So, okay, so it might seem that our next speaker is just Rob Dodson again, but change the hair slightly, change of wardrobe. Yeah, it's about that. And you're putting on a different accent now. Yeah?
British.
The British accent,
with
excellent.
With a weird accent on top, yeah.
So here to talk about web fundamentals, it's Rob Dodson doing a British accent.
Oddly enough, that is still a vast improvement over my introduction last year from Jake, where it was you're going to vomit information onto the audience. So you're doing good, Jake. You're learning. So my name's Matt Gaunt. I'm a developer advocate on the Google team, yeah. And I'm from London, hence the accent. I'm not Rob Dodson. And I'm going to be talking about fundamentals of mobile web development. So the way I want to frame this talk is just really briefly looking at what we've been hearing about today. So we've looked at performance from the Silk team, hitting 60 FPS all the time. Service worker, so the ability to actually offline your web page. Some of the things that are going to be coming off the back of that, background sync, push notifications, the fact that all of this needs TLS, and Polymer, like entirely new way of building your web apps. And this is actually a really exciting time to build for the web, right? Like, all of these new APIs are awesome. And then when you add all of that on what we already have with WebRTC, WebAudio, WebGL, like, this is really exciting. But if you're actually new to web development, or let's say you've been doing web development for a while, but the idea of responsive web design or developing for mobile is actually a bit scary to you, then all of these new APIs is probably going to be pretty daunting. I mean, I think it was Paul Kinlan, he did some research over the top 1,000 websites on Alexis, and I think it was over 30% didn't have a mobile viewport. And when you talk to some of these agencies and companies and developers, the thought of responsive web design is still really new to them. They don't quite understand it. And for them, if you take all of these new features, building for the web probably feels a bit like this. And you can kind of understand why. Like, you're new to it, you kind of feel like you might have your feet in the ground, or you completely don't. You're completely fresh, but this is overwhelming. And nobody wants this to happen to them, ever. And it's kind of interesting, because we're still building on top of this core set of technologies. It's still HTML, CSS, and JavaScript. We're just using it in different ways or different scenarios. And I mean, even if you take a step back from all of this, and you think about how you're going to approach these new APIs, everyone's going to do the same thing. You're going to learn about them. You're probably going to start building something using it. And then you're going to iterate on that thing, probably changing it to fit your use case or whatever it might be. And we started thinking, well, if someone actually came to us and said, well, how do I build a responsive mobile site? And they said, where do I go? What do I do? What do I learn? How do I do this? What's the approach? We kind of thought about it, and we realized we didn't have a good answer. Like, realistically, you've got specs, there's blog posts, some of them might be up to date, some of them might not. And we figured, actually, there's something that we can do here to help. So back at the very start of this year, we came up with the notion of web fundamentals. And this is basically a set of documentation which is built around use cases. So, for example, how do you build a responsive mobile site? And the idea with this is that we'd basically get someone who wanted to learn a particular thing, jump in, learn the best practices as fast as possible, and just get running with it. So, start this year, we started working on it, and we started iterating really, really fast. And we kind of got a couple of months in, and we realized we were at a point where we could release something. And we really wanted to do it as soon as possible to figure out whether we were kind of answering a question that no one was answering. So we got to a stage where, yeah, we're going to release it. And what we did was we just published the website. We made no noise because we didn't want the attention, because if it was a point where no one actually wanted this stuff and they didn't like it, then it could be like, OK, it was an experiment, we tried it, and it didn't quite pan out. And we were doing some work with RGA, who were basically designing the site for us and building it for us so we could focus on the content. And I think Phil Hawksworth kind of summed up how the launch went in this respect. Discovering that not all soft launches are equally soft, and embracing the resulting crowdsourced QA. And basically, what happened with this was the fact that we launched the site. It very quickly got picked up by Twitter, blogs, Hacker News. We got a ton of traffic that we weren't expecting. You'll also notice that it's largely me, Kinlan, and Paul Lewis are taunting him with, what do you mean? And it was really great, because what we found is that we had a GitHub link at the top to just basically encourage people to raise issues. And what we got was people complaining about typos where we'd done stupid things. Also, a lot of people complaining about the fact that we'd written it in British English. But then we also had a ton of issues around people who are actually experts in their field. So one of the scenarios is I'd written some documentation around touch. And I was writing guidance around, if you were supporting mouse and touch, you should probably be using active, hover, and focus. Good practices. You should do it. And PPK read through this documentation. He actually sat there and said, you've said people should be using hover. That's fine. But you don't mention the fact that if you touch something, when you actually let go, the hover state sticks. Now, my first thought was, WTF, why is that sticking? But the other part, I hadn't noticed it because I'd always used focus as well. So this was really handy for two reasons. One, he was an expert in the field. He just jumped in and said, actually, you need to add this in. It's best practices, and you have to tell people about this. Update the docs. It's in. Good to go. The other part is then I can go and complain to Chrome Engineering going, why are we doing this? Is there any way we can not do it? Because I can't hover on my mobile phone and do something with it. So the whole point of Web Fundamentals is its best practices, and we're still adding documentation onto it. But one of the important distinctions to make with all this documentation is its fundamental practices. So if you take something like Service Worker, that's not going to land on Web Fundamentals anytime soon, purely for the fact that it's brand spanking new, which means that there aren't best practices. I think everyone that's actually played with Service Worker has done something a little bit different, something that works for them. So to be honest, the idea of best practices and defining them right now, they don't exist. People are still figuring them out. But it's also important to point out that they're use case led. So you would never really land on Web Fundamentals and say, there's a doc on how to implement Service Worker. What it would be is how to implement offline web apps. So the main reason I say this is if someone writes an article like Jake did for App Cache, and there's a new API, then we can actually swap out. And then as time changes, APIs come and go, we can have this same document structure and change the best practices over time. And one of the main reasons we wanted this really quick feedback loop is because we were opinionated in all the docs. If you read something like the tooling section and you take a typical kind of heated discussion, shall we say, within the web development community, like Gulp versus Grunt, we just pick one. We make an informed decision out of all of the available tools, and we pick the one that we think is going to fit most use cases. Now, the main reason for this is if you're a new developer and you don't know what Gulp or Grunt is, you've never had a build process of your own, chances are you don't want the choice because you'll quickly land in this choice paralysis of everyone telling you one thing versus the other. And the flip side of this as well is if you land on the docs and you go, I disagree with you right here, chances are you know enough about this to make an informed decision anyway, so you should run with that. But there was one massive issue with what we'd done with Web Fundamentals, and that was the fact that we didn't help with building stuff. It's a set of documentation. You can still get really overwhelmed by all of this. And this is where we came up with Web Starter Kit. And the idea behind this was that all the best practices that we can actually just hand over to a developer go in here. And it's kind of interesting talking to people because they get a bit, it's difficult to define what Web Starter Kit is because we didn't necessarily do a great job of explaining it because we basically wanted to get the feedback to figure out what people wanted us to do with it. And the way I kind of think of it is, if you create a new web project, there's probably a couple of things you do by default. For me, it's always, I end up building something with Grunt and Gulp. I just start adding that in because it just takes care of a ton of tasks for me and it's good to use. I also just end up copying and pasting something from an old website in terms of the header and the footer just because I can't be bothered to remember it. It's true. But the other side of it is then I probably either define a set of styles just to make things look OK, or I just go and grab something like Bootstrap or Foundation, because ultimately I just want something that kickstarts the look and feel, and then I'll change it afterwards if I want to. So this was the aim of Web Starter Kit. So out of the box, we come with Gulp. And we do a set of tasks with this. So with your styles, we have CSS and Sass support, and we concatenate, which means just 2 files, smash them together, which means when the browser has to go and fetch your CSS, it's fetching 1 file rather than 5. It's just easier and more efficient in terms of getting everything to the browser. And we minify it so the files are actually smaller, faster to actually get to the device. And it's been really interesting because while I use Sass every day, most people actually get to a point when they're new to this, they don't want to install Ruby, they don't want to install Sass on top of that. So in the next version of Web Starter Kit, we're going to drop the requirement for Sass altogether. We're going to make it an optional thing, so by default, no Sass, but if you add it in, we'll be using Node Sass. So basically, it's an NPM module, there's no additional dependency. JavaScript, minify and concatenate again, because it's efficient. We also use JSIN out of the box. So if you're a brand new developer, I think this is probably a little bit scary because you suddenly get this thing that goes, actually, a JavaScript, you need to fix these set of issues. But it's incredibly useful. It catches really simple errors, and plus it encourages the education of best practices in JavaScript. Images is an interesting one because how many of you guys have heard of PageSpeed Insights? OK, a fair few. So PageSpeed Insights looks at your site and basically analyzes the, essentially the load time performance of your page. And one of the things it looks for is image compression. And at Google I/O, we had a device lab like we had, and we got to a point where people come up and say, I want to see my website across all the things. And we kind of, me and Pete LePage, who were manning the station, we got to a point where we said, OK, we'll put it on all these devices if you let us analyze every single part of your site and kind of point out where you could be doing better. And images, it was horrifying the number of people that just didn't minify images. And these aren't even like just pet projects. These are like proper companies spending lots of time on their mobile sites. And this thing can save you like 50, 60, 70% on just a single image. So yeah, we've just put that in there. It's best practice. And then we've also got a style guide. And the initial intention with this was that out of the box, if you just wanted to get going, you'd have a good set of styles. And then if you, over time, we'd hope that you jump in Style Guide, customize it, do whatever you want, rip bits out, put stuff in, and it would be yours. And developers actually really like this. They like the notion of splitting content from style. I don't know whether it's term Style Guide-driven development, but that's generally how people kind of refer to it. But the problem with the current version of this is it's horrible to actually change. Like, it's great. A lot of people would just jump in and use it, but tweaking it is a pain because we've got all these dependencies in Sass, and it's not all that good. I'm going to talk about what we're going to change with that in a minute. But first, there's 2 other tools that we added in to Web Starter Kit. And basically, the minute you start a development server with GulpServe, it adds in Live Reload. Now, have you seen any of my talks in the past? I friggin' love Live Reload. I still occasionally see professional web developers make a change, go into the browser, hit refresh, occasionally hit Control-Shift refresh because the cache is taking effect, and it genuinely, yeah, it drives me insane. But basically, what it does is you make a change in HTML, CSS, or JavaScript, and then it will instantly reload the page for you. And you get this really nice development workflow because you can just stay in your editor, make the changes that you want, and you immediately see them take effect. But one of the other tools that we've added in is Browser Sync. Now, Browser Sync is this weird little thing that if you have a set of devices and browsers pointing to your local development server, any interaction that you do on one of those pages gets synced across all the other devices. So this is like tapping, scrolling, you can input text, and all of them get matched across the devices. Now, this is really handy if you've got like different platforms, different browsers, different screen sizes, just sat next to you on your desk, maybe like a tablet and a couple of different versions of different OSs. This is really useful because you can just stay at your computer doing whatever you need to do and then checking all the parts of your page just from your development machine. So you don't have to muck around with each one. So that's what we have in Web Starter Kit today. And I kind of mentioned that we're going to drop Sass support. That seems to be quite a big one that people want to change. But the other one was this style guide. And the biggest issue with this that I see is the fact that A, it's super unfriendly, and B, we get to this point where it was getting unmanageable, even for us. So we needed to properly strip it back and just figure out, OK, we need to undo all this dependency. And we got to a point where like, we should just start again. Because basically, it's a style guide that we inherited from Web Fundamentals. And we got to this point where we realized that actually a lot of the people using Web Starter Kit, they also had a lot of requirements around browser support. A lot of these developers were at a point where they needed to support older browsers. And then we kind of realized, well, that's normally a gating factor on Polymer. And we figured, well, if we're going to do a style guide, we could use the material design spec and bring it to some of the older browsers. So this is like a super early cut of what we currently have. And essentially, it's just a material design-inspired style guide. It's got the usual things that you'd expect, typography, lists, of course. I really like this bit because it's like a rainbow. Obviously, because you've got the material design spec, you have to have the buttons with all the ripples. My personal favorite is the text field, and I just love the animations with the underlines. And then when you get to the next one, the label goes up. And we just basically have a set of default boiler components. But the really nice thing with this is behind the hood, it's so much easier than what we had before. You can literally jump into this and understand that if you wanted to change something with the buttons, I'm breaking things. Yeah, if you wanted to just change one of the buttons, you can actually just find it really clearly in this new structure because it's literally like button folder, button.sas. Easy. But it's really interesting, in the process of this, what we realized is that the material spec isn't necessarily geared towards standard web design. Like if you think of a stereotypical website, header, set of links, that's pretty much web design 101. I guarantee all of you have implemented a website exactly like that at some point in your life. And yeah, there wasn't anything in the material spec that was just did this. So we've been working with the material design team just kind of like, what does this pattern look like in material design? And they've been great because something simple as this, we've just got a couple of variations. So just bog standard kind of bar with the links on the right, centered horizontal navigation where we've got kind of like the content embedded within it. If you look at the material design spec, you also have like static navigation, which is where you have the left nav bar hidden away on mobile, but then it's constantly pulled out when you're on desktop. And the idea with all of this is then you obviously get back into the standard hamburger menu with the side nav. But it's been interesting, the fact that we actually hit this problem where it wasn't built for content sites. So it's been an interesting kind of process getting to that point. And I wouldn't be surprised if we hit another couple of points like this where actually we need to work with the material design team to actually bring in these new kind of design patterns. And we've been really fortunate because we have a couple of Chrome UX designers in London, and they happen to unfortunately sit near us, so we can basically tempt them in to come and help us with things. And Hannah and Ed have been great because they took one look at our style guide and they probably died a little bit inside. We're like, what are you doing? But Hannah's put together this amazing mock, which is basically how she thinks the style guide will be used. So rather than have like checkboxes and buttons, that should really be grouped into a form. That's how it's going to be used. And I very roughly started putting this together, hence the bacon ipsum. But it's an interesting point. The fact that style guides should be kind of getting to this point where it helps you and encourages you to use it in a particular way. So we're going to be including things like just copy to clipboard so you don't have to worry about finding a particular snippet hidden away somewhere else. And that brings us on to this iterate step. Because Web Fundamentals should help you with learning. Web Starter Kit should help you with building and starting a brand new project. And the minute you get to iterating, this is where DevTools basically comes into its own. And I guarantee all of you probably have opened up DevTools. So the DevTools team have been making a ton of changes that basically help you with mobile web development, as well as figure out what the browser's doing. So the first one is this device mode, which is basically this blue mobile icon on the top left. Now, the first thing to call out are these bars just above where the website is. These are basically an indication of just where your media queries are on the page. Now, the really useful thing with this, if you get to a point where you've got a ton of media queries in your page, perhaps you're doing it by component, you can actually realize where you might have conflicting media queries and things might get a bit messy. And there's a good chance that there might be something wrong within those patches because you've got so many things overlapping. The other part of this that you've probably all seen before, just put in a nicer way, is this device selection, where basically you select a particular device, and it will set the width and height of that particular device, including the screen density, which is really nice because you get to this point where if you're using responsive images, you'll actually see all of it. But one of my particular favorites is this new network throttling. Now, what this is you can basically select a particular network type that you want to emulate within your browser, and then it will just apply it for you. So here, if I select 2G, do a refresh of the page, and this is a pretty solid indication that I need to do something with that image at the top, because that's kind of painful for a 2G user. But the nice thing with this is actually embedded in DevTools. So this is the point where you're already trying different things out. Before, you'd have to pull out a different application. Depending on which one you use, sometimes they're actually a bit fiddly to work. I actually once managed nearly to lock myself out of my machine because I'd applied it to my entire machine to actually have the slowest network connection I could think of. At that point, my machine decided to lock, and then also decided it needed to phone home to make sure that I was actually still legitimately working here. I can't remember how I got out of it, but it was not a pleasant experience, I can tell you. But at least with this, it's just built straight in, and it's really easy to change. So the other area of a ton of changes in Timeline, in DevTools, is Timeline. So if I just refresh the page, what I've got is just essentially a timeline of what the current page rendering is doing. And we always get this typical waterfall of what the browser's done. But one of the first new additions is Paint Profiler. So here I've just selected the paint on the page, and it looks fairly hefty. But down below, what you've got is this new Paint Profiler tab. Now, what this is along the left, we have a set of draw commands. This is basically what the browser's doing to paint these particular things to the screen. So as I scroll down, we should get to a point where you can actually start to see where these paint commands are actually painting stuff on the page. Along the top here, we also have a representation of how each one of those commands have happened and how long they took to actually occur. And then right in the center, we have this big bad boy, which is basically what the browser's actually painted. Now, the really nice thing with this is if I select a small chunk of the instructions from the paint, as I start to scrub along, you can actually see what the browser's painting and how it's painting it. So if you ever get to a point where you've got this huge, long paint, and actually it's really causing you issues, this is the first time you can actually really dig down into what the browser's doing under the hood. But admittedly, you have to have an issue that warrants that huge paint. But what happens if the browser could tell you, well, this paint has happened, and then also give you an idea of why the hell it's actually done it? So if I go to our trusty Chrome developer website, I should hopefully find a paint that looks a little something like that. Now, I genuinely find Timeline confusing at the best of times, and I also find it even more confusing to figure out what the browser's doing when it decides to do it. So when I see a paint like this, where there's just a blue block, there's a bit of me that questions why it's painting a blue block when it's probably always been there. So in the Paint Profiler, this is all you'd get. But if you move to details, right down the bottom, we have this style invalidations. And basically, what this is telling you now is the fact that it's this particular element on the page that has been painted, and the reason why it's been painted is animation. Now, this is really nice because before you'd run a timeline, you'd have to be a master of the dark art like Mr. Paul Lewis, understand what the hell is going on because you know what the browser's doing under the hood. This is the first time DevTools is actually going, I've painted, here's the reason why I've done it. And it's kind of nice with this demo because I can actually click on this and you see styles being added. So you can actually see the style invalidation and where the paint's happened. But still thinking along those lines, if we go back to another part of this timeline, you can see we've got this recalculate and this layout. Now again, not being a master of the dark art of timeline, I genuinely still don't know why that would happen. So if I scroll down to the bottom of this layout, we've also got layout invalidations. And this is another scenario where DevTools is actually saying, this particular thing has happened, here's why. So here we can actually get a stack trace that's basically saying cds.card.callProperties is resulting in this particular layout happening. And it also has a list of the components that's basically being laid out as a result of this. Now this is really useful because before you were kind of left high and dry to figure out what was going on. Now you can actually get a bit more of an indication of where your code is resulting in the browsers doing some kind of action. Now, I don't know about you, but there comes a point where if I'm looking at a waterfall, it kind of just becomes a lot of pretty colored bricks. And the thing that really kind of confuses me is if I take something like this, I kind of see that the layout and the recalc style have happened, and this yellow block kind of tells me that it's my JavaScript that's done something. But this isn't a really good, clear picture of what's happening, why it's happening, and how long each piece is taking. It's just a colored brick. And this is where the new flame chart viewer comes in. And basically, as you zoom in, you get a bit of a better picture as to animation frame took this amount of time. Within that, your JavaScript was actually the majority of the time spent in it. And something inside this resulted in recalculate style and a layout. Now, it's exactly the same information, but it's just displayed in a different way. But the nice thing with this is you can actually start seeing a bit more of a cause and effect. But admittedly, this still doesn't actually help me figure out what is it in cds.min that caused calculate style followed by a layout. So wouldn't it be kind of handy if you could actually figure out a bit more about what's going on? And this is where JS Profiler comes in. So if I go back and repeat this same thing. So here I've now enabled the JS Profiler along the top. If I go and find this animation frame again, some of you may have noticed that the thing looks suddenly a lot longer and scarier now. But here we've got the animation frame fired, followed by that exact same function call of something in our JavaScript. But you notice a couple of bars in, and suddenly we've got this cds.card.expand, followed by cds.card collect properties. And it's that method that's actually resulted in the recalc style and the layout. So this is really useful because now you're actually at a point where you don't have this magical black box of you did something and now I did something too. It actually goes, well, you did some stuff, this was all fine. The minute you hit this method, this is what happened. So it's actually starting to surface up a ton of stuff. Yeah, there we go. And this is really nice because normally you'd get to this point where actually you'd realize maybe you measured offset top or something. But unless you know there's a problem, it's pretty hard to diagnose that. Whereas this goes, this method, something here does something fishy. And that at least reduces your entire search down to a much smaller surface area to try and figure it out. So one of the other new cool things, again, still in the vein of DevTools surfacing information, is you'll notice in the Flame Viewer, we get to this point where we have these kind of weird bobbly things along the top with some kind of time in it. Now, what these represent are frames. Admittedly, my website is awful because by the looks of those frames, it's definitely not hitting 60 FPS. But we'll look past that just for a minute. But when you actually click on one of these frames, you get this layers panel down the bottom. Now, how many of you guys are happy when I say the notion of composite layers? Oh, wow. So Jake actually gave an amazing analogy of this, of if you had a wall and you had to paint a stickman moving from left to right, you could draw with a marker on the wall a stickman, paint over it, draw the stickman again, paint over it, and repeat until you get to your final destination. What you could do is have transparent plastic on wheels, draw the stickman once, and then just move it across the wall. And the idea of a composite layer is you basically draw everything on a transparent layer to move across. And it's more efficient. It just loads it in the GPU, and you're good to go. So what this layers panel does is it actually tells you everything that's been promoted to a layer. Whereas before, it was kind of, you'd have some orange borders that might tell you. Now it's really explicit. Now, the other side of this as well is you can see on the right-hand side, yeah, it's your right-hand side, composite reasons. Now, this is great because sometimes you get to a point where something would be promoted to a layer you didn't mean it to. Other times you want it to be promoted to a layer, this tells you it's not. But if you have something and you don't know quite why it's being promoted to a layer like this thing, composite reasons will tell you why it's made that decision. So in this case, overlaps with other composite content cannot be squashed since this layer scrolls with respect to the squashing layer. I didn't intend for this to happen. Ironically, this causes a bug on Android for Chrome where when you scroll it off the screen, it doesn't become a layer anymore and things go a bit funky. But this is actually the first time I've debugged it because you can actually see all the layers. And the nice thing with this is as you start clicking through each of the frames, you should start seeing the layers move. But because I'm so janktastic, of course you don't see the frames. But if it was a good demo, it would have worked. But again, the nice thing with the composite reasons is, again, DevTools is actually explaining what it's done and why it's done it. Now, as good speaker, I have backups to all of these because when you have Paul Irish telling you don't update Canary, it'll break your demos, you have videos for backups. So yeah, that's what we're doing on the Chrome team. Web Fundamentals to help you with learning, Web Starter Kit to help you build new projects, and DevTools is adding a ton of new features to help you with mobile web development, as well as understanding what the browser's doing. So that way, when you hit this problem of not hitting 60 FPS, it's actually easier for you to diagnose the problem. So thank you very much for listening. Hope it's been useful. Cheers.
Thank you very much, Matt, if that is your real name, which it is. Well, we are hurtling fast towards the beer time, which is great. But before that, we do have a closing keynote from the Senior Vice President of Android, Chrome, and Apps. I mean, Google is a super modern company with an extremely flat structure, yet this guy is my boss's 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 boss. Which gives you an impression of how low down I am. With that many levels between us, I'm kind of more worried about like the effect of chaos theory. Like, you know, if you step on a butterfly, I might get fired or promoted. I will find you a butterfly. We can do this test. A big welcome to the stage, Sundar Pichai.
Hello, everyone. It's good to be here. Sorry, I guess I forgot to turn off my phone. But the good thing is in L, we have this nice feature by which I can put stuff in Do Not Disturb. So I think I'm good. Or so I think. There you go. It's good to be here. Thanks. For me, when I first heard about this forum, I was very excited. It's really nice that we have a way to connect with the web developer community. The web itself is something near and dear to my heart. I wouldn't have joined Google. I was outside Google when I saw Gmail getting launched at that time, and the fact you could write an application like Gmail in the web, was an important realization for me for how important a role the web platform was going to play in computing. And we've come a long way, but it's really exciting for me to see all of you here and a way for us to connect with the developer community. The web is at an important and inflection point, and I think something in which it will play an even stronger role over time. When I look at mobile, it's a very, very profound shift. A few months ago, I had gone back to India to launch Android One, and seeing people come and get their first ever computing experience on a smartphone is really amazing. The PC throughout its life cycle probably reached about 1.6 to 1.7 billion users. Mobile is already beyond that, just smartphones. And in a lifetime, for sure, it's going to be the first computing platform which will nearly reach the entire world. So we expect over 5 billion people, in the next few years to have a smartphone connected. And so to me, we haven't lived through a phase in which computing reaches that many people. So it's a really profound shift. And so I'm excited to see the next wave and the role that the web will play in that paradigm. We are seeing great traction. We are deeply committed to this area. We are investing a lot. You probably heard from the team. Chrome on mobile is at over 400 million users. And so for me, we feel a huge sense of responsibility in terms of making sure the web evolves well on mobile. And the web has such unique properties and things which make it particularly good at what it does. And I don't think we've seen anything quite like it again. So when I look at how, as a developer, you can write something, it could be the long tail, you could reach your users, people can search for it, people can find a link in a social network, get to your website. And the model is simple, it's universal, and it just works. There's no installs, downloads, nothing to deal with. And that model, I think is something really important in computing, and it's important to preserve that. And to me, so I'm excited to see what all we can do with mobile. As a platform, the work I've seen around, be it focused on performance around getting 60 frames per second, be it the work around offline with service workers, the Polymer stuff, so that you can build great design with material design, etc., really excites me. And so hopefully we can continue pushing all of that. And especially when I use the L release, for me, I can see how interestingly apps and the web and the browser can all come together. And we are in early stages of this. The lines are blurring. And so if you fast forward a few years, I think hopefully we surprise users and all of us with the way these things evolve. And I think it's important to keep an open mind. And so don't have much to say other than this is an incredible time. For me, the web wouldn't be where it is without developers like you. That's the crux of it. In the end, people building great applications which really advance the state of computing, what users can do with their devices. And given what I talked about earlier as an opportunity to reach 5 billion users, I think it's one of the biggest opportunities all of us will see in our lifetime in computing. So hopefully you all take advantage of that. And with that, I want to say thank you all for coming. And you guys have a day 2 tomorrow. So good luck, and I'll see you guys soon.
Well, that's day 1 done. Yeah, that's my responsibilities done for today. That's a lie. I need to sort out all the panels for tomorrow. So if you want to tweet questions about anything you've heard today, do that. That makes my job easier. But for now, go forth, leave this forsaken place, journey to the land of through that door over there, where the beer roams freely, the wine is plentiful, and soft drinks are also there. You can have those as well, wherever it's up to you. Have a great evening. Do tweet us with questions, and we'll see you back here at 9:30 tomorrow. Bye.